So we are now live on YouTube.
Oh, I see.
The program is updated and there may be some delay in you seeing the program because of caching issues. But this is being, so people have been warned through Slack and in the program. So Ning Ning is not here yet. Tu disseste? Sim. São. Peraí, David, desculpa lá. Eu aqui editar coisas, editar HTML e afins. Norbert, I've just included the 2 other papers
Yes, on the website. Yeah, I've seen that.
on the website and here as well.
Oh yeah, good. Okay.
Okay. But the improving knowledge graph, the author is not here yet.
Yeah.
And I don't know if she will be able to.
Yeah. Mm-hmm. Yeah.
Norbert, so we in this session had 1 paper less, and if that author doesn't show up, we will have just the right number of papers in this session.
Okay. Mm-hmm.
Good. So we're ready when you are to give you control.
Yeah. How was it the other mornings? Did you start on time? Because I see we only have 32 people or so. What's the normal audience?
It's the social event and the banquet defect.
Okay, I see. I also had my social event yesterday evening. But nevertheless, I have the advantage of being 1 hour ahead of you. So
yeah, that's right.
the effect is not so strong. Let's give it 2 more minutes and then we can.
Sure. I have to start the A and the C, and so like juggling.
Okay, I see. Okay, I think we should start now. I was hoping for 40 people, but nevertheless, I think we should start.
We have 47 with all of us, counting all of us.
Yeah. If you
but yeah.
Okay, so should I just start talking? You have to switch something.
No, I've stopped sharing, and now you can introduce the first author and the session. So the floor is yours.
Okay, thank you. Well, good morning, everybody. My name is Norbert Fuhr, and I will be chairing this session, a very interesting one. If you look at the program, as of now, we have 2 more papers than in the original plan, but the original plan had 1 talk less than the other session. So overall, it will be at most 1 talk more. Also, one of the authors hasn't shown up already. We will see. And nevertheless, this is a very interesting session with some quite interesting papers, among them the Best Paper Award. But I will come to that later. We will start now with Hans Witschel on his talk on KVGR, a graph-based interface for explorative sequential question answering on heterogeneous information sources. Hans, the floor is yours.
Okay, thank you very much, and good morning, everyone. I'm sharing my screen, yes, and hope that you can see my slides. Can you?
Yes, we can.
Okay, thank you for the feedback. Yes, so welcome to this talk about what we have termed explorative sequential question answering. Actually, when you read literature about sequential question answering, what people are assuming is that maybe not so likely that you come with a giant complex question and access your question answering system, ask that giant question, get an answer and then quit, but it's considered more likely that you take your question and break it down into several smaller bits that you would ask in a more conversational style. But still, these approaches or these papers assume that you have something rather clear in your mind, that you have some questions that you want to have an answer for. And when we've termed it explorative sequential question answering, we tend to assume that you don't, that you maybe come with only a rough idea of wanting to get to know a certain domain, and maybe you have a rough question, but all the other questions, they will come as you get answers. So we assume that each answer triggers the next question. And we've built 2 knowledge graphs so far. One is in the medical domain. So let me give you an example from that domain. And assuming maybe you have a patient, a child sitting in front of you describing a symptom, maybe you want to start accessing your knowledge base by asking which diseases would cause this particular symptom. And yeah, then you get maybe several diseases and you would like to start differentiating. So maybe your next question would be, which other symptoms do these have? So you can ask your patient and try to figure out which of the diseases would be the most likely one. Maybe also because it's a child, you may want to ask which of the diseases are typical for children. And once you've narrowed down on 1 or 2 diseases, you maybe want to know about diagnostic tests and then maybe treatments and so on. And yeah, what you can observe is, although this might be in this domain a rather standard procedure for asking questions, there might be deviations depending on the situation. So if you don't have a child but an elderly person, maybe you ask different questions. But also maybe depends on the answers that you get. So if you get many diseases after the first question, then maybe your further procedure and the questions you ask will be different than if you get just 1 or 2. So yeah, one thing that you always have to deal with, so these are challenges that I'm listing now, in such a scenario would be context. So for instance, if we ask, do all these have or this particular one, the system needs to be able to figure out what we mean. And on the other hand, if we have, yeah, as I said, questions that depend on the previous answers, yeah, the information needs to start evolving, and the first questions, maybe this is not the best example here, but often we would see that we have rather simple questions, or might be even fuzzy questions, which in turn have rather complex answers. So if we look at this example, if you have a few diseases after the first question and you ask which other symptoms do all these have, you might get quite a large list of symptoms associated to your diseases. And we can also call that a moderate level of complexity in your answer. So we want to support, yeah, maybe most importantly, complex answers. How do we manage to give people an overview when they ask simple but fuzzy questions and get complex answers? How can we summarize the information best? And also maybe allow behavior like zooming in and out of complex answers. And of course, how can we keep track of context? And our proposal is, we believe we can best do this by, of course, still letting people ask their questions in natural language, because it's the most natural way to do that. But maybe as opposed to many other question answering systems, our suggestion would be, in order to deal with the complexity, to give the answers in the form of visualizations of subgraphs of our knowledge graph. So we're working with structured knowledge base, more precisely a knowledge graph, and so we suggest to visualize this parts of this graph that can be seen as an answer. And we can also use this graph then to allow the user to define the context or focus for our next question. So the user can select some nodes and say, okay, I want to continue with these. So why would that be better than giving answers in natural language? Might be a question that you can ask. So what we believe is, let's take our example again. Maybe you've asked for a symptom and you got two diseases, diabetes type 1 and type 2 in this example. Not sure whether you can read this on the screen. And then maybe your next question is, what other symptoms do they have? And you see here, there are a number of symptoms. So this is a little bit of complexity here. But what the picture tells you right away is what are the shared symptoms and what are the unique symptoms to each of the two diseases. So I believe you can very quickly grasp this by simply looking at it and use it for differentiating. If, of course, I can give you this also in textual form, so I could say diabetes type 1 has symptoms A, B, C, D, and diabetes type 2 has these symptoms, and then you can figure out for yourself which are shared and which are unique. We also believe, as maybe result sets grow a little bit larger, you can see things in the graph that are maybe not so easy to grasp from textual answers, such as what nodes are important because they have many connections, or maybe you start seeing things like clusters. So as a bottom line, we believe a picture can say more than 1,000 words here. And what about the context? Why is it maybe a good idea to use the graph to define your context? So of course, it makes it easier for us to know what someone refers to if people select something explicitly in the graph. And on the other hand, we believe, and of course this was subject to investigation, that it's maybe also helpful for the user to define where the journey is going next by saying, okay, well, let's focus on these nodes. So I don't want to spend much time on telling how we implemented this. It was a fairly simple approach, and the focus was really on the interaction mechanism that I will sketch in a second. We've built knowledge graphs for two domains. The one that was used in the experiments of the paper was from the book domain, so information about books, authors, topics, reviews of the books, institutions of the authors, and stuff like that. And the second graph that I will show you in a second was built for the medical domain. Actually, what I show you is a sandbox graph, and we're still currently building up a large graph. They are always coming from multiple sources in different formats, XML, HTML, Sparkle endpoints, and so on. And we integrate all that into one Neo4j graph database. And let me explain now what is the core of this interaction concept. So we believe a natural entry point would be to type in some keywords, because yeah, this is kind of your initial fuzzy information need that you articulate with some keywords, which gives you a subgraph that we call G0. And then it's really very simple. Given any currently visible subgraph of the knowledge graph, GI, you can go to the next one, GI+1, by either doing some standard graph interaction, for instance, expanding or collapsing nodes, or yeah, now this is the thing, select one or multiple nodes and then ask a question about these nodes. Okay, I'm trying to give you a demo now, hope it works. Can you see the browser?
Yes, yes.
Yes, okay. So this is what it looks like. You see here the types of nodes that are in the graph, things like treatment or disease. And as I said, that the entry point could be a keyword search. So maybe our patient is reporting fatigue as a symptom. And when I search for the keyword, I get a graph of disconnected nodes in the first place. There's an historical case, which I don't want to focus on. And now I can select the symptom, which is what I want to study. And down here, now the system asks me, what do you want to know about this symptom? So maybe I can ask which diseases cause the symptom. And then we will see that we have these two candidates, diabetes type 1 and 2. Make it a bit bigger so you can see it better. And then now, yeah, this is something that was not available in the version that we tested with our users. But what I can do now is I can say which other symptoms do these diseases have without selecting anything. This is something that we learned from our tests, that people like this magic, so that even without selecting the diseases, the system can guess that if there are these two diseases on the screen, if I say these diseases would refer to these two. Now you see pretty much what was on the slide earlier. So you see the two diseases with their shared and unique symptoms. Now the diseases are red, before they were yellow, but it's the same thing. Yeah, and then I can continue asking, for instance, a filter question. Maybe I say which of these diseases are typical for children. So maybe I go back to the standard way of selecting nodes. And then I see, okay, I only have diabetes type 1, which is typical for children. And then maybe I would say, okay, which diagnostic tests, or you can replace that also with treatments, do we have for this one? I can also use this one or it, and it will understand that. There's one more thing that I want to describe. It was not particularly, it's not a particularly good example in the medical domain, but sometimes we have what we call elliptical queries, so that people would ask something like which contraindications, you will see in a minute what this refers to, are known around this disease. And so I select diabetes again. And now what you see is that I asked for contraindications, and insulin allergy is a contraindication, but it's not directly related to the disease, but it's rather related to a treatment, insulin, that treats the disease. So we can also ask queries where we leave something out in the middle. This is, we found that more frequently in the book domain, which we used for our experiments, where, for instance, you would ask which authors have written about this topic, where the thing in the middle, like insulin here, would be the books that the authors have written. So the authors write books, and the books are about topic. Let me go back to the slides. I will speak a little bit more time, but so I will simply skip. I think it's not so. You can read how we did it in the paper. It's fairly simplistic because it was also not the main goal, but the main goal was really to understand this interaction mechanism that I showed you just now. So let me report directly what we learned in our evaluation. We had 5 people. Okay, admittedly, it could have been more. And also there was a slight bias. We have to admit that they were all technical people. So maybe in the back of their mind was going on, how did they implement this? And how should I behave to, to make it not work? Or I don't know, but actually they behaved quite like ordinary people, I would say. And what did we do? So we first gave them a demo, just as I did with you. And then we had prepared some information needs. So in order to make the sessions a bit more comparable, we told them, okay, let's start with a topic. In our case, it was criminal law. And yeah, then we told them, okay, we want to know, for instance, which authors have written about this topic. And we want to know where they work, in which institutions, and so on. So these were kind of needs that we had prepared, and we asked them to use the system in the way that we had shown them to satisfy these needs. And yeah, usually they had to select the context, some notes, before asking a question. And we had prepared one information need, the last one, that was really complex. So they had to break it down into several steps. And we were, of course, also interested whether they would be able to do that. We had a script for the evaluation. We also asked for intermediate feedback, and we offered help once they got really stuck. Okay, what did we learn? We learned that sometimes we could improve our grammar. This was less interesting, maybe. What was more interesting, so we observed whether they would be able to learn this principle of having to select the context and then asking a question, and maybe also breaking things down into several steps, which was required for most queries. And you see there a rather steep learning curve. So 2 people had learned this after the demo already, so they did it without help. 3 people needed the second information need, Q2, to learn it, and then for Q3 and Q4 they could do it. Well, the 2 people who failed on Q5, they actually told us later that they simply hadn't understood our information need. So it was more our fault for not being able to explain that well enough. And now they said if it had been their own information need, it wouldn't have been a problem to break it down. Now we can believe this or not. So maybe we have to just be careful here with the interpretation. For context selection, the question was, do they remember? Yes, I will finish within hopefully 1 minute. Do they remember that they have to select nodes before asking questions? You can see a flatter learning curve there, but most people learned it. One person had problems until the end. And what they said, yes, this is intuitive, but you have to remember to do it. And so we built in this magic that I showed you, that the system makes assumptions. For elliptical queries, I told you about this example with the books, show me all authors who have written about this topic. The result would show not only authors in the topic, but also the books in between. So it would show which books these authors have written. And we asked the people, do you find this useful? And they said, yes. Although we haven't asked for it, we find it very useful to see the books and also to see which authors have written many books. So for explorative purposes, it's good to see many relationships. They liked the way the system understood their questions. They particularly liked to see how things belong together, to see the relationships in the graph. And we observed that it seems easy to learn. The improvements that they suggested show habits from using web search engines, I guess. So they said, oh, it's so much typing for the questions. So we could have a speech interface, or maybe they asked for keyword queries. And yeah, okay, ranked result lists when graphs or results grow larger was also something that they asked for. But they always said, please keep the graph and only do this in addition. So to cut it very short, I think with 3 things that we learned, we can kind of carefully conclude that our hypothesis is correct. So it seems easy to learn. People like the interaction mechanism as such. They like to see the relationships, and they also found it intuitive to select a focus for the next question. What we need to do in the future is to better represent node scores or node importance, especially when we have large results. But this is one piece of future work. Of course, we also want to test with more users once we've built this medical graph completely, and we are implementing a few further improvements like query recommendation for lazy typers and stuff like that. Okay, thank you, and sorry for taking a bit longer.
Okay, thank you, Hans. Now we have time for one or two questions. So we have in the Q&A already one question from Ian de Vries. Great presentation and brave with live demo. And he asks, would it be useful to include prediction of the next query and show a larger part of the graph, perhaps with transparency for the predicted nodes and links?
That actually sounds like a very good idea. So what I said one last or one idea of future work that we're currently working on. Yes, we're trying to predict the next query.
Mm-hmm.
We haven't thought of actually also predicting its result. This is how I interpret the question, that we would not only predict what the next question could be, but maybe also show a preview of its result. And I think, yes, so maybe it depends on how big the current result already is, or the current subgraph. If it's fairly small, maybe showing a bit more context that might likely be relevant for the next questions would be very helpful. Yeah, that's a nice idea.
Okay. Nobody has raised. Oh yeah, here. Just one suggestion from Ying-Sang Liu. Just one suggestion regarding the user study. It would be useful to consider users with different levels of visual literacy or domain knowledge when interacting with the system.
Yes, yeah, of course. Yeah. So, I mean, what we're planning to do or need to do when we've built this medical graph is that we're going to try it out with some physicians. I believe domain knowledge, I'm not sure how much variation in domain knowledge we need to account for, because if we use this with physicians, for instance, I guess we should assume a certain level of domain knowledge. But of course, there might be novices and more experienced physicians. So yes, that should also be something that we look into. And of course, yeah, visual literacy. I think, yeah, if we take a random sample of physicians, then probably we will have we'll have different types of people with different types of visual preferences and literacy, hopefully.
Mm-hmm. Okay, thank you very much, Hans. Okay, now we go on to the next talk, which is a talk based on a journal paper in the ECIR journal, and the presentation is given by Jimmy. Jimmy, yep. The floor is yours. Go ahead.
Thanks, Norbert. Hi, everyone. Can you see my screen?
Yes, we can.
Okay. Thank you. So today I'm going to talk about a paper that we work with title Payoffs and Pitfall using knowledge base for consumer health search. So the domain of my talk today is about consumer health search. And with consumer health search, we refer to the activity where common people, like most of us, searching the web for health advice, which is a very common activity. And the problem that we want to address in this talk is that people are not effective in formulating health search queries. They often submit underspecified queries, ambiguous queries based on observation of symptoms. On the other end, current search engine struggles to retrieve search results that are relevant to this such underspecified queries. To better elaborate the problem with formatting health queries, imagine if we observe this condition. We have no idea what it is, and therefore we decide to Google this condition. How should we Google this? A study on consumer health search queries found that for this exhibit, people often submit queries such as swollen legs. A more effective queries for this condition should be edema, which is the precise medical term for this condition. So the question becomes, how can we convert these initial queries into a better one? In this study, we investigate query reformulation methods to improve the effectiveness of initial queries. A previous study by Plovnik and Cheng showed that manual replacing layman terms with medical terms lead to a more accurate search results. We therefore question, can this improvement be done automatically? To automatically improve health queries, we investigate the entity query feature expansion model that is known to be effective in clarifying user query by adding related entities from knowledge base such as Wikipedia. Hence, we investigate whether this AQFE can be more implemented to improve the effectiveness of consumer health search queries. The AQFE model is formally defined as the sum of expansion term F, expansion terms across entity dimension M to all knowledge-based entity features F. In this study, we consider 3 knowledge bases. First is the Wikipedia. Second is the UMLS, which is a compendium of thesauri in medical domain. And the last one is consumer health vocabulary, or we abbreviate as CSV. For Wikipedia, we extracted the title, the categories, the links, aliases, and body in each Wikipedia page to the feature of an entity in our Wikipedia knowledge bases. For UMLS and CSV, we exploited the title, the aliases, the body, the parent, and related entities as features of an entity in UMLS and CSV knowledge bases. In this study, we divided the implementation of AQFE into 5 consecutive steps. Each step involves multiple choices. The first step is knowledge-based construction. In this step, we consider which entities should be included in each knowledge base. In the second step is entity mention extraction, where we extract entity mention from the user query. For example, here we consider if the user type in headache caused by high blood pressure, we extract entities such as headache caused by high blood pressure, headache, high pressure, and so on. Third step is entity mapping, where we map the extracted entity mention to entities in the knowledge base. Fourth, after we have the related entities in the knowledge base, we investigate the best source of expansion terms from the knowledge base to be added to the initial queries. And last one, we consider relevance feedback to further improve the effectiveness of the already expanded queries. Now, for experiment, in this study, we used the CLAY 2016 health task, which consists of 300 user queries, and the corpus that we use is the CLUWeb 12b. For evaluation, we used NDGG at 10, BPREF, and RBP at 10. The effectiveness of each choice was measured sequentially and used to determine the subsequent steps settings. The best settings of each choice was determined based on average results for all queries. However, if there's a discrepancy between the 3 measures that we use, then we check results from the high coverage queries. What are the high coverage queries? I will explain about that one a bit later. Let's start with choice for step 1, which is the knowledge-based construction. In this step, for Wikipedia, we consider 4 options. First, we consider every Wikipedia pages. So it means like every each pages will become one entity in this knowledge-based Wikipedia knowledge base. And the second option for Wikipedia is to include only pages containing medical info box type. The third one is type links, where we consider pages that contains info box types and links to medical terminologies. And last one, we include only pages with title matching a UMLS entity. For UMLS and CSV knowledge bases, we consider using all entities and only entities that are related to symptoms, diagnostic, tests, and treatments. Our initial results shows that the expanded query retrieved many unjudged documents, As shown in here, the majority of baseline queries without expansion terms retrieve less than 2 unjudged documents in the top 10. In contrast, the majority of expanded queries retrieve more than 5 unjudged documents in the top 10. This is a problem. Like commonly, unjudged documents are regarded as not relevant to the query. To enable a more fair comparison, we therefore consider high coverage queries, which on average across all considered choices have a maximum of 2 unjudged documents. Now let's take a look at results from all choices that we consider in step 1. These plots shows effectiveness of queries expanded using Wikipedia knowledge bases. The dark colored bar on the bottom here are results from all queries, and the light colored bars are the average of high coverage queries. For comparison, the effectiveness of baseline queries are displayed as dashed horizontal lines. Like this one is baseline from all queries, and this one is baseline from high coverage queries. Based on these 3 plots, we see that option type links, this one perform better than other options. And this is consistent across all other measures. In bpref, the WC type links also the best. In RWPA10, WC type links is also the best for Wikipedia knowledge bases. And therefore, we use WC type links as for the subsequent experiment. Then we check the same then we do the similar analysis for queries expanded using UMLS and CSV knowledge bases. Results show that UCO is the best for UMLS-based queries, and CCMAT is the best for CSV-based queries. For choice 2, we consider 4 entity extraction methods. 1, we consider all uni, bi, and trigrams. 2nd, we consider only grams that match CSV entities. 3rd, we consider grams that match UMLS. And finally, we consider grams that match to UMLS using MetaMap. Results shows that WME CSV and UME UMLS, and for CSV is the CSV, mapping using CSV, are the best, and therefore will be used for the subsequent experiment. 3rd, this is where we start mapping the entity that we found from the queries into entities in the knowledge base. As I mentioned earlier, each knowledge base has its own features. For example, for Wikipedia knowledge base, we consider mapping the entities in the queries into title, alias, links, body, categories, and all of these 5 features altogether. Results shows that for all knowledge bases, the best is to map entities using into the aliases. Choice number 4. In step 4, we consider features of knowledge base that are best to be added as expansion terms. For all knowledge bases, we consider adding the title, the aliases, and both the title and the aliases. In here, our results indicate that the best features to be added is the title. This is true across all 3 knowledge bases. Additionally, we also consider the effectiveness of combining expansion terms from multiple knowledge bases. So instead only sourcing expansion terms from one knowledge bases, we source from multiple knowledge bases at once. We found that the best is combination of expansion terms from Wikipedia and CSV. We call this combination as Wiki CSV. Last step. In this final step, we consider relevance feedback and pseudo relevance feedback. In this step, we also consider the effectiveness of filtering expansion terms to include only high probability of being held related terms, as suggested by Soldaini et al. In 2015. In here, we found that across all KBs, relevance feedback with held terminology filter is the best across KBs. If we focus on the improvement, this graph over here shows that the AQFE can be used to automatically improve health search query by quite significantly. As you can see here, the best setting for NDCG improved by about 50%. With regard to RVPN10, it really improved more than 80% based on the high coverage queries. And therefore, we found that it works, and the improvements are comparable across knowledge bases. And then we try to evaluate the generalizability of these findings by applying these best settings against another collection, which is the CLAY 2017 task. And we also evaluate using shallow evaluation methods, and we found that they produce similar gains. In conclusion, we found that knowledge base can be used to automatically improve health search queries, leading to a more precise top-ranked search results. However, there are pitfalls with the settings of knowledge bases that we need to fine-tune them before we can get the payoffs. Thank you.
Okay, thank you very much, Jimmy. Now we have time for some questions. Please raise your hand if you have any questions, or you can also type it into the Q&A, but of course we would like to hear also someone from the audience so that we know that you are still there. Nobody so far.
Excuse me, Norbert. Actually, I'm from the panelists. So is it possible to ask a question?
Yeah, of course. Go ahead.
I have a question. I mean, thank you so much. That was interesting. I mean, talk. Is it available online? I mean, is there any API to call this query expansion method?
No, not at the moment. Sorry, but feel free to contact me if you're interested to deploy the implementation like this one.
Yeah, because right now we are working on, I mean, query expansion methods, so we can use yours as a baseline. So that's very interesting for, I mean, health-related queries. Thank you.
Thank you. Very good idea.
Okay. Yeah. I myself have just a short remark. Can you go one slide back, please?
Sure.
28. Yeah, here you are talking about relative improvements. So
yes.
These are arithmetic means for which you compute relative improvements. And you shouldn't do this. So please look in my ECIR forum papers. It's among the most common errors that people do in experimentation. When you do arithmetic means, you only should regard at the absolute changes, not the relative changes. Or you have to switch to geometric mean, then you can do relative improvements.
Okay, will do. Thank you.
Okay, any more questions? I don't see anyone raising the hand. No. Okay, then thank you again, Jimmy.
Thank you.
Okay.
How do I stop screening?
We will, the people from Portugal, they will switch to the next speaker.
Okay.
Yeah, you just need to stop sharing your screen, please. And then next author.
Okay, yeah.
Next speaker can share. Yeah. Thank you.
Okay. Good. So the next speaker is Jixing Wang. And so.
Hello, can you see my screen?
Yeah. Okay. Just switch it
Thank
to
you.
full screen and then you can go ahead.
Okay. Thank you. Hello, everyone. My name is Jixing Wang. I'm from Kyoto University. I would like to present our work on answering event-related questions over long-term news article archives. News archives contain millions of news articles and they are long-span document collections. Then each article has a publication date, and the reported events are usually strongly linked with this timestamp. In addition, there are valuable resources that can help people to know about the past events. For example, the evolution or the impact of the events. And professionals such as journalists or historians often need to deal with these collections. And average users may also need to access them for checking the event details. However, users feel difficulty to efficiently make use of these news archives due to their large sizes and complexities, and large-scale question answering system can help to solve the problem. In the paper, we present a QA system called KANA, which means question answering in news archives. The system aims to answer the event-related questions by analyzing articles in the news archives. In the experiments, we use New York Times corpus as our knowledge source, which contains over 1.8 million articles published from 1987 to 2007. And questions about the past usually contain temporal aspects, and we call them temporal questions. They can be divided into two types. The first type is explicit temporal questions, which are the questions contain temporal expressions. For example, which painting was stolen from the National Gallery in 1994 February. The second type is implicit temporal questions, which are the questions that do not contain any temporal expressions, but are implicitly associated with particular time periods. For example, the Prestige oil tanker spill happened off the coast of which country? In the paper, we focus on the latter type of the questions, since they are much more difficult to be answered. And this table shows more examples of implicit temporal questions. As you can see, none of the questions has any temporal expression, and still they are associated with particular time periods. For example, a question like what bill was signed by Clinton for firearms purchases, which has the answer Brady bill and relates to the event in November 1993. And what are the differences between our system and other QA systems? First of all, most existing QA systems are designed for synchronic document collections. For example, Wikipedia or the web. And typical systems consist of two modules, document retriever module and document reader module. For example, the DRQA system, which is one of the most well-known QA systems. However, when facing time-aligned news article archives, these QA systems are incapable of utilizing the temporal information inherent in news articles in the past. And unlike these systems, KANA system is designed specifically for answering event-related questions on news article archives and can exploit temporal information from different angles. And this is realized by the additional module called time-aware re-ranking module. Experimental results show that our model can outperform other existing QA systems thanks to this additional module. So then I will mainly explain the ideas behind this module. Time-aware ranking module is responsible for ranking candidate documents by exploiting the temporal information of the questions, of document contents, and of their timestamps. The ranking is needed to find documents that are likely to contain the answer. It contains the following 4 steps, and I will describe them one by one. The first step is question time scope estimation. And because implicit temporal questions do not contain any temporal expression, we need to estimate time scope of the question. And although the temporal information is not given explicitly, the distribution of relevant documents over time can provide information regarding temporal characteristics of the question. Thus, the question time scope can be estimated by finding bursts in the distribution of relevant documents returned for the question. And this graph shows the results of burst detection for 2 example questions. The second step is timestamp-based temporal score calculation for documents. Here we utilize the timestamp of the documents and compute their closeness to the estimated time score of the questions. The closer the publication date of a document is to the question time scope, the more probable is that the document contains the answer. Hence, the score of the document is higher. In this figure, the publication date of document A is closer to the to the question time scope than document B. So the timestamp-based temporal score of document A is higher. The third step is content-based temporal score calculation for documents. And this score is calculated based on the relation between temporal score embedded in document content and the question time scope by applying KDE, the kernel density estimation on temporal expressions extracted from documents content. The reason that we want to compute this score is that news articles may retrospectively refer to events occurred before the publication dates and provide salient information on these events. In this graph, the content temporal information embedded in document B is closer to the question time scope than document A. So document B has higher probability to contain the answer, hence its score is higher. The last step is the final temporal score calculation and document ranking. Firstly, we use the above 2 computed temporal scores to get the final temporal score. Then this temporal score of the document is linearly dynamically combined with the relevant score of the document, which can be, for example, the BM25 score, and then the re-ranking score can be obtained. And the combination here dynamically combines the proportion between document temporal score and its relevant score. The dynamic weight alpha Q depends on the number of bursts of the question. If question only has few bursts, that means the question has a obvious temporal character, and then the temporal score should be considered more. In contrast, the more the bursts, the higher should be the influence of the relevant score, and time should play lesser role. And as we mentioned before, New York Times is used as the underlying document collection, which contains over 1.8 million articles published from January 1987 to June 2007. And New York Times archive is indexed using SOL. Query of the question is exiled to SOL and returns the top 300 documents ranked by BM25. And then these documents are sent to the next module, which is the time-aware ranking module. And there was no previous proposal for answering questions on news archives or available QA test sets designed for news archives. So we need to manually construct the test set, making sure that the questions can be answered in the news archive we use, which is the New York Times archive. The implicit temporal questions are carefully selected from other existing test sets and history quiz websites. And this table shows the distribution of resources. And we finally extract 200 implicit temporal questions. And the extraction here is quite tedious, as such questions should satisfy these 3 conditions. First, the time of the question event should fall into the time score of the New York Times corpus. And then the answers can be found in the New York Times archive. And this was verified by manually selecting correct keywords from the questions, and then checking whether at least one retrieved document can infer the answer. They can infer the correct answer. And the last one is that questions should not contain any temporal expressions. And we test these 7 models. The first 2 models are the DRQA systems, which use 2 different knowledge sources. The first one, using New York Times as its knowledge source, is better than the second one, using Wikipedia as its knowledge source. And this implies that Wikipedia cannot successfully answer questions on distant past events very well. And so they need to be answered using primary sources. For example, news articles from the past. And the third one is a QA system combined with a re-ranking method proposed by Kanhar and Novak. And the other 4 systems are different versions of Kana system. The first one is the system without ranking module. And the second one is the Kana version that uses only timestamp for ranking. And the third one uses temporal expressions embedded in document content for ranking. And the last one is the Kana with complete time-aware ranking module. First of all, we can see that Kana with full components outperforms other systems for all different top-end documents used for answering the questions. And Kana version that only uses timestamp information or document temporal information, document content temporal information also performs quite well. And however, the complete Kana performs the best. We next test the effect of a dynamic combination of relevance and temporal scores. The 2 dashed lines indicate the performance of the model using dynamic combination, while the other 2 lines indicate the performance of the model using static combination. And if we only look at one metric here, or one color in this graph, the dashed line is always higher, which means that the dynamic combination is better than the static combination. And here are the final experimental results I want to show. We test Kana in regards to questions with many or few relevant documents, as well as in regards to the number of bursts that the questions generate. We observed that in these 2 experiments, Kana with the additional time-aware ranking module performs always better than the one without temporal ranking. And in conclusion, we propose an effective unsupervised system for answering implicit temporal questions over long-term news article archives. And the system exploits temporal information from different angles. And our work also makes few general observations. To answer implicit temporal questions on long-span news archives, one is to first infer the time scope of the question, and then re-rank documents based on their closeness and order relation to this time scope, and then use temporal expression in content, and finally, dynamically combine query relevance and temporal relevance of the documents. And as for the future, we will first extract more temporal questions, and we will use machine learning methods or deep learning methods to perform the question time scope estimation more effectively. And finally, we will try different temporal ranking methods. That's all. Thank you.
Okay, thank you very much for this very interesting talk. So now the floor is open for questions. Please raise your hand or type into the Q&A. So yeah, since while we are waiting, So my understanding is that currently this different weighting of the temporal part is just based on the document retrieval results, so how the retrieved documents distribute over time. Is that correct? Okay, and have you also considered thinking about other methods or other sources that you could use for determining how strong the temporal aspect should be?
Yes, I think we also consider using like the larger news archive, for example, the Times archive, which contains like the documents published hundreds of years, and which can maybe probably answer more event-related questions.
Okay, yeah. Any more other questions from the audience? Type in the Q&A or just raise your hand. Okay. No, I cannot see anyone. Okay, then thank you again. Thank you very much.
Thank you very much.
Okay, and yeah,
just
turn off your screen sharing. Okay, good. And now we are going to the next talk by Panagiotis Papadakos. And those who were present yesterday during the award ceremony may remember that this is the paper that got the best paper award. So we are looking forward to a presentation of the very best paper of this conference, and the floor is yours.
Okay, thank you. We're really grateful to the committee and the organizers for this award and feel very honored. I am Panagiotis Papadakos. I am a postdoctoral researcher at the Institute of Computer Science at Forth, and also a visiting lecturer at the Computer Science Department of University of Crete in Greece. And this is a joint work with a student of mine, and it is entitled Bias Goggles, a graph-based computation of the bias of web domains through the eyes of the users. And I will start by motivating our work. So currently we hear a lot about ethical issues like transparency, disinformation, and bias, and they are in the focus of our information society. And also there is a selective and restrictive exposure to online information. This is basically captured by terms like echo chambers and filter bubbles, where users live in visual spaces where the same information and the same ideas are echoed from all participants, and this information might be only part of the available information. So this leads to isolation of groups of people, and this is a result that is basically intrinsic in human nature, and it is studied a lot in psychology and sociology, but it is also reinforced by algorithms in our domain. So for example, we use personalization in social networks and web search engines, and also we might train our algorithms on biased data, which are basically data from human, and also we might have biased algorithms. So this isolation might inhibit the growth of informed and responsible humans, citizens, consumers, whatever we want to be, and can promote and resurrect social, religious, ethnic, and other kinds of discrimination and stereotypes. So the current focus is on the transparency, fairness, and accountability and bias of machine learning algorithms for decision-making and recommendation tasks, and especially for social platforms. However, we shouldn't forget that social platforms mainly act as gateways to information published on the web as common everyday web pages like blogs and news. And our users are not aware of the bias characteristics of the information they consume. So they visit a web search engine and they just consume information. So, and another important aspect is that there is no formal definition of what bias is, and it is a really difficult definition to give. So our idea is to provide an exploratory approach where we are going to let users to reflect and identify concepts of interest that can have bias dimensions, and let them define them and explore the bias characteristics of various web pages they can visit, and let them explore other related bias concepts as they are defined by other people, and also finally monitor the bias characteristics of the consumed content over time. So in this work, we are going to present the bias goggle model, where users are able to explore the bias characteristics of the web domains for specific user-defined bias concepts, which we denote with PC, and aspects of bias AB. And we present graph-based algorithms for computing the bias score using popular propagation models and bias PageRank that models basically bias surfer. And we also discuss evaluation results and future directions. So about the model, basically, the basic notions are the bias concept, which for us is like the goggle through which the user is going to explore the web about the different bias characteristics, and corresponds to a concept that can be biased. For example, we can consider the concept of politics in Greece or the politics in general, and it's user-defined. And for each bias concept, bias concept has at least two aspects of bias. So by aspects of bias, each aspect of bias corresponds to a bias dimension for a specific bias concept. So for our running example, we can consider a specific political party. And again, these aspects of bias are user-defined through non-empty set of seeds, which are the domains that our user considers to fully support this bias dimension. So a seed can be used only in one aspect of bias of a specific bias concept. And at least in our implementation, for every bias concept and aspect of bias, we create some kind of identity using SH1 hashes that are based on either the seeds information or the identities of the aspects of bias for the aspects of bias and bias concepts respectively. So for our model, we make some assumptions. One is the incomparable seed assumption. So based on this assumption, we consider the domains in the set of seeds of an aspect of bias to be incomparable and equally supportive for this specific aspect of bias. So for example, for the political parties, the homepage of the political party and the homepage of the leader are assumed to be incomparable. And also the orthogonality of aspects of bias. So for all the aspects of bias for a specific bias concept, they are considered orthogonal. So all the political parties in the parliament, for example, are considered to be unrelated. So based on this, now we can start and providing some basic metrics for our model. One is the support of a domain to a specific aspect of bias, which is a measure of supportiveness of a specific web domain to a specific aspect of bias. So this is a normalized score, and we can think of various approaches that can be used to compute this score. So there are graph-based approaches where we try to exploit the relation between different domains with the seeds of an aspect of bias, which is the current focus of our work, and also content-based approaches where we consider the textual information of the respective web pages, and finally hybrid approaches that exploit both approaches. Also, we have the support of a domain to specific bias concept, which is the measure of supportiveness of a specific web domain to specific bias concept. So this measure depends on the support scores of the distinct aspects of bias. And again, it is a normalized score, and it is the length of the vector of the support scores normalized with the length of the ideal supportive vector. So this is a vector ideal not existent vector which has support 1 for everything. And based on these support scores, we now can compute the bias scores of score of a domain to a specific bias concept. So this is again a normalized score, and it depends on the support score of the bias concept for this domain. So highly biased domains should be highly supportive of the bias concept, and also the distance of the support vector from the non-biased ideal supportive vector that fully supports all aspects of bias. So this is the product of the distance with the support. And in our case, we define the distance as the 1 minus the cosine similarity. So after this, now we can move on how we compute the support scores of the aspect of bias using graph-based approaches. So first we have to define the support flow graph. So let W be the set of crawl pages and DOMS W the set of the normalized second level domain and third level domains in our crawl data. And the links W holds all the crawled links between the domains. So we can create a graph that corresponds to the nodes that are in the domain of W, and with edges the links in the domain of W. And now the support flow graph is the set of web pages, is a directed weighted graph that we can create by inversing the links in our original GW. And how we are going to compute the weights. So again, we make another assumption. So for any link that links any domain in W, it is considered to be of supportive nature. So any domain that links to another domain has the same support stance as the other domain for any specific aspect of bias. Also, at least now in this work, we consider that all links are equally supportive. So all links in specific domain are equally supportive to another domain, and independent of the importance of the pages that they appear in. So links that appear in a home page are not more important than links that appear deeper in a web page. So now the weight of an edge in our SFG graph is the number of links from pages in the domain prime to pages in domain divided by the total incoming numbers of links to domain from all domains. And again, this is a normalized value. So now we can use this support flow graph and the seeds of an aspect of bias and describe how we can support, how the support flows across the nodes. So this means how we compute the support score of a domain to a specific aspect of bias. So we use some popular models. The first one is the propagation model of independence cascades. So here we run a number of experiments, and we start with a set of activated nodes, which in our case is the seeds of the aspect of bias. And for it, in each iteration, there is a history-independent and non-symmetric probability of flowing the support to the neighbors of the activated nodes through their link. And there is a probability for activating those nodes that is represented by the weights that we computed in our SFG graph. And the nodes are selected in arbitrary order, and the experiment stops whenever there are no other activated nodes, and we get the average support score. So another algorithm is the linear threshold propagation model, which is similar, with one important difference. So here, for one node to become active, the sum of the support of its neighbor must be greater than a specific threshold, which is considered as a resistance of a node to be activated. So this threshold is computed randomly for each experiment. And again, we use the same probabilities and get the average support scores as our support score. This is a more expensive approach. So we have to consider the neighborhood. And finally, we use the bias PageRank, which is basically a variation of PageRank that uses ideas from personalized PageRank and rooted PageRank. So here we try to model a biased surfer. So the biased surfer always starts from our seeds for a specific aspect of bias, and either visits a domain, the domains that are linked by the selected seeds, or any of the seeds again. So it is like we are creating artificial links from any node to the seeds. So we have some kind of probability that adjusts the weights of these links, and this basically models the behavior of our user. So we have a model the strongly supportive user, where the probability of visiting a seed or the linked domains is the same. We have the decreasingly supportive, where the probability of visiting the linked domains increases as the surfer visits more pages, so it becomes less biased. And also the non-supportive, where we just start from the seeds, and then we use the usual PageRank algorithm. So we also, when the surfer stops visiting links, there is a biased teleportation to any node of our graph, and we have high probability to pages that are close to the seeds. And initially, all of the support scores are 0, except for the score of the seeds, where we have a score 1 divided with the number of the seeds, and we run until we converge. So regarding our evaluation results, we created a dataset based on some sites from the Greek web. So we used as seeds for our crawling sites from critical political life, sports, related with sports, some big companies in Greece, and also the top 300 popular Greek sites in Alexa. And we created a graph that contains almost 100,000 domains and 300,000 links. And since there are no datasets that associate domains with a degree of bias, we created our own. So basically, we have created two bias concepts. One is the contains all the Greek political parties in the parliament, and it consists of 9 aspects of bias. And also we have another bias concept that consists of popular Greek football sport teams. And for these bias concepts, we manually constructed a golden collection that holds highly supportive domains for each specific aspect of bias of the bias concepts. We do not include the seeds. And also we did not check the content if it contains links or not. And then we comparatively evaluate our algorithms. In order to do this, we use the following metrics. So we have the average golden bias ratio, where it is the ratio of the average computed bias score of the golden domains divided by the average score of all domains in the dataset. So the higher the value, the easier we can discriminate the golden domains from the rest of the domains. And also the average golden similarity, which is the average similarity of the computed support vector of the golden domains to their corresponding supportive AB. So the higher the value, the closer to the original supportive aspect of bias. So here you can see some metrics. Kappa basically is the diameter of our graph. It's about 8,000. So, and also for the bias PageRank, you can see in the parentheses the iterations until convergence. So regarding timings, we see that the independence cascade is really fast and can be used at real time, at least in our collection, while the linear threshold is a rather expensive algorithm. And regarding the biased PageRank, we see that the strongly supportive approach is rather fast. And also regarding the metrics, we can see that the independence cascade is also, it is not also fast, but it's also really good, at least for the average ratio, while the biased PageRank is very good at providing scores that are highly supportive to the corresponding aspects of bias. Also, we can see that regarding the sports teams, we have, it's easier to discriminate between the supportive, the golden domains in our collection against the political parties. Also, we did some manual inspection to see, because we had some domains that got really low bias scores. And so this is because there are no links from this domain to the neighborhood of the seeds of the aspects of bias. Also, we are currently creating some cross-browser plugins to offer this functionality to users. So here you can see our plugin, so the user can define or select other bias concepts and use those concepts to get scores about different web pages that he can visit, either by clicking on the location bar or by just hovering over links. So he can see the scores, and also he can compare different domains about their bias scores. Also, as I said, we plan to provide data about how users consume information and what is the score up after some time. So it is like as we have watches and that give us biometric data about our health. The idea here is to give some data about the bias healthiness of the content that they consume. And regarding the future work, we are working in many different directions. Currently, we try to somehow use more relaxed assumptions about our model. So we try to use sentiment analysis to find the supportive neutral or positive nature of links. Also, we want to integrate the importance of the web pages that these links appear in. Also, we want to experiment further with the graph-based approach and the biased PageRank. And also, we want to try some content-based approaches like topic extraction algorithms, so to compute the support scores. Also exploit social graphs from Twitter, etc., to further improve our results. And also we want to implement scalable algorithms and indexes so that we can crawl more data and we can provide scores for millions of popular domains. And basically, if we can in real time, and also if we can also to provide incremental algorithms so that we don't have to recompute everything from the beginning. Also, we plan to release the browser plugins so that they can be used by everyday users. And we want to gather information from users. So we want to gather bias concepts as defined by users, get more popular domains that are used by our users so that we can provide information, and also get some feedback about the bias of the domain to specific BCs. So we want our users to tell us if we are good or not. And finally, we plan to conduct a large-scale user study in cooperation with psychologists and sociologists so that we can study how users define bias, which are the most popular bias concepts, if we can find any correlation between bias concepts of different domains, and check how is the behavior of users affected through time when they know the bias score of the information they consume. And finally, we would like to extend our golden data set to include more data and bias concepts that are of international interest and not only for Greek people. Also, you might be interested in another paper that we're presenting as a short paper, which is highly relevant, where it is entitled Dualism in Topical Relevance, where the idea is that we exploit antonyms as a way to provide better conceptual and better overviews of the conceptual and information space. So, for example, consider the query capitalism and war. The idea is that this user might also be interested about the query capitalism and peace, or socialism and peace and socialism and war. There are many insightful results in these queries. So thank you very much. You can find anything in this link about our system. We have there also our data. So please don't hesitate for any question to contact me. Thank you.
Okay, thank you very much for this very interesting talk. Now we have time for some questions. Oh yeah, here Ting Su.
Yes, I will give him, I will unmute him. Just give me a minute.
Yeah.
You can speak now.
Hi, thank you for the presentation. It's very interesting and there are lots of information. So there's something I didn't catch. Can you please go to the page 20?
Okay, let me, sorry, I can't see the page. Okay. Here, okay.
So you mentioned these 3 types of supportive behavior.
Mm-hmm.
In the data set, did you label these by yourself? Did you label these manually, or did you automatically label them? And if you did automatically label them, how did you do that?
We just use some specific weights for example, for the strongly supportive approach, we just assume that the user either will visit, as he visits links, he will either visit one of the links that are in the page, or he will visit any of the available seeds in this specific aspect of bias. So for this case, we have the same probability that he's going to visit either original links or links to the seeds. While in the decreasingly supportive, we decrease the weights of the links to the seeds as we get more iterations. And the non-supportive, basically the weight is 0. So it is like a rooted PageRank where we start from a specific specific nodes, like for example from the seeds, and then we visit the pages through the links.
Okay, thank you very much.
Mm-hmm. Okay, we have time for one more question. Anyone?
I think we have a question from a panelist.
Yeah. Okay.
Javier?
Hi. Thank you very much for your talk. I thought this was very interesting. I see that you've put in on your future work, but I wanted to know what you think about this. You have presented a future plugin that will allow for the users to watch their bias. Of course, something interesting would be to use some pages that do not have bias, but do you think that maybe knowing which pages are more biased towards several, for example, political parties might reinforce somehow the echo chambers or the filter bubbles, and because those people will go to the pages more aligned with their political parties, for example?
Yeah, this is correct. For example, this approach can be used either to get information from other parties, but again, you can use it also to just visit information that is related to your stance. So basically, the idea is that we want to provide the tools and the cues to the users so that they can know what their biases are. So at least we want them to get in the process of defining the bias concepts that they think they are interested. And then since they have the tools, they can use them as they want. Also, we have to consider that biases are not only negative, so there are also positive biases. So it can also be used in this way. But our basic purpose is towards this direction to provide better overviews of the whole information, so we have more responsible users that know better the available choices so that they can make informed decisions for any aspect in their lives.
Thank you.
We can't hear you.
Norbert, your microphone is muted.
Okay, yeah, thank you again for this very nice presentation. Okay, now we can go on to the next talk. I think the speaker has not shown up, so Ning Ning, he or she had connection problems in the previous days.
So what we will do is, since she is not here, we will run his presentation during the coffee break, and then now we can skip to the next speaker. Okay.
Okay, so this presentation that was scheduled for now will be run as video during the coffee break, and now we go on to the next talk by Hossein Fani. Is our next speaker. The floor is yours.
Thank you so much. So I have to share. So are you able to see my screen?
Yes, we are.
Cool. Okay, actually my talk is a little bit different from the previous talks because it's a repeated, talk. Morning, everyone. I'm going to explain how temporal latent space modeling can be used for the task of identifying topical user communities in future. Okay. So user communities in social networks happens due to a simple principle called homophily. So it states that people, instead of creating a sporadic connection, they create connection with similar others. So as a result, user community detection methods actually try to identify dense connected area of social network, which implies, groups of similar users. However, in the early method, actually they overlooked the time dimension. As we all know, social network structure actually have a highly dynamic behavior. Later, temporal user community detection methods proposed in order to incorporate the time dimension. And then recently, little work has been done in order to identify user communities in future time intervals. These works actually can be categorized into three main groups. The first one are those that only consider the social content. We refer to them as a topical user community prediction method. The second group are those that only considers the explicit links between the users. In Facebook, it could be friendship. In Twitter, it could be followership. And we refer to them as a topological user community prediction method. And there's a third group that combines both type of information. In this talk and in our work, actually, we only consider the topical user community prediction. And the reason is because of these five, reasons. First of all, in social network, there are lots of similar users, topically similar users that are not aware of each other. They don't know each other. So there is no explicit link between them. Also, there are lots of links that doesn't necessarily mean similarity between the users. For instance, these links might be because of sociological, factors such as conformity or sociability, or might be due to just kinship. Also, in some cases, links are not available or misleading because of because there are some link farmers exist in the social network. And the last reason is empirical studies show that the evolution of link information happen at a very lower pace compared to the social content. There are lots of links in the social network structure that are effectively dead, and the user actually don't take time to drop those links. Due to these reasons, actually, we follow the topical user community detection in future time interval. And here is the problem statement. Actually, given the information about the interest of users in the history from time interval 1 to time interval t, our task is to identify topical user communities in future time interval time t+1. In this figure, you can see an example. There are 3 Twitter users. The first 2 users, Joe and John, are interested in the topic Z44, which is war in Afghanistan. And not only they are interested in the same topic, but also they are aligned with each other within the time dimension. However, the third user, Mary, although she is interested in the same topic, but the time is not very aligned with the other 2 users. She becomes interested in this topic much later. So if you are going to create, or predict user communities in future, you would ideally create 2 communities, one for Mary and the other one for the other 2 users. Our proposed method actually is to use temporal latent space modeling and has 2 main steps. The idea is that as the node or as the user changes its topical neighborhood within the time interval, we want to predict a vector for that in the latent space and allow the position of that vector in the latent space changes as the neighborhood of the user in the graph changes or in the topical neighborhood changes. So in the first step, we created a stream of graphs in order to capture the topical similarity of users at each time interval. In this example, you can see at the first time interval, the day number 20, we calculate the cosine similarity of topic vectors and create a weighted graph at time interval 20, and then next time interval, up until the current time interval t. When we have a stream of graph or temporal graphs which captures the temporal topical similarity of users, the next task is to create embedding vector for each user based on the topical neighborhood of each user within this stream of graphs. So we estimate the user vectors in the latent space by minimizing this objective function. It has 2 main parts. The first part is the quadratic loss between the cosine similarity of estimated vector in the latent space for a pair of user and the actual topical similarity between that pair of user in each time interval. And the next term is the regularization term, which we refer to as temporal smoothness. We put this in order to prevent user to have bursty behavior toward topics. In another word, we want each user to gradually changes his or her interest toward a topic. But as you see in this objective function, we have to consider all the graphs in the time interval from 1 to t, and this is not scalable. To address the scalability, we used a proposed method by Zhu et al., which is instead of globally optimizing the function, it's tried to sequentially optimize a local version of the function. So the way it works is this. It tries to initialize the embedding vector for each user by random numbers at the time interval 1, and then tries to optimize the function at that time interval based on the graph at time interval 1. In the next time interval, It initializes the vector based on the previously learned vectors and then tries to optimize the objective function given the graph at time interval 2. So this sequential optimization at each, given the graph at each time interval, actually addresses the scalability. And at last, we have the output vectors for each user. And this is because, and this is based on the fact that as the user changes the topical neighborhood within the graph, it changes the his position in the latent space. And the last vector is the ultimate position in the latent space for each user. Given the last position of each user in the latent space, we calculate the distance of these positions between the users, or cosine similarity between the embedding vectors, and create a new weighted graph. This graph is the predicted graph in the future time interval t+1. And then we apply graph partitioning method. The state-of-the-art method is the Louvain method, which is the scalable and accurate method, the state-of-the-art. And the final subgraph in the graph is the user communities in future time interval, which captured both the topics and temporal behavior of users. For evaluation, we didn't have any golden truth or golden user communities for our data. Actually, there is no golden standard which captures both the topics and the temporal behavior. As a result, we couldn't use the intrinsic evaluation by metrics such as RAND index or Jacquard index or NMI. In literature, in such a situation, extrinsic evaluation actually is advised. In extrinsic evaluation, we pick an underlying application, and we say that if I have the output user communities and I give this extra information to the underlying application, and this improves the performance of the underlying application, it means that that extra information, that output user communities are of high quality. We pick two applications, news recommendation and user prediction. In this regard, we build a gold standard. The assumption is this: if a user mentioned the URL of a news article in her tweet at the time interval t+1, we say that that user is interested in the topics of that news article at that time. So these triples become the entries in the golden standard. And for the task of news recommendation, we just removed the observation about the news article, and we wanted to predict the rank list of news article, or recommend a rank list of news articles to user U at time interval t+1, given the output user communities. For the task of user prediction, we wanted to predict what user or who mentioned a URL, the URL of a news article N at time interval t+1. We built this gold standard for a data set of tweets. It includes about 3 million tweets in English posted by about 100,000 users within the time interval November and December 2010. This data set was publicly available, but because of the Twitter policy, it is not available anymore. And here's the result. We picked 4 categories of baselines. First category is similar to ours. The task is to identify topical user communities in future. The state of the art, to our knowledge, is the Apple Hotel. The second category is the temporal user community detection. The goal is not to predict, it's just to detect the user communities up until now. We picked 2 baselines. The third category is just non-temporal link-based user community detection. We use the Louvain and ECIR, which is the state of the art in this category. And the last baselines are from the temporal collaborative filtering. In these baselines, we consider topics as an item. And as you see in this table, our latent space modeling approach outperform other baselines in the news recommendation task in terms of MRR and DCG at 5 and at 10. And also in the user prediction task, in terms of precision, our method actually outperforms other baselines. However, in terms of recall, the RRN, the collaborative filtering method, RRN actually outperforms others. This is a recommender method, and the architecture is based on the recurrent neural net. When we investigate the reason, we figured out that the output user committees for the collaborative filtering methods put the users in few number of communities, but the size of the community are very big. If you imagine the worst case, if you have only one community and all the users are on that community, then the recall would be 1. So this is why the recall for these baselines are very high. But this comes at the cost of precision. And overall, in terms of F measure, our method actually outperforms other baseline, and these results are statistically significant based on the paired t-test with p-value less than 5%. As a future work, we want to extend this work in order to incorporate bursty behavior of users. You remember about the, temporal smoothness regularization? We want to remove this, and in order to incorporate some bursty topics and bursty behavior of users toward the topics. This is more realistic assumption about topical user community prediction. And actually, this is a joint work between me and Ibrahim at Ryerson and my supervisor, Wai Chang at University of New Brunswick. Thank you so much, and I'm happy to take your questions.
Okay, thank you very much for this very interesting talk and for getting up so early for a presentation. So, do we have questions?
Yes, we have one. So I think so you can talk now.
Yeah, I think so, yeah.
Hi, thank you for your talk. It's very interesting. Can you please go back to page 7 first? Yes. So in page 7, there are 3 people, and you mentioned that Joe and John, they focused on the same topic at the same time, whereas Mary focused on the same topic at a different time. But I also noticed that they seems to have been focusing on the same topic. If you check the y-axis, the 31, they seem to be focused on the same topic. I wonder if, so when you map the users into communities, or when you analyze users, do you put each user into one community, or they can be related to multiple communities because they are related to multiple topics?
Actually, that's a very good question. In our research, we only consider the partitioning methods. So a user can be a member of only one community, but there are some overlapping community detections, and in the future we're going to use them. Then a user can be member of different communities based on a confidence score or probability score. The only difference is in this step. In the last step, let me show you in this step. So instead of using a graph partitioning method such as Louvain, we could use a graph, or overlapping community detection. So that way, a node can belong to different communities with a probability score.
Thank you. And sorry, I have another question. So can you please go back 3 pages, page 18? 18. Yes. Yeah, here. So it seems like the graph you build is over time, like the graph is built over time, and it just completed step by step. But I wonder if a link would be deleted if someone lost its interest.
Sorry, can you repeat the question?
So the timestamp, like 1, 2, 3, 4. Mm-hmm. Here, that's the graph you built on that timestamp based on the topic the user is related to or checked, right?
Yes.
So did you delete, for example, if if the time at the timestamp 4, a user stop interested in the same topic, do you delete that link or do you not delete that link?
Yes. Let me come back to this step. In this example, as you see here, at the time interval 20, these are the topics. So we calculate the cosine similarity of these vectors, and based on the similarity score, we create an edge. So for instance, if this is the user first and this is the second user, the first two is Joe and John, because there is a high similarity, so we create an edge. But the third user, Mary, there is no, for instance, the similarity between this and the other two users are very low. So there is no edge between these. I mean, for instance, if this is the Mary, so we cannot draw an edge. So we do this for each time interval. So we go to the next step and then calculate again all these topical similarities. Based on the similarity score, we create an edge. So if a user actually loses an interest toward the topic, so the similarity drops, so there is no edge for that. Based on this, we created the weighted graph.
Okay, thank you very much. Thank you.
I can answer more. And then, if you imagine this node actually stays the same in the second time interval, but as it goes to the end, creates a new edge. And then comes here, there is another edge. So the topical neighborhood of a node actually changes within the time. This way, we changes the embedding vector as well. As that node goes toward the end of the time interval. Yeah.
Thank you. It's very clear. Thank you very much.
Yeah. So we can have one more question. Anyone? No? Okay, then thank you again for the interesting presentation.
You're welcome.
Okay, and now we are done with the presentations, and we will, during the break, we will now show a video of the talk by Ningning Chia on improving knowledge graph embedding using locally and globally attentive relation paths. So the one that, if you have the current version of the online program, then the second to last talk of this session is now during the break. And so I would like to thank again all the speakers and also the audience for their participation in this session, and hope to see you again soon. Thank you.
Thank you so much. Have a good day.
Thank you. Bye.
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 Thank you.
Thank you.
Can you please stop sharing your screen?
Sure. Wait a sec.
Or David can stop the share.
Oh, yeah. I got it.
Yeah, you already stopped it. Thank you.
So let's see if this works.
Hi, Mr. Relation Passes. Before the presentation, I'd like to give a brief introduction about my background. My name is Ningning Jia, and I'm a PhD student at Beijing University.
But it's strange because I cannot hear on my side. Okay, then I will.
But it's working. It's working.
Hi, Mr. Chair.
Now it's not working.
First slide.
Mr. Chairman, ladies and the content contains the following 5 parts. Firstly, background and motivation. The background of the task is that knowledge graphs such as free-based
every time we change slide, it seems like
Google Knowledge Graph are extremely
she recorded a clip
for
per
many
slide, so it's
NLP
working.
tasks, including information retrieval
I
and
cannot hear
question
anything on my side. That's
the knowledge
probably
graphs
some Zoom.
compose of relational facts with triple format. For example, add entity, relation, tell entity. Da Vinci nationality, Italy is a relational fact in Google Knowledge Graph. Although existing key knowledge graphs can a knowledge graph embedding, which embeds entities and relations of a knowledge graph into a continuous vector space and predict missing facts by manipulating the entity and relation embeddings involved, has been an active research area for knowledge graph compilation. Among knowledge graph embedding, in fact, a path of one entity pair describes the relation connecting the entity pair from some aspect in a fine-grained way, and the importance of relation paths is different. For example, in Figure 1, the two paths of entity pair Tom Cruise America describes the relation nationality from the local and social way respectively. Since the path place of birth country is more essential than friend nationality to express the relation nationality, thus it is more important from the local view. Moreover, from the global view of path friend nationality also occurs in entity pair Tom Cruise England, which is connecting by the relation travel, thus it is less important than the past place of birth country to express the relation nationality. After the background and motivation, then I will introduce problem definition. Given a knowledge graph, which is a collection of valid factual triples, and in knowledge graph compilation, embedding methods aim to define a score function that gives an implausibility score for each triple, such that valid triples receive lower scores than invalid triples. Next, I will introduce our proposed model. Before our proposed model, I will brief introduction the base of our proposed model. For each triple, then through convolution layer, nonlinear layer, and dot produce achieves an implausibility score for each triple. Our proposed model called Curve KB, which incorporates relation paths locally and globally for knowledge graph embedding. Specifically, we apply attention machinism to measure the local importance of relation paths for knowledge graph embedding. And since the attention machinism only focuses on the set of relation paths of the given entity pair that connects by the relation, it does not consider that the path in the set of relation paths may also occur in other entity pairs that connects by other relations. And inspired by inverse document frequency, which is a wide function that has been widely used for measuring how informative each word is in the set of documents, we propose degree-gated inverse path frequency to compute to model the global importance of each path in the set of relation paths. And next, the experiments. We conduct experiments on 4 benchmark datasets, and the statistics of the experimental datasets is shown in Table 1. We evaluate our model on 2 tasks, link prediction and triple classification. Both of them evaluate the accuracy of predicting unseen triples from different viewpoints. Link prediction is to compute a triple with head entity or tail entity missing, and the evaluation metrics are mean, rank, and hits at 10. Triple classification is to determine whether a given triple is correct or not. The evaluation metric is accuracy. The evaluation protocol for link prediction is for each test triple, we replace either head entity or tail entity by each of other entities in entity set to create a set of corrupted triples and calculate implausibility score on the corrupted triples. We can get the rank of the test triple by ranking these scores in ascending order. And the evaluation protocol for triple classification is for each triple in the test set and validation set. We construct one negative triple by switching entities from test triples and validation triples respectively. The triple classification decision ruler is for a triple if its implausibility score is below the relation-specific threshold. Threshold predict positive, otherwise negative. The relation-specific threshold is determined by maximizing classification accuracy on the validation set. And the parameter settings are as follows. And we compare our model with the following methods. The experimental results about link prediction is shown in Table 2. From Table 2, we can see that P curve KB obtains the best MR and highest hits at 10 scores on the 4 benchmark dataset, demonstrating the effectiveness of incorporating in relation paths for knowledge graph embedding. And among P curve KB, P curve KB local, and P curve KB global, P curve KB obtains the best performance, which indicates that considering relation paths locally and globally is benefits for knowledge graph embedding. The experiment's results on triple classification is shown in Table 3. On the whole, P curve KB yields the best performance on the 4 benchmark datasets, which is consistent with the results of link prediction and further illustrates taking the relation paths into consideration is beneficial for knowledge graph embedding. More specifically, on FV50K237 dataset, the accuracy of triple classification improves from 80.6% of P curve KB locally to 82.1% of P curve KB, and 80.9% of P curve KB local to 82.1% of P curve KB. It demonstrates that considering the importance of relation paths locally and globally can better improve the knowledge graph embedding. Finally, the conclusion. Firstly, we present a path-augmented CNN-based knowledge graph embedding model, which improves embedding model by incorporating relation paths locally and globally. Then we introduce attention mechanism to model the local importances of relation paths for knowledge graph embedding. Next, we propose a simple yet effective measure, degree-guided inverse path frequency to compute the global importances of relation paths for knowledge graph embedding. And lastly, we conduct experiments. Results on 4 benchmark dataset show that our model achieves state-of-the-art performance. And that's all. Thank you for your listening. Thank you.
Ah, voilà.
Okay, so we still have some minutes if you guys want to get some coffee or to drink something. 2 minutes to be precise. On behalf of Rui, the local chair of the ECIR2020, I would like to ask you for answering a questionnaire. So basically, we are one of the first conferences to be held completely virtual. So it's really important for us to understand what did you guys enjoy, what went well, what went wrong, and understand how we can improve. This will also be very important for next conferences because, well, until this situation settles, probably this will be the setup of many conferences. So this will also be good for the next organizers. Okay, so the questionnaire will be shared by email and it will also be available on Slack. It's a link to Google Forms. So if you guys can answer them, we would be really, it would be really great for us. Hi, Morgan. Can you are muted? You have him.
Hi there.
Hello. So
Hi.
I just moved some of the authors, some of the speakers to panelists so that they can share the screen and present. I think I'm still missing some. I will check this now.
Yeah, I think we're just missing Subhadeep Maji, but I saw him in the attendee list earlier.
So we have Patel here, Brian Patel.
So we have Uni Krishnan's here, I think, yeah, for the first paper. Linda is here for the second paper. I don't know if we have anyone here for the third paper yet.
From the third, yes, we have Priyank Patel.
Okay.
And just to check, Jesus is also one of the authors of the second paper, along with Linda. So will they both present? Linda, you are muted, sorry.
Sorry, Linda will present, but Jesus just, if he can attend, he maybe answer some questions and so on, if possible.
Yeah, of course. Any attendee can ask questions and.
Thank you. Thank you.
The presentation.
I don't know if you see Jesus. You see him? I don't see him in among the panelists.
Who?
I don't know if he raised his hand.
Let's see.
Can I just ask, Linda, your surname in the papers down is Tamim.
Yes,
Tamim.
Yes, yes.
Okay, it's just a different on your.
I have two names.
Okay, that's fun.
Just like Magyar woman in France.
Okay, I'll stick with Tamim then. Super. And we have Amit Kumar Jaiwal for the fourth paper, I think, and Gaurav Verma for the last paper.
Yeah, Morgan, I'm here. Yeah.
Cool. So I'll just try pronouncing all of your names, those who are presenting. Let me know if I'm mispronouncing anything. I do have a Scottish accent, so there's a certain amount of mispronunciation to be expected. So for the first one, it's Uni Krishnan, if that's okay.
Yes, that's right.
Linda Tamim.
Yes. Hi, Gigi.
Super. Priyank Patel.
It's Priyank.
Priyank yes. Patel. Okay.
Perfect.
I wasn't sure if it was a y or a j.
Yeah.
Good. Okay. Amit Kumar Jaiwal.
Yeah.
And Gaurav Verma.
Yeah, that's correct.
Okay. Super. David, do we want to check whether they can present or not, or are we assuming that works? Silence. Does anyone want to check to make sure that they can present okay, or?
Yeah, sure.
For the presentation?
Yeah, just to make sure that there's no problems, because I know in previous sessions there was sometimes some.
Okay.
Yes,
On the
Morgan,
first paper, maybe first.
We are really on a tight schedule here, so maybe we should just start, and then along the way we just try to figure out any problems and address them. Okay.
Okay.
Thank you.
All right. Yeah.
Okay. Well, thanks. Hello there, everyone. Welcome to this slightly delayed session. Thanks for joining us. We have 5 papers today in the session, all investigating queries, but looking at kind of quite different problem contexts and applying quite different methodological approaches. So it's a really interesting session, lots of diversity in this one. As with the previous sessions, each speaker is going to be given 15 minutes to present. Should you have any queries of your own, leave them till the end. There'll be 5 minutes at the end of each talk for those. If you want to ask a question, then please use the button in Zoom to raise your hand, or alternatively, you can ask a question by text in the Q&A panel. So our first paper is entitled Generation of Synthetic Query Auto-Completion Logs, and that's going to be presented by Uni Krishnan from the University of Melbourne.
Right. Yep. Hi, everyone. Thanks for joining this session from different time zones across the world. I have a pre-recorded talk, so I'll be playing that now, and at the end, I'll be back for Q&A sessions.
Hello, everyone. Today I'll be presenting our work on generation of synthetic query auto-completion logs. My name is Uni Krishnan, and this is a joint work with Alistair Moffat, Justin Zobel, and Bodo Billerbeck. We are all familiar with query autocompletion systems. These systems present a set of completions as the user enters their query in the search box. The completions are set to extend the partial query represented by P, which is the string currently displayed in the search box. So in this example, that will be the string UNI. Each modifications made by the user to the partial query updates the completions presented. And the completions are generated by matching the partial query against the strings from a target string collection, which is typically formed over the strings from a query log. Since there are privacy concerns around sharing query logs collected from commercial search engines, we came up with this idea of abstract QAC log. In an abstract QAC log, instead of recording the actual partial query strings, the length of each word and the total length, including white spaces, are recorded. A set of interaction statistics are also included in an abstract QAC log, but these are not used in this work. More detail on this can be found in our IRJ paper. An abstract QAC log preserves high degree of anonymity, and it can be used for understanding user interactions with the QAC system. However, in order to evaluate the efficiency of QAC system implementations, we need a set of partial query strings. The word lengths from an abstract QAC log is not sufficient in this case. Here is a schematic diagram for the generation process used. For each conversation, which is a group of partial queries, a target string is selected from a publicly available string collection, referred to as the surrogate log. The synthetic QAC log is generated by mapping the word lengths or signatures from the abstract QAC log to the target string selected for that conversation. In this example, the conversation records a user entering the string Kung Fu Panda, starting with the string K. An abstract QAC log records the word lengths or the signatures and the total length of each partial query. The target string selected, John of God in this case, has the same signature as the final partial query from the conversation. And if we map the signature sequence from the abstract log to the string John of God, we get a set of synthetic partial queries, which is shown here on the right-hand side. Now we have to see how a target string can be selected for a given conversation. As I said, for each conversation, the target string selected will have the same signature as the final partial query from that conversation. The signatures of the final partial queries from the abstract QAC log can be collected to a seed signature list. Similarly, the signatures of the target strings could be accumulated to a target signature list. Now, given a seed signature, the process of locating the matching target signatures can be formulated as a string searching problem. And the ways in which a match between the seed signature and the target signatures can be defined are classified into the following modes. A target signature can have an exact match with the seed signature if they are both the same. For instance, the seed signature 332 matches only with the target signature 332 following this mode. In a prefix match, we look for the target signatures having the seed signature as a prefix. For example, the seed signature 332 matches with 3324 or 33247, etc. If the seed signature is an ordered subset of the target signature, we can drop the mismatching tokens from the target signature to find a match between them. And this is defined as a match by drop. For example, if the seed signature is 332, the target signature 3432 can be a match because we can drop 4, and 323425 could be a match because we will drop 2, 4, and 5 to get a match between the target signature and the seed signature. Finally, in a bag of numbers mode, we check if the tokens in the seed signature are a subset of the tokens from the target signature. So this mode doesn't consider the ordering of signature tokens while finding a match. For example, the signature 332 matches with 2334 or 52363 and so on. So the observation here is that a user looking for Facebook login page, for instance, may enter their query as Facebook login, or login page Facebook, and so on. While generating the synthetic QAC log for each of the conversation in the abstract log, we select a single target string. So when we handle deletions, the characters added after the deletions should be, at least in most cases, different from the ones that were typed in before the deletions happened. To handle this scenario, we assume that the user initially typed in a replacement word, which was later on changed to the original word from the target string after the end of deletions. Here is an example that better explains the scenario. For this conversation, by looking at the total lengths and the signature sequence, we can infer that there was a deletion from the second interaction to the third interaction, and another one starting from the sixth interaction to the seventh interaction. So we have this information in the abstract QAC log. If the target string selected is black hog down, the first set of deletions are applied to black mirror, and then the second set of deletions are applied to the string black hole. And we assume that after the final set of deletions, the word hole was replaced with hog and down. How can we pick replacement words for handling various deletion sequences? So we assume that users delete characters to fix the typing errors they made. The following set of typing error categories are considered in this work. A deletion error happens when the user misses out entering one of the characters. So in this example, that will be the character C. Or an insertion error, in which case they end up typing an extra character, so an extra R in the word sheriff. Or a substitution error can happen if they make typing errors and mistype one of the characters. So disturb becomes disturb with a V. A transposition error is defined as the interchanging of two adjacent characters. So EI and IE in weird gets swapped. In addition to these error categories, in a QAC interface, you can also have multi-char deletion. So users could type in a full word, possibly well spelled, and then they could delete a few characters and typing a completely different word, possibly to get a different set of completions. So we call them multi-char deletions. For the experiments, we use wiki clickstream dataset as the surrogate log. This is derived from Wikipedia request logs, and the synthetic log generated from wiki clickstream is referred to as wikisynth. And the QAC log collected from Bing QAC system over a period of 1 week is referred to as Bing QAC 2018. And then we have an abstracted version of the Bing log, which records only the total length and the signature of each partial query and a unique conversation ID for each conversation. While generating wikisynth, we refer to just the abstracted version of Bing QAC log. And at the end, we compare the synthetic log generated, wikisynth, with Bing QAC log. And our expectation here is to obtain a synthetic log, which is similar to Bing QAC log across a set of properties. The frequency of such queries from a query log generally exhibit power law distribution. Therefore, while generating a synthetic log, we have to explicitly fit a power law distribution on the frequency of target string selected. we observed that the distribution of scores from a wiki clickstream dataset follows a power law distribution. So therefore, if we sample each target string based on its score at the end, when we generate the synthetic log, we should obtain more or less a power law distribution on the frequency of final partial queries. The replacement word used for handling insertion, deletion, or transposition errors could be obtained as a character level modification of the original word, for instance, by deleting or adding an extra character. For multi-char deletions, we obtain a completely different word. So the best replacement word, given the contextual information, is identified using a 4-gram language model trained on the strings from wiki clickstream. To simulate substitution errors, a character bigram model is trained on the Microsoft spell correction dataset to predict the most likely next mistyped character given the previous character. So this is going in the other direction as a spell correction. While comparing Wikisynth with Bing QAC log, the final partial queries from each of the conversation are used as a proxy for the target string collection from which the completions are generated. So these strings are assumed to get indexed eventually by a supporting data structure. The partial queries gets queried against the string from the target collection as before. The mode of matching the partial query with the strings from the collection could vary depending on various QAC implementation strategies. This is discussed in one of our earlier ECIR 2017 paper. While generating Wikisynth, we try to obtain a power law distribution on the frequency of final partial query strings. In this experiment, we check how well these distributions are explained with the power law. From this figure, you can see that the frequency distribution of final partial queries and partial queries from both the logs are well explained with the power law distribution. And the value for the exponent alpha are similar across the two logs with a slight exception for the frequency distribution of final partial queries from Wikisynth. So the alpha is slightly higher in that case. Another empirical distribution compared between the two logs is heaps log, which tells us that the rate of growth of unique terms in Bing log is slightly higher than that of Wikisynth. This is expected because the strings in Wikisynth comes from a curated collection, and the strings in Bing log comes from web search having a lot more randomness. The frequency of unigrams and bigrams are also compared between the two logs. And the empirical entropy, which gives us a measure of compressibility of the final partial query strings, are also compared between the two logs. We invite you to go through the paper for more details on these properties. While generating synthetic QAC log, typing errors are introduced to handle deletion sequences. Once the generation process is completed, we can examine the word length and the edit distance before and after the deletion sequence to find a pre-correction string, the word that was there before the deletion started, and the post-correction string, which tells us the corresponding word that was typed in after the end of deletions. So in this example, the pre-correction string will be PAL and the post-correction string will be PLA. And once we obtain the pre-correction strings and post-correction strings, we can compare them to classify the corresponding typing error category. So in this example, PLA and PAL corresponds to a transposition error. An analysis of the typing errors identified from Bing QAC log and Wikisynth shows similarities in the frequency of various typing error categories like insertion, substitution, and deletion errors, and the position of each of these errors in partial query strings. Again, please refer to the paper for more details on the analysis and detection of typing errors between the two logs. In summary, in this work, we proposed a method of generating synthetic QAC logs by combining an abstract log with a publicly available string collection. Alternatively, we can also follow language generation strategies to obtain synthetic logs. But we find that the synthetic logs generated from naturally occurring string collection encompasses many of the properties that are expected from query logs. Even then, some of the post-correction strategies like handling deletions and sampling of target strings are required in the generation process. The performance measurements obtained from a synthetic log and a real QAC log for various QAC implementation strategies are expected to be more or less similar, and we plan to explore this in our future work. So thank you so much for listening. Again, my name is Unnikrishnan, and I'll be happy to take questions now.
Okay, thanks, Uni. I think we have time for a quick question if anyone's got one. No question. Remember, if you have a question, you can raise your hand or ask it in the Q&A by text. A second. No questions. Okay, I'll ask a very quick one. So you mentioned in the paper that there are 0.23 million conversations from the real data that you couldn't match with appropriate strings from the surrogate data. Just wondering what kind of conversations and queries these were, and did you analyze them at all?
So when we couldn't find a match, so based on the modes that we discussed, there were no strings in the wiki clickstream dataset that has the same signature that we were looking for based on different modes. I don't know exactly what the strings were entered because I could never see the actual strings from Bing log, which was always kept private. So, I mean, all I have was the length information from the Bing log. So unfortunately, I could never know what happened exactly there.
There must have been quite strange queries. Okay, if there's no other questions, we will move on. Thanks very much again.
Morgan, the question answer.
Oh, we have one, sorry. So Jochen Leidner has said, thanks for this brilliant talk. Could you see the high level idea of using synthetic data be applied to other IR tasks?
So our initial idea was to use the synthetic log for measuring the efficiency of QAC system implementations. So the properties that we selected for comparison were decided in a way that each of these properties could somehow affect query processing strategies. It could be extended to other tasks possibly. Then when we do the comparison, we may have to identify those properties between the two logs that may affect the outcomes of the tasks that we are planning to perform.
Super. Thanks. Thanks again, Annie. Much appreciated. Okay, so the next paper is going to be presented by Linda Tamin from Université Paul Sabatier, who's going to be asking us what tasks can teach us about query reformulations.
Sorry. We'll share with you my official. Yes. Are you able to see my slides, my presentation?
Yes, we are.
Okay, do you hear me? Okay, everything is okay. So hi, everybody. I'm from the University of Toulouse in France, and I'm delighted to share this work with you. This work was carried out with my co-authors, Jesus Lovon, Melgarejo, and Karen Pinel-Sevania under the COST project. And the study I will present, I'm going to present focuses on the analysis of query formulation pattern and driving by search docs. So first of all, let's say that either users query formulation and query suggestion are inherent to our interaction with search engines, and those interactions are traces of search tasks being done by a user and are very insightful for identifying intent and behavioral signals along user search session. Before detailing our study, let us fix some terminology, what is meant behind task, session, and so on. So task, as we can see from this log extracted from the OWL weblog data, a task, also called in the literature review mission, is a set of queries driving by search goal activity that could be timely, consecutive, or not. And the task could include subset of consecutive related query called logical session. For instance, the job search task will include 2 subtasks related to the seeking for job employment and life commodities. And likely a session called also physical session or timeout or time-based session is a set of consecutive query automatically delimited using a timeout threshold on user activity. And what we can say today from this figure, and we can make 2 main observations that were already confirmed by previous finding. The first one is that online search session tend to have interleaving of multiple tasks in the same session. So this means that in a single session, the task process might get interrupted by other competing tasks that become salient in the particular task. And the second observation is that multitasking could also happen across multiple sessions. All these provide a strong evidence that multitasking during online session exists and depends on the web tasks. So what we are seeking now, the big question that we can, but we can see nowadays that search tasks are emerging as a competitive perspective in this space. We have that has emerged from the recent literature review and even from the talks that we have this year at ECIR from Chirag Shah and Jenny Callan. And the major share of peer work have considered up to now the search session as the focal units of analysis of seeking behavior insights such as query formulation. So the big question that we ask today is that can tasks and sessions be considered as equivalent focal units of web search? And the open and concrete question that we ask today is the query formulation across tasks have similar trend than those across session. Okay, so to fill this gap, with the aim of promoting task-based search, we perform a study on a large-scale weblogs whose main objective is twofold. First, investigate the prevalence of lexical patterns in query formulation and also identify behavioral patterns in query formulation that we can capture from search tasks and compare them to those identified from sessions. And in the case of the existence of significant differences, explore the impact of exploiting task context to improve a query suggestion model. So, to answer this research question, we performed a log-based study on the free available subcorpus of a well query log, namely the WebIS corpus. Some numbers here, the log comprises more than 1,000 users, submitting a total of more than 4,000 queries. And for each user, we use the manual annotation of tasks provided by the website. And for the study purpose, we also segmented the logs into sessions. Using timeout widely used in the literature, 30 minutes and 90 minutes, to ensure the generalizability of our findings. And we can observe in the data a relative high number of interleaved tasks and multi-session tasks. So let us answer the first research question. In the first step, we investigate how query lengths vary across the search sessions within session and task of different sizes, and in what extent the trend of query length changes observed in needed tasks are similar to those observed within sessions. To make fair comparison, first, we compute, of course, the cumulative density of frequency of queries along session and task to identify either homogeneous categories of task per length and search size boundary. Use as authors, you can refer to the paper for the details of this preliminary analysis before comparing the results. So we can see two clear trends. First, queries in both long possession and longer toss generally tend to contain more terms. This trend remains all the different search stages. And regarding particular toss, our results suggest that long toss require at least two more search terms. One could argue that long toss that more likely involve complex information needs lead user to formulate more informative query. We also relate this observation with previous findings showing that increased success is associated with longer query, particularly in complex tasks. Well, the second, we can surprisingly see that in general, queries observed within session, whatever the sizes, are slightly longer in average than queries observed within tasks. One possible explanation of the found is that since long sessions are more likely to be multitasking, the average query length is particularly increased with sessions that include queries at late stages of the associated tasks. Second, we can in a second step, to learn more about the impact of search content on search content on the task level of query term use, the term frequency along the search session, we examine the query term frequency along the search with respect to session and versus task. We compare that. So typically for a query belonging to session or task, not submitted between the beginning, we compute the frequency of each term from the previous query in the same session until achieving maximal term use, and then we compare the numbers between the two categories. So by comparing terms between the term repeat term used in session and task, we clearly observe that they are less reformulated queries that do not share any identical terms with the previous query in tasks. And interestingly, we can see that the difference is particularly higher in the case of long task and long session. However, we can notice that even if the percentage of query sharing an increased number of terms with previous query decreases for both medium sessions and medium tasks, the difference is reversed between the long session in long tasks. So it's more likely that query terms are renewed during long tasks, which could be explained by shifts in information need related to the same driving long-term task. Let us move now to the percentage of reformulated query for which each used term occurs at the first time at a given position by moving the position from 1 to 6 to try to examine along the history of the search context. So it appears that the sources of the used query terms in both task and session are limited to the two previous queries. So no clear difference between session and task on this part. So while we found terms used in the previous query in all the reformulated query medium session and medium task, it's more likely to observe a formulated query containing terms of the two previous query in long session and in long tasks. To sum up, the context used for driving query action is limited to the two previous queries, even for long task and long session, with, however, a lower term or lower level of term use in long task. Let us move now to our second research question that focuses on analysis of query formulation based on some known term action like term removal, term adding, and term retention, but also the similarity between the successive query. Well, while significant to do so, we computed the Jacob similarity and the ratio of term retention, term removal, and term adding between queries, either in the short-term context and long-term context, means only the previous query or the previous ones in the task organization. So we clearly noticed that there were significant differences were observed for the whole set of search actions and similarity values between task-based and session-based scenario. But we particularly report here the differences observed along sessions and tasks. And what we can see, the first observation that we can make is that successive query in both medium and long tasks are significantly more similar than they are in medium and long session for both timeout threshold with higher ratio of term retention. And the second key observation is that the query history long task exhibits a higher topical cohesion than it does in long session, with a higher ratio of term retention and a lower ratio of term adding for tasks. So this suggests that longer tasks more likely include topical and lexically closer information need that might drive subtasks in compared with long session. And likely in long session may include multiple and topically different information needs. We complement this analysis by the investigation of the computation of the query formulation similarity at different stages of the search session and task by also considering both short-term context and long-term context. And we also report here the results obtained through the analysis of long session and tasks. So the main observation that complement the previous ones is that the overall similarity of query formulation observed over the search history in both session and task tend to decrease along the search. Although the trend is the same for both session and task, the possible explanation might be different, as likely different queries and likely task might include different ongoing related subtasks. However, queries are still overall more similar across the search stages in long tasks than they are in long sessions. Let us move now to the third contribution and to ask the third research question. So once we highlighted the set of significant differences in the search trends between task and session, we try to see if those differences or if task features really are relevant for query for improving the accuracy of a query suggestion model. And well, that was our third question. Okay. So let's briefly recall the problem of query suggestion problem. It's usually stated as a ranking problem where the challenge is to score the relevance of candidate query in a search short task. So the top relevant query being the suggested one. The context widely used in literature review is the previous query. We use representative baseline, the one used for query to completion by Jiang, published in a ECIR paper, also used as additional score in recent query suggestion model. So we use the baseline, the session ranker, which is based on learning to rank approach using some pairwise suggestion feature, and use also a baseline to based on the most popular suggestion. We designed the task ranker model in this paper, what was published in this paper, based on the session ranker. We added two sets of features, the classical feature, the traditional feature using the session ranker, and the additional feature related to the previous analysis that would extract that had emerged as significantly different in the case of task, related to user action and query similarity features. And of course, we added those features at the session level in the session ranker and adopted a task-based training protocol, a standard training protocol. For details, you can refer to the paper. We adopted training test methodology and split before the days before to train the session, both the session ranker and task ranker, and following 3 days to test the model. And the observation, the main result we obtained, that clearly task features allowed to improve the AMR measure in terms of accuracy of prediction, particularly for long session. And the results from this finding, and this was quite expected from our analyzers, as since long session include queries related to a larger number of long tasks for quasi contests allowed accurate prediction of user search intent. So the conclusion that we can see that really tasks could play a relevant role in analyzing search history of users, since there are significant differences in query formulation pattern between session, and that climb threshold does not really play an important role. It means that the differences relate to the task itself, to the unit of search itself, And so that the task context is relevant to enhance the user next query prediction. How this study will have design implication, particularly for the design of test and boundary detection method, design predictive model for query JSON based on memory model, and design more interpretable model of representation of query reformulation based particularly on homomorphic representation of queries, such as done by a previous work. Thank you for listening, and I'm here with Jesus, my co-authors, to answer your question.
Thanks very much for that, Linda. Great talk. Does anyone have any questions? Remember, you can either raise your hand or if you're shy, you can ask via text in the question and answer box. Give you a couple of seconds to have a think. Okay, I'll kick us off then. So I was kind of interested when you looked at research question 2, when you looked at the differences between the sessions with 30-minute and 90-minute cutoffs. I was a little bit surprised that you didn't find bigger differences there. I would have expected less topical coherence, let's say, in the 90-minute sessions than the 30-minute ones. You're going to capture potentially lots more interspersed tasks in the 90-minute cutoff and the 30-minute cutoff. Do you have any sort of insights or intuition about why this was?
That's what we expected. Thanks for this interesting question. That was we believe that we'll find that, but no. Finally, we found that the time of cutoff have no real impact, no significant impact on the trends. The time cutoff had some impact on the numbers, on the absolute numbers, based on, for example, on some similarity values between the query similarity, particularly in the long term, when using the long context, the long-term context of queries. But finally, the trends remained the same. And that was a big and important conclusion here. Either 30-minute and 90-minute, the trends were the same.
Yeah, it's surprising. It's quite surprising. Thanks, Linda. No questions at all from anyone? Okay. Then thanks again very much, Linda, for the interesting talk, and we'll move on to the next one. Thank you.
Thank you.
Thank you. So our next paper is going to be presented by Priyank Patel, who is from Flipkart Internet. And the paper is a regularized intent model for discovering multiple intents in e-commerce tail queries. Okay, Priyank, take it away.
I can't share my screen.
Yeah, sorry, if you could unshare your screen for us, that would be great. You're still sharing. Okay, Priyank, you should be able to.
All right, let me try. Cool.
Success.
All right, cool. Hello, everyone. Good morning, good afternoon, good evening. I'm Priyank from Flipkart, and I'll be presenting our work on a regularized intent model for discovering multiple intents in e-commerce tail queries. This work was done with Shubhadeep, who's now at Amazon, Bharat, Krishna, and Mohit, who's now at Udaan. So, hold on. So this is roughly how I'm going to structure my talk. We'll begin with an introduction to the problem statement, certain peculiarities of e-commerce search. What do we mean by the intent of an e-commerce search query, and some examples. I'll then move on to the latent variable generative model that we propose for the problem, the regularization, the data-dependent regularization that we developed for this particular generative model, and I'll end with some experiments and analysis. So let's begin with the problem. I'm sure everybody here has shopped for various products on various e-commerce platforms. And these products are typically defined as a set of specifications, which are a set of key value pairs. So what we see here are two products from Flipkart's jewelry and home furnishing categories. So if you look at the earrings on the left, specifications like plating are product attributes that take the value silver. Specifications like base material is another product attribute that takes the value zinc. For the carpet on the right, specification like shape is another product attribute that takes value rectangle, and so on and so forth. So e-commerce search queries is thus a faceted search on a structured catalog of products which are defined by a set of specifications represented as key value pairs, as we saw in those examples before. The intent of a search query is defined as a labeling of its tokens with the product attributes whose values are matched against the query tokens during retrieval. And we'll see an example of this just in a moment. And queries can have multiple correct intents due to multiple valid matches between the tokens and the various product attribute values. So let's take a look at an example of two queries. The first one is silver oxidized earring. One intent for this query is color, model, and store. And what that means is that when we run a query against our inverted indexes to retrieve the products for the query silver oxidized earring, what we are looking for is products where the query token silver matches a token in the value of the product attribute color. And similarly, we are looking for products where the query token silver matches the value of the product attribute plating, and so on and so forth. And as you can see, the queries, the token silver can have multiple intents: color, plating, material, so on and so forth. Same is the case with rectangle room mat. The query token rectangle can either refer to the product attribute shape or pattern. And this sort of labeling of the queries or annotation of the queries is used when we formulate the query to retrieve the products for this particular query. So the question of tail queries and multiple intents. What we noticed in our query logs at Flipkart is that approximately 1/3 of all the unique queries occur less than 50 times a month. For such tail queries, we do not have enough sufficient click-through data from which we can derive intent labels, and they tend to have poor retrieval performance. I'll get to this problem of deriving labels from our click-through data later in the talk. What we also noticed was that approximately 42% of all the queries in an editorially labeled sample of tail queries had multiple correct intents. So tail queries tend to have multiple intents, and most existing techniques for identifying the intent of search queries are either supervised or semi-supervised, and they require labeled or partially labeled queries. And extending them to identify multiple intents in tail queries is thus difficult. And that is what our problem is. And that's the problem that we intend to address in this work. So let's move on to the latent variable generative model that we propose for this problem. Well, why use a generative model? I mean, as I mentioned previously, tail queries lack sufficient click-through data from which we can derive intent labels. And in settings like this, where labels are absent, generative models are a natural choice. We propose a latent variable generative model for queries, where the observed variables are ordered pairs of query tokens, and the latent variables are the corresponding ordered pairs of attribute labels. Now, the question that very naturally arises is, why look at ordered pairs? Why not look at individual tokens? Modeling token interactions and attribute co-occurrences in a query is important because the attribute label for a token in a query can depend upon the other tokens in the query. So here's an example. Let's consider the queries cotton sofa cushion and cotton bed sheets. The correct label for cotton in the first query is filling material. So we are looking for a cushion that is stuffed with cotton. While in the second query, the correct label for cotton is fabric. So we're looking for bed sheets made of cotton fabric. Right? So here is what the generative model for our queries is. So here we are going to start introducing some notation. So let psi a dash be the co-occurrence probability of an attribute A given an attribute A dash. And this therefore will define a matrix of all the co-occurrence probabilities of all the attributes that we have for the products in our category. Similarly, let phi WA be the probability of generating a token W from the attribute A. And this thus will define a matrix of parameters of generating all possible tokens from all possible attributes of products in the category. And then we assume that the ith ordered token pair, xi, where the first token in this pair we denote by xi1 and the second as xi2, is generated from a corresponding ordered attribute pair, zi1, where again we represent the first attribute in this pair as zi1 and the second attribute pair in this pair, as zi2, and it's generated as follows. We first sample an attribute zi1 uniformly at random, and then conditioned on zi1, we sample zi2 as a multinomial from a multinomial distribution where the probabilities are given by the corresponding column of the psi matrix, where the column is indexed by zi1. And once we have these two attributes, zi1 and zi2, i.e. the attribute pair zi, we generate the token pair xi by sampling xi1 as a multinomial distribution from phi, where the column of phi that we sample from is indexed by zi1, and the same for xi2. We sample it as a multinomial distribution according to the column in phi that is indexed by zi2. For this sort of a mixture model, the inference and parameter estimation can be done using the standard expectation maximization algorithm. Right. So now the question of multiple intents. So here is an outline of our approach. We'll first describe our method of constructing intent labels from click logs. We'll then define a similarity measure between attributes using the background estimates of the generative model's parameters that are constructed from the product catalog and the label data that we generate from step 1. And then we'll finally use this similarity measure to get a regularization technique that distributes the generative model's posterior distribution across attributes that we deem to have similar vocabularies in terms of the probabilities of generating tokens. Right? And this will improve its ability to detect multiple intents. We'll cover some of this in more detail later on. And this approach that I outlined, it's guided by insights that we obtain from an empirical analysis of our product catalog and all the label data. The details of this empirical analysis is given in section 3 of our paper, and a discussion of the results and how that guides what we do is also there in that section. I refer you to the paper for more details of this empirical analysis. So let's come to the question of constructing intent labels for quick logs. So queries that occur sufficiently often with sufficient click-through data, we can use the matches between the query tokens and the attribute values of the products that are clicked to get our attribute labels, that is our intent labels. So what we do is that for a query, we find matches between its tokens and the tokens of the attribute values of every product that is clicked for the query. We then aggregate these matches across all the attributes, do a normalization and thresholding to construct intent labels for every token in the query. Now, do we do this for all queries in our click log? No. We only apply this process to queries that occur at least 500 times in a month with a sufficiently high click-through rate of at least 40%. And what this ensures is that the labels that we derive are fairly clean, they're fairly clean with high confidence, and doing it on queries that don't occur a lot will give fairly noisy labels. So that's why we restrict the queries on which we apply this process. The label data that we generate, we refer to as the click log label data. Cool. Now the background estimates for the model parameters. Let CL WA be the number of times token W is labeled with attribute A in the click log data that we constructed. Let kappa, the VA, be the number of products in the catalog with V as the value for the attribute. And then we'll define a counterpart CUWA, which is just summed over all the attributes where the token W occurs in the value of that attribute, the log of this count divided by the number of tokens in that particular attribute value. And then we define the background estimate for phi WA as proportional to the average of these two C's, smoothened by an attribute specific parameter. And one interpretation of this attribute specific parameter 5a is that it's a parameter of a Dirichlet prior that we are putting over all of these probabilities. We also construct a similar estimate for psi, which we use in initializing the EM algorithm, but since we are not going to use it for the regularization, I'm going to skip it. You can look at the paper for more details. Now let's look at the attribute similarity measure. So if two attribute pairs, A/B/B' have a similar high background estimated probability of generating a given token pair, WW', then the model should pick both attribute pairs as relevant labels for the token pair. We kind of formalize this notion by defining the following attribute similarity measure. The key thing to note here is that is to figure out when this attribute similarity will be high. Well, it will be high when the two terms inside the squares are roughly equal and all the four terms are high. So that quantifies the notion that I just described, that both attribute pairs have a similar and high probability of generating the same token pair. We will use a normalized version of G in our regularization term that I define next. So we use G bar, a doubly stochastic version of G, to define the following regularization term on the log likelihood of the generative model. So what we do in this regularization term is that for every token pair, we take a weighted sum of the squared difference between the posterior distribution for an attribute pair Z and an attribute pair Z bar for that particular token query. And what this means is that for a given token query, so for a token pair, if G bar is high, then models which assign very different posterior probabilities to Z and Z bar will get penalized more. So we want to drive our learning towards models where if G bar is high, then the posterior distribution should not be too dissimilar. The posterior distribution between Z and Z bar should not be too dissimilar. Okay, so what happens when we add this regularization term? So when we add this regularization term to the log likelihood, what will happen is that maximizing the log likelihood becomes a little intractable due to coupling of the model parameters in the M step. So instead we get a lower upper bound on the regularization term, which then gives us the following lower bound on the regularized log likelihood that is tractable to maximize. So effectively what we have done is that we have replaced the posterior distributions in the regularization term with the Qs that are there in the evidence lower bound that we use in EM. And alpha is a hyperparameter. The details are given in the paper of how to optimize this lower bound. So let's just look at a bunch of experiments and analysis. So we evaluated a proposed models against several strong baselines on data sets that are proprietary to Flipkart due to a lack of publicly available data sets. We selected jewelry, home furnishing, and furniture categories for our experiments. These categories have a high business value, but they don't have a lot of query volume, which results in a lot of tail queries. And we take all queries from 1 month of query logs with at least 10 occurrences to filter out queries with mistakes. So here's a summary of the data set, and there's just one salient point that I would like to highlight. If you look at the total number of queries that we have and the number of queries that ended up being labeled by the procedure I described earlier, there is almost a 10x difference in the number of queries. We compared our model against several baselines: logistic regression, CRF, by LSTM CRF, a uniterm mixture model from the existing literature, and our model without the regularization. So the way we did it, we did an offline evaluation and an online evaluation. So for the offline evaluation, we had an in-house team of experts at Flipkart manually label a random sample of tail queries from the query logs. We selected a bunch of queries with multiple intents, we refer to as a golden set. We did 5 random 80-20 splits of this data set to get multiple test and validation sets. And we chose F1 score as the performance metric. And we get the F1 score per query by micro-averaging the F1 score per query token. So these were the results of the intent labelings. As you can see, we performed the best. And the other notable thing to note is that all the unsupervised methods perform better than all the supervised methods. And these were the results of the online A/B experiments. We deployed the best performing baseline, UMM, against our proposed model in the production system at Flipkart, and we did our standard A/B experiment. 10 million users visit Flipkart every day, and 15% of them were assigned to each experiment bucket. The experiment was conducted over 10 days. Only tail queries belonging to these 3 categories were considered for comparison. And we measured the click-through rate and the add to cart ratio as the relevant metrics for this A/B experiment. So here were the results of this A/B experiment. We saw significant improvements in the CTR of tail queries and a very significant improvement in the add to cart ratio of tail queries. And all of these results were statistically significant as measured by a paired sample t-test. Just to wrap up, here is an example of a before and after picture. So what you see on the left is what the production system was retrieving for a tail query in the AB experiment, a small pillow cover pack. And what you see on the right is what our model was able to return. So since we're able to identify the intents of the query correctly, we're able to retrieve relevant products that we were not able to before. And here is another example of another query from the AB experiment. Glass top wooden dining table, right? So we're able to correctly infer the intents and retrieve dining tables with glass tops, whereas the existing system was actually retrieving dining tables with wooden tops. That is the end of what I have to say. Thank you for listening. Any questions that anybody has, I'll be happy to answer.
Okay, thanks very much, Priyank. We have time for a quick question, or possibly two, if anyone's got any. Again, I'm sure you're getting used to this by now. You can raise your hand, or you can ask a question using the Q&A.
Everything clear, huh?
Yeah, you've also done a perfect job, Priyank. Everything's abundantly clear. Well, I'll ask a quick question.
Sure.
So I'm quite interested in how your sort of golden data set was produced. You said you got people to assess these queries.
So let me go back to this golden data set.
So I was just wondering if you had multiple assessors per query and did any interrelator agreement, or
yes, we had multiple assessors. We had multiple assessors per query, and there is a set pattern that we have to deal with inter-rater disagreement.
So how much sort of disagreement were you seeing?
Sorry?
How much agreement were you seeing roughly?
I don't recall the exact numbers, but it's actually for tail queries with multiple intents, it is a difficult job.
Sure.
Because given the wide variety of products and their attributes, you need a very detailed knowledge of the catalog to figure out this particular query token is referring to this particular attributes. So there was, from what I recall, a decent amount of inter-rater disagreement, and there had to be several rounds to figure out what is the right particular labeling, multi-intent labeling for all the queries that we had manually labeled.
Thanks. No quick questions to finish us off? Okay. I'll just mention, you did say that there's an issue that this is a proprietary data set and there's no data sets available for this.
Yes.
Okay, you want any possibility of one appearing at any time soon? We have a...
Yeah, so it's a delicate question in that the raw query logs does provide a lot of insight into what the company considers to be business critical systems. So there is always a great reluctance to openly share raw query log data.
Of course, yeah. Maybe we could.
Yeah.
Anyway, I'll let Anne has a very quick question, hopefully.
Hi, Priyank. Thanks for a great presentation. I just want to ask, when you label the query token, so you said you label the query tokens with the intents. Do you also consider, a set of tokens to be labeled as one intent instead of just taking like one query?
So that was a part that I had effectively glossed over in the talk. So what we did was that for every attribute, we essentially take a cross product between all attributes and a BI notation.
Okay.
So that sort of lets us label sequences of tokens in the query with the same attribute.
Okay. Okay, sure. Thank you.
So we use a fairly standard BI notation, cross product, take a cross product of the BI notation with all the attributes that we have. So we can then use that to say that these 3 tokens in this query belong to this attribute.
Sure. Okay. Thank you.
We can label multiple tokens. Effectively, we can label multiple tokens as a single phrase.
Sure. For more information, I will check the paper. Thank you. Thank you so much.
All right. Thank you.
Okay. Thanks, Anne, for the question. And thanks again, Priyank, for the really interesting talk. It's a nice paper. So moving swiftly on, our 4th paper today is on utilizing information foraging theory for user interaction with image query autocompletion. And this is going to be presented hopefully by Amit Kumar Yaiwal from the University of Bedfordshire.
Hi.
Hi.
Is my screen visible?
It is, yeah.
Yes.
No slides yet. But...
Okay, cool. Yeah. Hello, everyone. I'm Amit Kumar Jaiswal, and I'm a PhD student at the University of Bedfordshire. And so this is a work between within our group, and I'm advised by Hemminglew and co-advised by Ingo Fromholz. So I go with the basics of query autocompletion, and what basically we did, did the generalization of query autocompletion for image search. So query autocompletion is basically an important aspect of suggestion-based IR systems, and it allows users to, it allows the system that whenever a user types a prefix, it right next to the, and the system actually predicts the next character or the query itself. So it is basically an important aspect for in IR. So here we take an example. Let's say a user typed M. So so this example is basically from our system. So it's one part of our system, text autocompletion. So what we do here is basically so our model, so our system is basically tailored to the rare prefixes. So is for only single or multiple characters, not for word. So what we did here is basically whenever once type a word, it basically keeps on generating the completions for each query prefix. So these are basically reformulated query if one can want to understand what exactly these queries are. And these completions could be a list of suggestions. So for the corresponding queries that has been auto-completed for the prefixes. And what we do is basically, so if we consider that that the auto-completion, if a user chooses one of the auto-completions, like man on the board in the middle from the prefixes M, I mean the query man on the board in, so it clicks and then it finds the it auto-completes. So if we compare how it differs from the query auto-completion and document retrieval or image retrieval, it just differs in a way that the query auto-completion systems are basically prefixes or even term or words, or even the whole query. And in image retrieval, it basically for image query auto-completion is a textual query. So it differs in the terms it differs in the content you retrieve. So we basically focus on a query auto-completion task for image search. So our task is basically to generalize the existing language model for text query auto-completion, that it can be tailored to handle the semantic understanding of the language model that they understand. So basically we come up with an idea that we can apply query auto-completion for image search, and we basically tailor the user's information need, basically the ambiguous query they type in the form of visually oriented patch-based suggestions. So the purpose of the task is to how we can generalize the existing query auto-completion for image search, and how we can tackle the lack of the context that the text auto-completion model suffers from. So basically in text auto-completion, basically the word language models are basically I mean it suffers from semantic understanding of the text basically, and and to align those we basically assume that if we do operate on image search, it may get a better reflection of the user information need. So so here we go with the what is image query autocompletion. So whenever we do, so in our task, whenever we whenever our system handles a query prefix, it autocompletes for an image. So we retrieve an image for the autocompleted query that is man on the board in the middle, and why it I mean why it is needed, why do we need a image query autocompletion. So I mean, if you look at the auto-completed query, man on the board in the middle, and let's look at the image. So from the auto-completed query and the image, it has a lot of semantics difference that a word level language model can handle. So we basically extend an existing language model. We'll talk later in the slides. So the contribution of our work is basically we present an approach for query autocompletion for image source, that image query autocompletion, and we also we does it by extending the existing character-based language model by replacing the user embedding by image embedding, and we also look from the cognitive viewpoint of how a query autocompletion can be explained, can be explainable. So we leverage information foraging theory to explicit those observed behavior, observed behavior of the user information need, those unambiguous query prefix. And in the end, we leverage BERT, and we propose a image BERT to compute to reflect the information need in terms of patches. So we basically compute the patch probabilities of patch probabilities to reflect that if the context can be aligned, the text query, the context of the text query can be aligned to those patches. So here we go with the problem description. So we basically considered the autocompletion problem as a probability maximization problem. So QA star here is the query adopted on an image, and this probability for a given query prefix to autocomplete an expected query for an image so these query are basically those terms T1, T2 for those 10 suggestions, basically the autocompletions, and for a given query prefix. So what we do is we basically extend we extend the existing language model that is in here in the reference one. If you look at it, it's from ACL, and what it does is basically they use a user embedding. So in our case, we replace those user embedding by image embedding because we focus on query completion for image search. So we parallelly feed image features. So these image features are basically basically trained on is a region-based convolution neural network, and it's trained on ImageNet, a large corpus of images. So I will talk about what data sets we actually used and we trained our model on for the effectiveness of our model. So we basically feed image features alongside the auto-completion, and then at the end we actually match those auto-completed queries to those images and we actually basically inspect those patches in the image where user actually focuses on. But in our case, we're not doing user study, so we're saying the user focus by means of alignment of their user information needs. So those user information needs are basically the queries, they are the information need that they types in. So basically the unambiguous information need. And why we compute patch probability is to reflect those ambiguous information need. And yeah, and we also come up with the explainable approach that the patch selection by the deep neural network, that is the BERT, how we can explain those black box mechanism with some explainable approaches. So we adopt information foraging for that. So here I go with the information foraging theory. So information foraging theory is a theoretical framework for understanding information access behavior, and is basically adopted from, is basically derived from optimal foraging theory and it applies in information retrieval, that how a user can understand how we can understand the users seeking behaviors. So, and it actually stands on three constructs or models, that is information patch and information sent, information diet. So what is information sent? So we know that the contents in the web and the contents in any sort of let's say a document, I mean a web search, or it could be image search. So those contents are basically scattered in the form of maybe text or documents, or maybe code snippets, or maybe images. So we consider so those images are basically such sort of images or text snippets or labels are referred to as a patch, and and the user actually move from one patch to another, or maybe from one page to another in the form of from one patch to another. So these movement are basically followed by a queue, or the queue could be hyperlink or the other construct of the same interpretation. So we basically so the model that characterizes such movement is basically information sent, and the consumption of information based on the probability of how this information can be positively consumed, or is not non-relevant item that the user consume. So basically the consumption of resources we refer to as information diet in information patch in information foraging theory. So here we take a simple example that how one can interpret information foraging theory in query auto completion. So let's say a spider builds a web, and it waits for its prey to come. So it waits for its information to come. So basically the information is pushed to them. So if you interpret in terms of query auto completion, so whenever a user types a key or prefix, the information gives some suggestion or autocomplete correspondingly for those prefixes. So basically those completions are basically pushed to the users for their ambiguous information need. And the wolf, so if we take a case of wolf, it basically it hunts for its prey and they seek information. So they pull information to themselves. So this is a basic example of how we can interpret information foraging theory in such query suggestions or query completion context. And the explainable approach that we come up with for query auto completion, for image query auto completion, is that whenever a user types a query, we consider every suggestions from the system as a queue, and we hypothesize that these behavioral cues are basically the perceptual cues, and it activates it basically for the users to match the to match their mental beliefs of the mental picture they are thinking of. So we interpret these perceptual cues or the suggestion in a way, and the information sent of those cues, let's say a user typed a query prefix or a query, and the system didn't give any suggestions. So in that case, we consider the information sent of such query prefix or the cues are too weak, and the system didn't know. So we apply beam search to generate those query based on the features that we have in the model. And these query suggestions basically represent the diversity of informations and pattern. We will also see in the later slides that how these query suggestions can reflect these information sent. So here we come up with the implications of these explainable approach based on IFT, that how it works. And so these are basically the trails, these ambiguous information needs of by the user that they type. So we So we consider these tails as information sent level, and when we do the patch selection, we basically inspect those patches based on the patch probabilities, and these represent the information sent pattern of the user's information need reflected in form of patches over the image. And we propose a model, that a foraging based model for patch selection. So here the FPI is basically the frequency of the patches. So these patches could be different or similar. So this FPI means a frequency for the given patch in an image. So this so here the probabilistic patch selection model based on IFT is basically we come up with two model. So one, we compute the information sent of any queue under a query station, this QS, and this is a summation of all the frequency for a given patches with the log up. So this basically means that the first part is actually the term weights. So and with the log, and the second term is the function of time is basically a time. So we derived it from the TF-IDF, and the second formula, the log probability of patch selection, is basically the log probability of for a given for selecting an image I for a given patch is the product of non-parametric mixture of Bernoulli distributions. So this RPF is basically the rate of at which patch P can be focused by a user, or it can be semantically aligned with the ambiguous information need. And here's the model. So the user taps in a query, and we parallelly basically feed the image features, and these features are inputted to the context dependent weight, the second term, the adaptation matrix, and it feeds into the LSTM model to autocomplete the query. And we feed the auto-completed queries to the BERT model as in the lower part you see, and we predict the class labels of those patches. So those class labels, we compute their probabilities, and we rank these selection based on the probabilities. The higher the probability, we think we assume that the context and the user focus or the user information need is more tailored to the high probability. And the evaluation we did is for the LSTM language model, we used two benchmark datasets, that is a visual genome and variety. So it is a big collection of images annotated with region description. So region description are basically the topical captions to describe an image. So we considered those region description as a queries, and same for the variety dataset. And we consider like 20,000 images in the visual genome. So we consider only 20% of the samples from the visual genome, as it's too large and it computationally too extensive for us to train on. So we consider 16,000 images in the visual genome as a trained set, and 4,000 for the test set, and same for the variety as well. So here is the mean reciprocal rank for our. Yeah, I'm finishing right now. So we basically evaluated our LSTM language model, and the MRR for our language model is 76.4. So why it is high is because we basically use an external image information, the feature basically, and it actually improves our model. And why it improves and why the image features are one reason for those. So we actually compute the perplexity of our language model to see if our image model are basically certain, or it results in a lower uncertainty. So for visual genome, the value is closer to 2 for those images. So we think that our model is has a better perplexity, and it performs better as a very less certainty of for the auto-completion. And the future work could be we can interpret this foraging-based model for scalable query auto-completion systems, and we can generalize based on some other data set, that's open image data set. And this can also be leveraged for query level interactions and the multiple actions, the query and session level. Thank you.
Okay, thanks, Amit. I don't think we really have any time for any questions. We'll have to move on. But if you do have any questions, really interesting talk, please do take them offline. Send an email to Amit. I'm sure he'll be happy to answer any questions you might have about that. Thanks very much. Okay, so our final talk of this session is using image captions and multitask learning for recommending query reformulations. And this is going to be presented by Gaurav Verma from Adobe Research. Gaurav, take it away, please.
Yeah, just take a moment to share my screen. Okay, so is my screen visible?
Yes.
Okay, so hi everyone, I'm Gaurav Verma from Adobe Research, and I'll be talking about using image captions in multitask learning for recommending query reformulations. And my colleague from Adobe Research, Vishwa Vinay, is also on the call, so I just wanted to say a virtual hi. Okay, so so many of us like to think of search as a conversation where the user comes in and types in a query. In response to that, the search engine tries to autocomplete that query. The user may or may not choose one of the suggested autocompletions and finally executes a query. That query is used by the search engine to look into the repository and come up with relevant results, which are displayed to the user. The user then analyzes the results and often does not find what he or she is looking for. And under such scenarios, the user is forced to reformulate their original query into versions that better reflect the intent that they executed the query with. And so the conversation goes on. But if we look at key transformations in this conversation, there is one transformation from beach to sunset beach, which is enabled by technologies that fall under the umbrella of query autocompletion, something that Unikrishnan talked about. And the another transformation is the transformation from sunset beach to tropical ocean sunset background. These transformations are usually enabled by technologies that fall under the umbrella of query reformulation. Our work here is more focused on the query reformulation side of things, and we'll talk about it a bit more in the coming slides. Before I get to what we have proposed in this work, I would like to discuss what the prior work is. The state of the art for generating query reformulations is an architecture called hierarchical recurrent encoder decoder, which essentially has the ability to model sequence of terms within a query and the sequence of queries within a session. The way it does that is by having two encoders that operate in a hierarchical manner. The query encoder takes in the words of queries as input and generates a query representation, which is sent as input to the session encoder, which then generates a session representation. It is up to query decoder to take the session representation as input and generate the reformulation word by word. So the way current technology or current version of HRED reformulates a query is by taking query 1 in the session as input and generating the subsequent query as the reformulation. So if Qn is taken as the input, the supervision signal for generating the reformulation is Qn+1. This is where the change that we have proposed comes in. We propose an alternate supervision or target. Instead of using the subsequent queries within the session, we use captions of clicked images as supervising signals. And the reason why we want to do that is because captions of clicked images are inherently more descriptive in nature. So if you think about this examples where there are 3 queries in a session, the corresponding caption to the clicked image in response to the query friends was 2 best friends celebrating with confetti in evening, whereas the subsequent query was group of friends. So essentially, we see that the clicked caption is much more descriptive than the subsequent query. Another reason is that we want to bridge the vocabulary gap between what the user is typing and what lies in the domain that we are searching in. So going back to the conversation example, we saw a transformation which changed sunset beach to tropical ocean sunset background. So a lot of new words came in. And these words are indicative of the kind of data that lies in the domain that we are searching. And so using properties of documents that are going to be retrieved as supervising signals, we can map the vocabulary, we can bridge the gap between the vocabulary of the domain and the user. Also, there is a shift between systems to become more, among systems to become more conversational in nature. And since most of these captions, image captions are given by users, these are closer to natural language than the subsequent queries within the session. I particularly like this example. It says sunset with mountains and ocean and distance. It talks about the keywords and also how these keywords are related to each other. The second change that we introduced to the baseline setup, which was HRED, is bringing in a new component of ranking through a multitask setup. The way we do that in the architecture is by concatenating the current query representation with the session representation so far and passing it on to the ranker. Now the ranker is responsible for using that total concatenated representation to rank the retrieved items. The motivation for using a multitask setup is that it has been proven to be beneficial when the tasks are somewhat related. In our case, the tasks are query reformulation and joint ranking. And when we bring in the new component of ranker, we have this possibility of experimenting with different kinds of losses. The two loss that we focus on are pairwise ranking loss, which allows us to model the item-wise preference in the retrieved set, and cross-entropy loss, which doesn't allow to do such a thing. Now, I want to emphasize on the point that even though we are considering ranking as one of the tasks in the multitask setup, it's not the focus of this work. The focus of the work remains query reformulation, but we just want to experiment that whether the signals from ranking can benefit the learning of better reformulations, essentially trying to see if these tasks are mutually beneficial or not. So I'll briefly talk about the data that we are using. We are using a proprietary data from Adobe Stock, and it comprises of millions of queries in sessions, and billions of assets, which may be images or videos, are shown in response to these queries. We also know which of these images were clicked and what were the user-given captions for the images which were shown as well as clicked. So most of the work happening in search at Adobe Research is focused around Adobe Stock, which spans the data from which spans multiple modalities and is very rich in nature. So just to revise quickly, there's two setups that we are interested in are HRED and HRED cap, where the first one tries to learn a query reformulation by using subsequent query in the session, and the second tries to learn a reformulation by using captions of the clicked images. And to both of these setups, we bring in the ranker component and try to experiment with different kind of losses, what works better and what works not as good. And we'll look at the performance of these models in a bit, but before that, I would like to talk about evaluation. So for evaluating query reformulation, we rely on standard NLP metrics. Blue score is basically a score which gives us the n-gram overlap between generated reformulation and ground truth, the extent of n-gram overlap. And embedding-based similarity is a software metric which tells us how close the generated reformulation is to the ground truth reformulation in terms of their cosine similarity, in terms of their embeddings cosine similarity. When we talk about recommendation, diversity becomes an important issue, and we'll talk about that a bit later. But diversity is also one of the aspects which we want to evaluate our models on. For the ranking component, we evaluate our model on the metric MRR, which, as the name indicates, computes the mean reciprocal rank of the clicked image among all the shown images. A thing to note here is that the historical data that we pulled from Adobe Stock had an MRR of 0.31, which means that on average, the image which was desired by the user occurred at rank 3. And we consider this as a baseline, and we want a ranker to be performing better than this while assessing its performance. Few more notes on evaluation. The metrics that we are using for query reformulation, blue and embedding-based similarity, they have known shortcomings, but these are standard metrics which are being used. And then one of the known shortcomings is that it penalizes descriptiveness, because there are going to be less n-grams if new words are coming in. And also the average embedding of the reformulations are going to shift away from what the ground truth is. Another important aspect here is, irrespective of what is being used as supervision, whether clicked caption or the subsequent query, we use subsequent query as the ground truth. And this is done in order to maintain consistency while evaluating the models within this paper, as well as the consistency with existing prior arts, the way they conduct evaluation. So in terms of query reformulations, there are two major trends to observe. The first is joint ranking in reformulation performs better than just reformulation, which essentially means that bringing in the multitask component helps us reformulate better. The second trend is HRED cap wins out on blue and diversity, which means that the richer supervision, which in our case is coming from captions of clicked images, helps the model to learn better reformulation, to generate better reformulations. And we do observe a drop in embedding-based similarity, and we do have an intuition about that, but I'll skip that for now. Talking about ranking results, the first obvious thing that we notice is multitask learning shows increment over baseline MRR. So where the baseline MRR was 0.31, multitask setting, irrespective of what kind of loss we are using or what kind of supervision we are using, performs better than the baseline. This is somewhat expected. The good thing is that pairwise ranking loss, which allows us to model the item-wise preference in the retrieved set, performs better than CE loss while ranking. The most important observation here is that multitask learning plus reformulations using captions show a greater increase in MRR. This is when they're compared to using subsequent query as targets for reformulation. So it indicates that multitask learning helps reformulation more than it helps reformulation when we are using captions as reformulation target than it helps when we are using subsequent queries as reformulation targets. So throughout our slides, we have emphasized on the descriptiveness of reformulations. We want them to be descriptive, so it makes sense to analyze that separately. And next few slides try to do that thing. So we start with the observation that captions are contain more words than queries, and this is also reflected in the generated reformulations. HRED cap contains more words in its reformulations than the conventional method HRED. But number of words in reformulation is only a facile proxy. We want to look deeper into what these reformulations are adding and dropping. And in terms of numbers, we see that HRED cap is adding more words than the conventional method. And we also observe that HRED cap is dropping lesser words than the conventional method. And in conjunction, when we look at the number of words which are dropped and added by HRED, we see that the numbers are almost similar. So the number of words that are added to reformulation and the words that are dropped from the original query while reformulating are more or less similar in case of HRED. And the numbers are considerably higher on addition side than compared to the drop side for HRED cap. This allows us to do another interesting experiment where we try to evaluate the similarity between inserted and dropped words. The way we do that is by computing average similarity between the dropped and average embedding similarity between the dropped and inserted words. We find that for HRED, which uses subsequent queries as reformulation target, that similarity comes out to be 0.64. And for HRED cap, which uses captions as reformulation target, that similarity comes out to be 0.41. Now, a lower similarity is a better indicator that new information is coming in by dropping older words. So we can make a conclusion that added words are semantically different than the dropped ones. But in case of HRED, the replacements are mostly synonym replacements, and not much new information is coming in. So this number 0.41, when looked at in conjunction with good blue scores, means that we are somewhat doing good at descriptiveness. But the final test is to actually look at the reformulations and see what's happening. So this particular example is one that I really like, where the query sleeping baby cute was reformulated to baby sleeping in bed peacefully, whereas HRED just reformulated it to sleeping baby. Now, this is consistent across all the observations here, that a lot of new words are being inserted, which adds to the descriptiveness of reformulations. One example that I really like is the one that reads little baby sleeping in white bed peacefully. Whereas earlier we had white bed sleeping baby. So this reformulation not only talks about the objects, baby and bed, but also talks about the attributes of those objects. The baby is little and the bed is white. Also, it captures how these objects are interacting with each other. The little baby is sleeping in white bed peacefully. So this brings in the notion of conversational reformulation again. We see that the reformulations are more natural language-like and less keyword-like. The last part of analysis was analyzing the diverseness of our recommended reformulations. Now, the notion of diverseness here is important because we don't want all our reformulations to have redundant information, and also because we want to cover the multiple potential search intents that the user might have had while executing the original query. Now, to measure the diversity, we try to compute this pairwise similarity between the reformulations in the candidate set, and we take an average and subtract from 1 to get the average similarity to get the notion, a metric to quantify the diversity in a set of reformulations. This is a curve which shows the trade-off between diversity and relevance. It's something that is expected, that as diversity goes up, relevance comes down. But what we want to emphasize here is how jointly learning to rank along with generating reformulation leads to more diverse reformulations. And also the fact that pairwise ranking loss diversifies better than cross-entropy loss. So this multitask setup is helping us come up with more diverse reformulations. Just to summarize quickly, we introduced 2 changes. One was the change in supervision signal. Instead of using subsequent queries, we used captions of clicked images as target. We saw that the reformulations became more descriptive. And we also saw that the vocabulary gap between user and the domain was somewhat bridged. The second change was joint ranking with pairwise ranking loss. We saw that this multitask setup helps both the tasks, which are related in nature, but more importantly, it helps to reformulate better. The second observation was that pairwise ranking loss diversifies better than CE, which is the cross-entropy loss. And with that, I would like to stop. If there are any questions, I'll be happy to answer those.
Super, thanks, Gaurav. We have time for one quick question, I think, before we finish the session. Anyone, any burning questions? Remember, raise your hand or use the Q&A. Give you a little bit of time to have a think. Okay, Makunda has a question, I think. Nope. Nope. There was a hand raised there, but it's gone down again. Okay, last chance. Going once, going twice. Okay, well, thanks very much for your talk there, Garth. It was excellent, thank you. And thanks indeed to Uni, to Linda, to Priyank, to Amit and Gaurav for the interesting session. Thanks to all of you, well done. And thanks to all of you for listening. Thank you.
So we can all have lunch now, and we can get back in 1 hour for the conversational search panel. So don't miss. There will be great speakers, and so meet you at 2 p.m. Lisbon time. Javier, can you see the screen, my screen, with the lunch break?
Yeah, it's perfect.
Okay, great.
Yeah, previously it was you were sharing the notes, but now it's perfect.
Yeah, I swapped the screens now. Okay, so I'll get some lunch and I'll be back at 2.
Yeah, there's no problem if I go out, right?
Yeah, I'll be close to my computer. So if anything happens, just text me. I mean, that shouldn't be any problem.
Yes, because I'll go lunch too. So that's why.
Yeah, but actually, so now I don't know when, but Gustavo may jump in because now he will be the host of the afternoon session. So he should be arriving anyway, anytime.
Okay, I'll stay here. I'll leave this open just in case you need something. I am on the mobile.
Okay, yeah, me too. I'll also leave this open, and everything will still run. Will be kept running. So just text me if something happens.
Okay, perfect.
Okay, so bye. Be right back.
Bye.
Hello.
Hi, good to see you.
Hi, Martin. Good to see you.
How are you?
Good to see you.
Good, good. How about you? Hey, Joao.
Hey, guys.
Hey, Joao.
Hi, Martin. So I'm bringing everyone. So, Tatsing, hi. How are you?
Yeah, hi. Good, good. Yeah, it's almost 9 p.m. here in Singapore.
Okay. Chen Yang, I need you to raise your hand. Do you see the button there? Okay. Hold on. Got you. Okay. Now, Julia.
I'm me. Okay.
Hello, can you hear me? Hello.
You're still waiting for Ugo. Okay.
Sure.
Can you hear me now?
Can you hear me?
Yes.
Okay.
Yes.
Good.
Martin, can you hear me as well?
It's very soft. You're very soft, Julia.
Maybe I'm just speaking soft.
No. So, Chen Yang, you're okay. Julia's voice is very soft.
Yeah, Julia is.
Is it better now?
A bit.
Is it better now?
Yes.
Yes.
Okay, then I
Oh,
don't
yeah,
know.
now I can hear very well.
So, Martin.
Yeah.
Diego is from Bloomberg, and he's going to say a few words before the actual panel starts. As Diamond sponsor of ECIR this year.
Okay. And then I take over briefly, and then we go through the list of panel members, each for a few minutes, and then we start our Q&A. And then how do I see interactions with the audience?
So you have the Q&A button. You see?
Yeah.
And if they are so, can someone in the audience raise their hand just to test?
Ugo, for instance.
So you see hand raised, and I see Ugo there.
Oh.
I actually need. Okay, we have already now too many hands. Thank you, everyone. So all these people would like to ask questions.
I do not see them. I do not see them.
But you have to press in the participants list. You have the
attendees
button.
Okay, I was looking at the Q&A.
Okay, yeah, no. So that is the participants list. If they want to talk and ask the question, they press that button, and I will promote them to allow them to speak, to ask.
Okay, you're doing that. Okay.
So and if they are too shy, they can write the question, and then
Okay, so
you can read them out loud, because the attendees cannot see the questions. They cannot see the written questions. So we need to read them out loud.
and they'll come in the chat box, in the Q&A, or both?
In the Q&A.
All right.
So,
there you go.
So,
Diego.
hi, Hugo. Good to see you.
Hi, good to see you, Martin. Can you hear me?
Yes.
Yeah.
Oh, good.
So, Diego, would you like to share your screen now with us, and then I will play the video.
Oh, can you play the video actually?
You want to play the video? Okay.
No. It's fine if you want to play it. I'm not sure if YouTube will do it.
I can play the video. I can play the video.
Okay, so I'll just say something and then we can play the video.
Sure. Sure, you can go ahead.
Okay. So, hi everybody. My name is Diego, and I work for Bloomberg. In Bloomberg, I lead a team that works on autocomplete. So we basically do ranking and auto-completion for query. I would like to thank the organizers of this conference.
Diego, I'm sorry, but we cannot hear you very well.
Yeah, I cannot hear you very well.
Can you hear me now?
Can
you hear me?
Slightly better.
Sorry.
Can you hear me?
Very low voice. Yeah.
Okay, we had here some panelists from previous sections, some previous sessions.
Can you hear me now?
Yes, now it's fine.
Okay.
Good. Go ahead.
Sorry, I was saying I would like to thank the organizer of ECIR. I first attended this ECIR in 2011, so I'm glad to be here today, and in the previous day I saw very nice talks. As I said, I've been working at Bloomberg for 5 years, and I'm happy that we decided to sponsor this conference. Just wanted to say a few words about Bloomberg. So Bloomberg is a quite old company. It's been founded in the 80s by Michael Bloomberg. And the goal of the company is to bring transparency into financial markets. And the way they do that is through a software called the Terminal. In the 80s, it used to be like an hardware machine. It was like a Macintosh, but in these days, it's just a software. And this software, you can think as a browser, a private browser that gives you access to a particular web where you have data about finance. So you have financial news, you have stock prices, you have all the information that people in finance need when they do their work. And for people in finance, I mean traders, analysts, government officials, news professional also, because there's financial news and so on. So people think this is a financial company, but actually is an information technology company because there's a lot of technology. They have 19,000 employees, but 6,000 of these employees are actually computer scientists and programmers. So more a quarter of the company is basically developers and engineers. So as I say, I started to work there 5 years ago, and I am part of a group that is called AI. We are around 150 people in this group, and the goal of the group is to use machine learning, NLP, and information retrieval techniques to enhance the software of Bloomberg. So we work in different areas. Recently, we had a paper at ECIR where we show how to cluster news and produce summaries of the clusters. I've been working for that several years on search. And among the things that we did was also like open source learning to rank plugin inside Solar. That is an open source search engine that we use at Bloomberg. That's another thing, like we use a lot of open source. We try to rely as much as possible on open source and to contribute about that. And also inside AI, we try to do a lot of research. So I think that more than half of the people in the group have a PhD, and we try to combine research and engineering inside our work. Said that, I'm really glad and looking forward to the panel. That's mandatory to say, like we are hiring. We have internship, also remote internship at the moment, given these times. And we have a permanent position also available both in New York and London. So if you are interested or you just want to know more about working at Bloomberg, feel free to contact me on Slack. And I'm here. Thanks.
Finance, government, policy, and philanthropy. Every day, Bloomberg customers conduct millions of searches on the terminal, looking for information or news about executives, companies, and financial vehicles. Our information retrieval and natural language processing systems help our clients discover the right information they need. It is a lot, and we know speed and accuracy matter. For example, our customers conduct 16 million news searches a day, a process which begins by typing a simple English phrase into the command line. Bloomberg has a significant ontology of topics, including concepts like technology industry, regions like Asia, as well as codes for tens of thousands of companies, millions of people, and hundreds of thousands of different news sources. Bloomberg's natural language processing engine then translates this request into a specialized search query language using state-of-the-art semantic parsing technology. We then feed that into our search engine, which looks through an index of more than 650 million articles. These are stored in an open-source enterprise search platform that's been enhanced with learning to rank and other plugins developed by Bloomberg engineers. Each story is precisely annotated and classified for topics and companies. Machine learning also produces signals to describe each article. These are combined to create a document score, which is used to rank the document's importance. Using the score, we can display the most relevant stories at the top of those search results, all in less than 200 milliseconds. This is just one way Bloomberg is using technologies like AI to make our information more discoverable, relevant, and actionable.
Thank you. I think we can now continue. So this will be a challenging panel for the panelists, given the different time zones. So a very special thanks to Julia, Chenyang, and Tatseng, because they are doing this panel at such a hot times. And Martin, the floor is yours.
All right, thanks very much. Can you hear me okay?
Yeah.
All right, so welcome to the panel. I think we have an exciting group of people joining the panel. Thank you for joining, by the way, and some of you at very short notice. The topic is drawing a lot of attention, not just in our community, conversational search, but also in lots of neighboring communities, machine learning, language technology, knowledge engineering. And so it's a topic that creates a lot of energy, draws a lot of attention, and we thought it would be a good idea to bring some voices together from different parts of the world and different parts of the community to get some different perspectives and to get maybe a good identification of things that are worth pursuing and things that are maybe just the same old things, but now in a new package. So what we have in mind is we start with brief introductions by each of the panel members. And then I start with some questions. The audience is more than welcome to fire questions either through the Q&A panel or by raising a hand. And then at suitable moments, I'll try to inject those audience questions into the discussion. We'll see where we get. We have an hour, well, less than an hour now. We stop at 4 p.m. my time. I'm not going to translate that into your guys' local time, but we'll just stop at some point. So can I give the floor to you, Tsatseng, to begin with?
Okay, yeah. Can I get a screen or? Oh yeah. Okay, yeah. So yeah, I'm glad that I'm the first to start actually. So I look at conversational search as a constrained conversation to support a very, very targeted search. So you can see from my title, actually I add in one more keywords just to reflect the community I'm from. Actually, I'm kind of in IR and multimedia community. Yeah. So I guess the reason for multimodality is very simple. That actually all the data we see now is actually in multimodal form, and given the success of visual object recognition, we already know that fashion search, product search, and public safety type of searches are actually commonplace, right? Can we go to the next slide? Sorry. Oh yeah, sorry. Yeah. So I thought I'm controlling, but no. Yeah. So actually we can see actually multimodal interaction is actually a lot more natural. Look at the screen on the right. If I want to kind of search for a fashion items, actually I would rather use a combination of text or images, or I can point to the images to basically show the specific part of fashion items that I'm looking for. Okay, next please. So, okay, yeah. So I guess one important reason to kind of inject conversation into search is basically to solve the asymmetric problem of the disconnect between the user's query and the answers. So kind of it's quite easy to basically inject. So it's actually quite important to basically inject a very simple constrained conversation to clarify query, search, and actually to support recommendation. So in terms of research, key research, the next point, sorry, yeah. So in terms of key research, the important research actually are in kind of how to model multimodal context and history, and of course how to conduct constrained conversation to support a very targeted IR and QA, and as you can see from that small window, actually how to do multimodal conversation search in e-commerce, and also in possibly those more visual rich domain. And finally, actually, a lot of time actually we do search through browsing. And one important element that we are looking at is basically how do you detect that the user needs help during browsing, so that we can inject a kind of dialogue agent into the search process to help the user to cut short their browsing process. Okay, yeah, thank you.
Okay, thank you, Tsatseng. I want to move on to and give the floor to Julia Kiseleva, who's based at Microsoft.
Thank you, Martin. So I would like to attract your attention to a particular part of like more general evaluation and especially evaluation of conversational systems. So there's currently we facing a problem like which is well known and understood, especially from the dialogue perspective, that we actually don't have a common way to relate conversational systems for many, many reasons, including that like conversational systems are now designed for multimodal interactions, as just Chan-San said about it. So it includes voice, images, gestures. So like it's all kind of interactions, which is very hard to represent it like as we used to do it, especially in IR, mostly on a text base. So we're also facing interesting challenges from the aspect that is cross-device interaction. So you can interact with conversational systems on your phone and on a desktop. And it also even provides a different interaction signals and different satisfaction signals. So we also noticed that conversational agents, they use in a different situations, which can influence the user behavior. Like you can use your phone in a car, and then you can use the same phone at home, and you will provide completely different gestures. Or like even the way of the way how you evaluate the response will be very different. And one of interesting direction which now is taking more and more, and it's actually mixed initiative. So we initially, at least like most of the community, was thinking about conversational system based on Q&A. So it's just question answering, but sometimes it's now there's research about how to make the conversational system more proactive. When a conversational system doesn't know what to reply or is confused, as probably any human would be in a conversation. So instead of giving you a reply which with high probability is incorrect, how about asking clarifying questions? We're actually going to run the challenge at Sky, Search-Oriented Conversational AI workshop this year on that. Like if you're interested, please participate. And that's it from me.
All right, thank you, Yulia. So let's move on now to Ricardo Souza from Farfetch.
Hello, good afternoon to everyone. Good night to some of you, or good morning to everyone else. My congratulations to the Organization Committee of ECIR, and on behalf of Farfetch, my thank you for the invitation of this distinguished panel. If I might say one shameless self-promotion, I would like to mention that jointly with CMU, EST, and Universidad de Lisboa, we are organizing a workshop on multimodal conversational AI that will happen this year at ECM Multimedia. Just to give you a context of what Farfetch is, Farfetch was born in Europe and is now leading a company in high-fashion online marketplaces, being an e-commerce marketplace for luxury boutiques, and I think customers around the globe for over 190 countries to over 1,200 of the world's best brands, boutiques, and department stores. Farfetch is the leading global platform for luxury fashion, operates a marketplace at scale where lovers of fashion anywhere in the world can shop for an unrivaled range of products. So as science, as what we're doing here is, anyways, we mentioned in the end of the, in the morning of today, which was shared by my colleagues, we've been working a little bit on search, recommendations, organization engines, computer vision and methodology, which are paving the way on how to obtain a coherent narrative in the entire customer journey. So here, customer search, conversational search is key. As we know, WhatsApp, WeChat are already one of the main communication service, and Farfetch recently found that human conversation service with WeChat represented significant conversion rate improvements. There is a challenge, very interesting for our business. In 2017, we have announced the Store of the Future, which is the augmented retail concept that combines the online and digital experience. So one of the challenges with this front is how can a customer interact online, and when he goes to the shop, continues to have the same conversation with staff or everyone that is on the boutique. So in conclusion, our goal is very simple. How can we leverage ongoing work on this topic that was led by Beatrice, Quintino, and Marcelino? We are currently working on providing a unified framework for symmetric retrieval of fashion products. There are a lot of next steps, some of those that already have been addressed by my colleagues, and I'm pretty sure there will be others that we can continue to discuss. Thanks.
All right. Thanks very much, Ricardo. Let's move on to Chenyan Xiong from Microsoft.
Hi. So I wish to briefly share a little bit of my recent thinking about like really what is conversational search. Like it is very hot. Many call it the future, and we all believe it's the next generation IR. But is it just maybe a new interface of the old techniques we already have, or is many things new? So many tasks in some sense in conversational search is very similar, or many of the techniques are shared with previous things we have already done. For example, in terms of conversational ranking, it's much like session-based search. And in terms of learning to ask, like learning to ask clarification questions, is very similar to the query suggestion or search without diversification. And the response generation is some type of maybe a new format of query dependent summarization. And now we're all doing deep learning by neural networks and machine learning before as well. And why and what is new? So I would say some of our recent trend is more like a reaction to the business progresses. So we have portable and devices, we have edge devices where we do have a speaking interface, which is more natural, and it's not only limited to the web browser. And users do prefer in many studies that a more natural experience instead of a keyword search, even in search engine interfaces. And we have more richer media as multimodal things, etc. And in the tech part, many things are now actually more ready than before. For example, the speech recognition is actually working in Teams, and also in Google Phones, we have a live caption, which actually is working pretty well, to be honest. And also natural language understanding nowadays is actually a thing. And even natural language generation, I would say, is really started working. Before, like 5-10 years ago, it's really very prototypical, or sometimes a little bit science fiction to some extent. Also, we are much better in user modeling now. But moving on, I think in the panel discussion, I saw Martin, there's a little bit of very interesting questions that I also have been thinking, like what is new, why we are doing it, what does it mean to IR, etc. So I'm really looking forward to the panel discussion later.
All right, thank you, Chenyan. And finally, let's move on to Hugo Zaragoza from Amazon.
Hello, can you hear me?
Yes.
Great, just trying to unmute myself. Okay, so first 2 words on my background. I've been working on search and machine learning for about 20 years now. First at Microsoft, mostly about search engines. Then at Yahoo, it was a lot more about natural language processing and understanding user content. Then in my own company, WebSys, which was about opinion analytics. And since about 2.5 years ago at Amazon Research in Barcelona. As you can imagine, Amazon works in many areas of conversational search related things, right? From Alexa Q&A, a lot of shopping, music, video. There's a lot of aspects of retrieval that are needed at Amazon in different areas, and there's hundreds of engineers and scientists working in this area. Today, I like to talk from the perspective of the work that I'm actually doing in my team in Barcelona. And so I wanted to propose the idea that actually, I don't think conversational search is that close to search as we think. It's a very different beast, to me at least, in the work that I've been doing so far, because it's no longer about retrieval anymore. And so that makes it really hard. We could talk about that later. In particular, in our work, what we're working on a lot is on trying to figure out what are normal, natural micro terms, activities or tasks that could be solved and introduced into a UI without having to solve the entire conversational problem. So for example, if you were to go to a shop and you say, I want to buy a bicycle, the shopper will not start showing you bicycles right away. It's very likely that they will ask you a question before they show you a model, like, is it for you or for your son? That may be the first question they ask you, right? So for us, those are like micro terms that could already be worked out and introduce into UIs before having to solve the entire conversational search. So we're very interested in this area.
All right, thank you, Ugo. So what I'd like to do now is briefly reflect on the different positions that you guys have formulated, and maybe see if there are some responses from within the panel, and then I'd like to raise some questions. So you just said, Ugo, that conversation is really different for you, from your point of view, from search, from retrieval, right? Chen Yang, you made this comparison that seemed to suggest that in many cases we're repackaging something we've done before. What do you think about Ugo's point of view?
I think it depends on the definition of the information. So if the information is still, say, typical web documents, and you are still interacting with text or multimedia in some sense, I think it's very typical call IR related things. But if it is more like a backhand, like API or Alexa skills, then that's we'll see what do you consider as the umbrella of conversational search. If you think all of these are part of conversational search, I think those parts actually is where conversational search is broaden IR scope in a way that you are also interacting with more structured things, database, knowledge graphs, or even different programs in a way, or systems through natural language, although before it might be Sparkle queries, SQL queries, or API calls.
Okay, thanks. Now, to follow up with you, Chen Yang, one of the areas that you mentioned and that I think is key to us making progress in conversational search, whatever definition we take, is user modeling. And understanding who the user is, what they're trying to achieve, and to some degree, the sort of micro turns that Ugo just mentioned, that they help us, right? Little steps that help us model a current task, ambition, wish, intent of a user. So Julia, you raised the point of evaluation. How do you see the connection between your evaluation agenda and challenges and user modeling?
So I think that it's very different. So difficult from different perspective. We could see like the IR, for example, has a very strong background in evaluation. So like whatever IR task you're gonna take, you probably already have a developed evaluation. So in dialogues, they actually face that because you bring a user into the conversation, and in this case, most of the time it's just dialogues and text and responses. So you don't really have a good evaluation. There's a couple of things proposed, but not a good one. So I think the biggest challenge here is because we don't really know what's the notion of successful conversation. So, and that's a philosophical question, and also like it's more machine learning question. Like because
I also sorry to interrupt you. I also thought that to some degree, whether you're succeeding or failing, I think depends on how well you're able to model your user and the degree to which you're satisfying or not your user. So that's why I thought there might be a connection between your agenda and some of the user modeling points that Chen Yang made.
Yeah, for sure. And also like the user modeling from this perspective, because the user interactions are coming at different levels. So we mentioned it can be image, it can be voice, it can be touch if you do it from the, and obviously there's probably going to be text and clicks. And we don't have yet a good way to represent this interaction. And it's a bigger challenge to actually model this.
And do you see the challenge as, I'd like to unpack the challenge a bit, right? Because evaluation is a gigantic bunch of problems all interleaved. I'd like to unpack it a bit. Is the challenge in the user modeling? Is it in the keeping track of what's going on? Is it in trying to come up with sort of small actions, those micro actions that Ugo mentioned, or is it long-term rewards, short-term rewards? What is it?
So in general, I think first we better focus on task-oriented satisfaction, like a dialogue or conversation after conversation. So and then I think the biggest challenge we're facing right now is that we don't really have also, again, good notion of like what is the satisfaction in this case, like when a user getting satisfied or not. There's many aspects to that. That's because it's like highly personalized, and also because like dissatisfaction is very situational condition. So what can be satisfying to you as your interaction maybe like on a go is not the same as you doing it on desktop. So, and it's like very like now in current models, we don't really deal with that much. So like,
okay.
You can always say that it's not.
I'm going to stop you. I'm going to stop you now. Sorry, because you know, we have a panel and we have a bunch of people online, 100 and something, who all and many of them have questions. So I'd like to have one more definition type question, and then I'd like to move on to a different angle. So there's two questions in the Q&A panel now. Let me see. There's a question that says by Celia, will conversational interfaces display one-shot search and recommendation? In other words, will the digital assistants that we have now displace traditional interfaces, and do we expect a winner? Let's focus on the first half of this question. Are we going to move away rapidly from the traditional desktop type interface to digital assistant type interfaces? Maybe Tatseng, can I give you the microphone? What's your view? You need to unmute.
I guess as I defined right from the beginning, to me, kind of conversational search is something between search and conversation. Conversation is basically is kind of very general. You kind of talk about, it could be talking about anything. It might not be an aim. It might not be just, it could be just for fun. Whereas search is very targeted. And to me, conversational search is basically a very constrained form of conversation to help the users reach, to kind of perform a search in a way. So in a way, to me, it's a kind of very constrained, constrained task-oriented search, right? So in a way, with that definition, actually, it kind of differentiates between dialogue and conversation. And then so actually the main task of conversation to me will be, given the user's query, we need to identify what tasks they want, and then to kind of figure out what are the related information we need, so that we can kind of precisely help users precisely describe their information needs. And as I quoted in the example there, and the way to do it, it could be through images, through text, through this and that. So I see that's a way to go. So whether that could be done in a desktop way, but I guess in a more natural way, when people are using mobile phone to do the search, then the images could come from the mobile phone, images could come from the video, and so on. And that I see in the not a too near future that it's going to happen.
All right, thanks. I'd like to follow up, slightly change perspective, follow up with you, Tatseng. So if we look at the panel, we have mostly industrial people on board, and we have you clearly positioning your research.
Academics, huh?
but positioning your research at the interface of academia and industry, right? You focus on e-commerce. So is this typical? Yes. Would you say that this is how we should think and organize the research around this topic in very close collaboration? Do we depend on this? Is this essential?
I suppose I think the audience question actually kind of pointed out this is a very, very broad topics. And I suppose for researcher, we need to kind of constrain the topics in the way that we can advance. So you can either advance it to problem-oriented approach, or you kind of narrow it down the problem, narrow it down the scope so that you can do a kind of you can advance on the theoretical aspects. The reason I go for e-commerce is because I think from our group, we have two e-commerce startups actually starting from here. One is vSense actually. So the type of problem I mentioned there actually is, two of them are actually very research, kind of industry-oriented problem. For example, how to help users browsing and inject conversation to help them to basically find the products and so on. So through this, actually, we can find a lot of academic problems there.
Okay, good. So that's for inspiration and also to help you scope and focus this very close industrial collaboration. So if we can go to you, Ricardo. So you're like Tatseng, you also have a strong focus on not just text, but multimodal and on e-commerce. So if you were to team up with, say, Tatseng and his students, what would you want them to work on?
Oh, that's a very tricky question.
Very interesting question. Yeah, I'm sure a lot of we can work on that.
There is around multimodal aspect of things. I do believe that the image and text combine pretty well. For instance, one of our recent works that we are also conducting within the academia is trying to understand the particularities of an aspect of a product. Let's say I want floral dresses. I want to understand exactly that I'm referring to dresses. So, and I want the very specific dresses with a pattern floral. So these kind of things are very interesting to understand. We are, and this is the way that Sang was saying, it's bridging the gap between search and conversation, because afterwards they're going to have a retrieval of products that are going to be similar to that one. But most than that is how can we incorporate personalization, my personal style, because I may like, or my wife may like of this kind of dresses, but they are very specific to me. So if I include an image or something that can illustrate what I'm looking for, is going to guide the conversation. And this is one of the things that also Tatsen was saying, and I completely second that, is how can we guide the conversation to a success. In a business perspective, it is of course a persuade. Eventually, our measure of success is I'm going to give an uplift on my conversion rate. I'm going to have my customer happy. He's going to return to my platform, to my marketplace. He's going to continue persuade. And so this is a sense that I see the success of the conversation being measured. How can we transport that in a given metric? It's kind of challenging. One of the things that I also would like to include in these research avenues is how can we separate or aggregate, depending on the angle that we're going to look at it, the browsing and search experience. So because I can interact with the conversational agent because I'm bored, I want to understand a little bit about that marketplace catalog. I just want to understand what is trending, and I would like to have a personal stylist. Please provide me suggestions around the given products that's going to definitely increase the appetite so I can return to the marketplace and persuade. This is nothing brand new. This is something that's already written in the literature, and not just on the scientific side, but also on the business. So this is something that is already being shared across the globe.
Okay. Now, Ugo, in your work, in your own work on these micro actions, do you see a natural bridge to the multimodality that Ricardo and Tatseng were talking about? Would that be, for instance, in your bicycle scenario, are you looking for a bike like this? And then you show an image?
Sure. No, I mean, there's clearly bridges all over the place. There's many ways to have a conversation, and visual is a very important part of it. That's true. That's also true that it's so hard to do this, even just with one modality, that in order to advance a little bit, so you have to work really hard on one modality, and so that goes against. So in a way, sometimes we just want to concentrate on one modality because it's so hard to make any progress. But I think any progress in any modality can help when you bring things together, and also multimodality itself, it's something you can study, how to combine things, for sure.
Okay, so when you say it's so hard, what makes it so hard?
Well, it's what makes it so hard is that we're trying to, well, in my case, at least, depends what you're trying to do. In my case, we're trying to model knowledge, right? So in the case of bicycles, you want to somehow figure out how to model the knowledge we may have about bicycles, and how much you may know about bicycles before you ask the question, and how much you expect me to ask about these interactions, which have to do with conversation and with domain knowledge and modeling knowledge in general in your brain. That's really, really hard. For me, that's why conversation is very different from search, because the expectation is so much higher.
Okay, so then I'm reading two things in what you're saying: modeling knowledge, but also modeling modeling a conversation, modeling what you think is going on in the user's head, in terms of expectation towards you as a machine, in terms of also their perception of what a natural conversational flow is.
Yeah, I think I list in my slide like 6 or 7 very different things that I think you need to have a conversation going. And each one of those things is really hard. And then actually doing them together, it's even harder. But that doesn't mean we cannot do small things. We can already test small things that are amazing. And if you can get away with them, the experience to the user is going to be new and interesting, but still very far from a conversation, of course.
Do you think it's important to be successful with the current state of technology and say the near future, to indicate to users that our machines are still stupid, right? So it's a kind of a expectation management.
I don't think, I mean, people use it if it's useful to them. It doesn't matter if you warn them. If you warn them, it still doesn't matter. Either it's useful to them or it isn't. So when we used our first mobile phones, today they look awful and really, really stupid. But at the time they were great because you could talk to people on the street, right? So in a way, if you make it good enough for people to use it, they will use it. And if it's stupid or not, that's not a question. They don't have an expectation of it being intelligent. In fact, they probably would love it if it could work without being intelligent, right? So the question is, how do you build experiences that make their life easier or more interesting?
Okay. How do you see that, Chen Yang, with your focus on user modeling?
I would say sometimes it's more like a challenge raised by the conversational interface, that the fallback zoom is kind of much constrained. For example, in web search, we have 10 documents to show. We can also diversify. We even have part of the screen, we can even show like different suggestions related to search, etc. So if it's a mobile phone, it's only one answer. You better do it right. And if it's a speak interface, it will be, I got pissed many times when my assistant told me, sorry, I'm still learning, and I have to spend like 5 seconds to listen to it. So I think that part of fallback thing is also a huge difference just because of the interface itself alone.
Okay. Some more questions came in. Let me read out one. The question here is, what is the most important thing that I can do with a conversational search system that I could not do with a regular one? Any takers?
I would say one of it is in terms of pure, say, information seeking conversation, where it is still, say, a search engine that you are trying to find some information on the web. I would say the interaction that we hope to provide using conversational search will be able to help the user to better formulate a more complex information need. So an example would be, for me, when I'm searching about something about a medical disease, I don't have the domain knowledge that I have to often start from Wikipedia page. I have to read it, I have to check everything, then pick the medical term and then go further. So that will be a very tedious and unpleasant and very difficult process for me. So with a more interaction interface, maybe that is possible for the assistant to actually assist me to achieve those more complex tasks. And maybe if I say a little bit more is that in for example, Alexa part or even in Office where traditionally there is not really a search box, but you have to click through all the UIs to pick all the APIs and all the buttons to click. Maybe that is something that you can use a natural language interface to achieve as well.
So there are many possible answers, but an interesting exercise to think, look, let's get rid of keyboards. That's it, no more keyboards. From tomorrow on, keyboards are banned. That doesn't seem like a crazy thing to ask. I mean, at some point they will go away. But until we solve this conversational interaction problem, they cannot go away. We need them, even just to do simple searches, right?
Okay. Anyone else who wants to chime in on this question?
Yeah, I also want to jump on it. And like also, first of all, I think why we move towards like conversational, because it should be more convenient. It just should be faster, and it's a less less of the user resources. So that's something kind of we want to pursue. That's why we have different interactions. And as Hugh said, like we don't use a keyboard anymore. How about that? Like, yes, my mood based on my voice and things like that. Just has to be more proactive, save time much easier, and keep the context.
Okay, thanks. Another question that came in a bit earlier is what about other aspects of conversational search than purely the technology? So together with the panel and myself, there's a strong connection with e-commerce, but of course there are lots of different areas in which you could use a conversational technology. Chen Yang just mentioned a medical domain, for instance. Are there any broader implications that we should worry about, that we should study? We hear a lot about fair ranking, unbiased methods for recommenders. Are any of these dimensions different in the conversational setting? Maybe because we can only give one answer, right? Diversity is a different issue here than in a list-based response setting. What do you guys think?
Okay, I would say
go ahead.
One challenge is that the privacy part is really more challenging to some extent, because it is definitely because you are promoting a multi-turn thing, you're promoting a more personal experience. So all of this with the GDPR and even the ethical part is that if, like, how do we store the data? Where do we keep it? And in academic settings, where do we get more real data? Because when it's 10 turn long or when it's for a month of user experience with the assistant. So I think that's a very tricky part for me.
Okay. Ugo, you wanted to add something?
Yeah, I was going to say the same. Privacy is a big issue, of course, because you get more information from the user and you have to model the user at some point. So that's an issue. The other is that if you're modeling knowledge, you have an even stronger possibility to bias, because when you're doing retrieval, you can bias, but you're going against the entire collection. When you're actually modeling knowledge from the collection, you have even more chance of being biased. So you have to be more careful, I guess, and we have to develop techniques that we don't have to be more careful.
Would you say that that should be a big part of the research agenda in this space?
Yeah, the thing is, research agendas are driven not only by needs, but also by opportunity. And sometimes you have a big idea on something and suddenly you can make a lot of progress and it becomes a big research agenda. Right now in differential privacy, it's trying to get started, but there's not really big ideas. We can work very hard on lots of people and go forward fast. So we need to work hard, but we need a few very smart people to figure out the ways to move fast forward. I think we're a bit stuck in that area. It's a personal opinion, but.
Okay, well, that's what we're here for, personal opinions. Thanks.
And I also want to add that most of the IR was driven by relevance. And I think here, like, we're also facing always all this information over the internet, because like it's not just like one collection now. So like how to take the response, which is also trustworthy, and we take a big responsibility for that, and we need to be able to do that.
Okay. In the same.
Yeah, maybe.
Yeah, go ahead.
Okay. Yeah. So maybe I just kind of follow up on that kind of IR on relevance. I think a lot of kind of requirements for search actually is actually to satisfy users' requirement in both long term and short term. So e-commerce is a very good example. We basically just satisfy users' short term needs. So it's kind of very easy to evaluate. That's why all of us work on e-commerce. And of course, if you start to go into medical, then the requirement is, do I just answer things just to solve your immediate problem, or do I give you information that is kind of longer term for you? I think so. Once you start to go into this mode, actually conversation will become a lot more important, because this is not a question of you ask a question, I give you an answer. In fact, I need to actually figure out. Sometimes I give you a short-term quick answer. Sometimes I want to give you a longer-term answer, because eventually I want to induce you to do the right thing with the right behavior. So I need kind of conversation, kind of feedback, and things like that. So I think the contrast of the two, e-commerce is kind of short-term. Of course, you can think of longer-term needs for e-commerce, but for wellness and medical, that kind of thing, is actually a more important part is the longer term. And for this kind of problem, I don't think it's a pure search problem. It's actually a long-term live conversation type of problem. And so to start with conversational search is probably the right way to look at that kind of problems.
Okay, thanks. Of course, this raises a ton of evaluation problems, a ton of user modeling problems, and then also lots and lots of privacy questions, right? If you want to maintain this long-term relationship with a user, say, of a medical conversational agent, that can be pretty sensitive on many counts. The sort of information that you share, the personal information that you receive, the actions that you suggest, and you know, as a system. So this last part is.
I suppose.
Yeah, go ahead.
I suppose one way to look at it, instead of looking at medication, is actually look at wellness. Just take food, for example. Food relation to nutrition and things like that. Because I think a lot of people are quite willing to share what they eat. So in fact, we have tried out one of these applications, but of course we don't have the resources to basically make it long term. I suppose people are actually quite willing to share what they eat, and then in return, if you can tell them the whatever information that helps them in their wellness and the health and so on, and that could be one way to go that has less privacy concern. But once you go into medicine, I think that one is actually a lot of privacy involved, and this is a very hard area to get into.
All right, I'm trying to read some of the questions that are coming in while you're talking, Tatsing.
Yeah.
Right. So here's one that maybe goes back a few steps in our conversation today, but let's go through it anyway. It's a question by Mohammad Alianejadi. Let's assume that we have a perfect model that's able to understand very complex user inputs submitted to the conversational system. What else would be instrumental for the success of that system? So very complex needs, very complex user inputs. And so if we take, for instance, the scenarios that you were just sketching, Tatsing, not short term, but somewhat longer term, what would we need, for instance, in this medical or health or well-being?
I suppose the assumption there is that we are able to express our needs in a very complex query in a very precise way, but I don't think many people can do that. In fact, most of us cannot do that because we basically think a step at a time, and so actually conversation engine is in a way is the main requirement is basically, I think a lot of people talk about personalization, talk about your requirements. Based on your requirements, we kind of try to ask simple questions so that there's no pressure on the users. Basically, they just have to answer simple questions and things like that, and then collectively you refine your needs. So in a way that kind of how do we formulate a complex question actually is probably a perfect way to look at the role of conversational search. It's basically to how we break down that complex requirement into very simple requirements.
Is that also how you? Thanks, Tatsing. Is that also how you look at it, Ugo, with your micro actions? Do you do that with the perspective of trying to understand complex needs? Do you build up somehow an understanding of that complex need through these small steps?
Yeah, I think so, because I think
sorry, Tatsing. This was for Ugo. We'll come back to you later.
That's okay.
Oh, sorry. Oh, sorry. I thought you were pointing at me. Sorry. Yeah, you go ahead.
It's funny because you started with yes and I started with no, so it should be interesting to hear. So we don't for the moment. Of course, you should at some point, but I find it extremely hard already to get just one or two of those. So combining them into a coherent, complex task, it's quite hard. Of course, it depends totally on the application, so and the UI and everything else. So in our case, we don't model users, and so at the moment at least, and so it's more of a turn-based with very short memory, and that's already very hard for us.
Okay, clear. Is the team that's working on this with you? So this is a slightly different question. The team. Is that a team of engineers, or is that also a team that has maybe experts in behavior, experts in
no,
human
it's
cognition?
Our team is at classical search, NLP, and engineering. So about half of them are scientists in search and NLP, and the other are engineers.
Okay.
But of course, we are collaborating and talking all the time to designers and people who have ideas about how a shopping page should look like at Amazon, that kind of thing.
But this idea of trying to understand whatever that may mean, a user or what a user is trying to achieve, that's for you, that's mostly first and foremost an engineering question.
I don't know. It's a question, and we have engineering tools to approach it. I don't know if it's an engineering question or not. But yeah.
Okay.
Yeah.
How do you look at this, Chen Yang?
I think it's more of a now we have some intermediate engineering solution to some extent. Yeah. For example, you can define the different templates and then just build a very good parsing system to those templates. But the definition of the templates could be very expert, very manual. Like it could be a okay solution for now, but does it address the problem? Is it transfer the problem to engineering problem? I don't think so, because the space of the templates is just infinite. Right? And also the question is very interesting. Goes back to the original question in the panel in the QA box. Is that what does it mean to have a perfect user understanding of the user information need? What will be the format if you give them a system? What will the system provide me? The only thing I can think of maybe is something like a very good structural query, like written by Bruce Croft or someone, or a very complex preset logic form, like this big with all the symbols in it. So maybe when we have that, let's see if the user is just as per users are able to type in that. I think the other thing missing would be how do we understand our content in that format as well? How do we? So if our content is just a very clean structured database, maybe that problem is solved. But many times it's not the case. We have web, we have text, we have image, we have like 100 different tables or different thing that is missing. So that part, I think, will be the other end of the conversational search system, that besides the understanding of the user information need.
But don't you think that, for instance, using the templates is going to reduce at least the angle of possible answers, and eventually is going to lead to a lot of dead ends on the conversation?
Yeah, I think so. I think that's why I also call it a intermediate engineering solution. Okay. In a way that, for example, I can write pretty good templates to set alarm, but for any other task or skill, we'll need new templates. And how do you generalize from a template of one task to other task? It's also, I don't know. For example, I heard research about you can write a very good expert intermediate structure guidance, like labels, for one parsing task. But all the information over here is very hard to even transfer to another similar parsing task that just use slightly different template definition. So I think how do you scale that up, how do you generalize, I feel like it's very hard research problem to me.
Okay, thank you. We started a bit late due to technical issues, and we're now beginning to run out of time. So what I'd like to do is pick up one more question from the Q&A panel and ask all of you guys in the panel to think about one short message you have for our audience. What should they do? What should they tackle? What should they not do? What should they not tackle? It's up to you to either give a positive or a negative message. So let me scroll through the list. So here's maybe a question for you, Ricardo, because you talked about fairly rich way of organizing the interaction with users. But it's a question by Celia, and the question is: Will the boundary between search and recommendation get further blurred with conversational interfaces?
Definitely, I completely agree.
Okay, well, that's clear. Okay, I think so too.
Why do you think so?
Well, because well, I'm the moderator, but let me say it anyway.
No, please go ahead.
So I think often we don't really know what it is that we're looking for. Often we don't really know how to verbalize our need. And then if in some sort of mixed initiative, a bit of search, a bit of recommendation, a system can help us forward, it doesn't, then that's what we need to achieve, not whether I search or whether I just passively log on and get stuff recommended. So parting shots, can I start with you, Julia?
On the same question? Yes, I hate to say.
No, just what should the community do next?
I just started with that. Like, if I would like to pick the one thing what community should do next is like, actually, along with this question on recommendation, make interactive system, meaning that like system can also ask user questions to clarify on something. So this way, like actually users like to be asked, and users like to be kind of, this way they feel in control, they feel they guide in the system. And there's one thing. And second, also like give the system being able
only
to-
one thing. Sorry, only one thing.
One more thing.
No.
And one more thing is like also just think about interfaces which leaves user the space to correct the system. Because most of the time the idea is like we only can ask
in other words, if I can summarize this, sorry, I'm the moderator. If I can summarize this, make it an actual conversation. Get closer to that.
Yes, making it actual conversation, and don't call it just a conversation.
That's saying.
Yeah, I guess
you would like to share with the community.
Yeah, the differences between, I suppose, dialogue, search, and recommendation actually are blurred now, because I think if we deal with complex query, we need a combination of all to actually help the user handle the problems.
Okay.
So I think we should look at all as a single problem rather than three different disciplines.
All right, clear, thanks. Ugo, you have anything to add?
No, I would just say that if you're planning to research in conversational search, I think it's very important not to think of conversation as something, because it isn't. So think of a task, of a real situation in the world that you want to help. And if it happens to be a conversational aspect, that's great. But conversation outside of a direct application doesn't mean anything. Alternatively, just forget about applications and think of really hard NLP problems like semantics and induction and things like that. But being in the middle, it doesn't help, I think.
Okay, being in the middle doesn't help. That's in general a good idea, a good advice. Ricardo?
I was just mentioning the generalization, which we were referring moments ago. How can
Generalization?
how can we evolve these systems?
Okay. Chen-Yang?
Although I'm as someone who mostly working on the modeling part, I actually think the most pain point for me in conversational search is definition and measurement. So it's a very big concept. It's like calling information retrieval is a task. So actually, what are the tasks? What are the different scenarios? What are the problems in this space? I think it's kind of not very clear to me, at least. And also the measurement is not there. Sometimes we pound by calling utility. Sometimes we pound by fallback to the typical relevance definition. By also different types of conversational search may need different measurement, different evaluation. And also all those parts I think is pretty unclear. And without a good definition and measurement, it's mostly like this paper is doing this, the other paper is doing that. Everything makes sense, but it's not clear what is the real progress forward to me.
And the positive twist to that is we have many challenges ahead. I want to point, we need to conclude, our time is up. I want to point out that we have a Slack channel devoted to the panel. Oh, and I'm just being told now that it's the general channel on Slack. So please share follow-up questions on that general channel on Slack for the conference. Before you run there, please join me in thanking Ricardo, Julia, Ugo, Chen-Yang, and Tatseng. Thank you guys, and thank you for staying up late, for waking up early, and for contributing.
Thank
you,
everybody.
Thank you.
Bye-bye.
Thank you very much.
Bye-bye.
Congratulations for an amazing panel.
Thank you.
Thanks.
Thank you very much.
Yep.
So if the presenters for the session could raise their hand, that would allow the host to make them panelists. So we don't yet have the speaker for the first paper, but Sian Shan, would you like to go and try and present, share your screen, make sure that you can present as author of the second paper? Oh, hi, Anastasia. Sian Shan, can you try and present your screen? We'll just have you test your screen first and your microphone.
Okay, so
yes.
Oh, here's Anastasia. Okay, Anastasia's first.
Anastasia, I'm here. Let me try to share my screen. How can I?
So then you should have a button at the bottom of the Zoom window, a green one saying share screen.
Yeah. Yes, I can see it. Is it
Yeah, can it be bigger?
bigger?
Yeah, is it? I'm just trying to see, does it seem quite small for other people? Maybe not, maybe it's just my computer. That's fine. Yes, that's fine. Okay. And the audio seems fine. Okay, do you want to stop sharing? We can, the other presenters can just test quickly.
Okay, so I stop sharing here, right?
Yeah. Ian, Shan, do you want to test?
Yes. Can you see my screen?
I can, that looks good, and you sound good. Okay, that's fine, thank you. Third paper.
Me, Saurabh.
Okay, Sarah, do you want to try and share your screen? Yeah.
Sure.
Okay, and then speak as well, please.
Yeah, I am presenting my paper.
You're quite quiet. Speak up, please.
Oh, yeah. Hello. Can you hear me now?
Yeah, we can hear you now. That's great. Thank you. Okay, so the fourth paper, Abhilasha.
Yeah, I'm right here.
Okay, do you want to share your screen?
Yeah. Okay, can you look at my screen?
Yeah, but you have to present the slide. You have to put it into presenter mode.
Yeah.
Yeah, okay, I can see that. Can you say a few sentences?
So this paper is on reinforcement rewards framework for textile transfer.
Okay, you might need to speak a little bit louder, but that sounds good. Okay, thank you. You can stop sharing.
Yeah. Yeah.
And Gustavo from Delft, you're the last.
Okay, let me try to put on presenter. Can you see it properly?
Yep, we can see it perfectly. Thank you. Do you want to say a few sentences?
Yes. So the paper is on curriculum learning. My name is Gustavo Peña from TU Delft.
Okay, great. Thank you very much. Okay. So we can go back to the beginning. So Anastasia, do you want to share your screen?
Yes, sure.
Okay. So we have, the schedule is there's 100 minutes for 5 papers. So we have 20 minutes per paper. I think you were all informed by email that it's 15 minutes for presentation and 5 minutes for questions. So I will try and warn you of the time, maybe by flashing a timer like that. It doesn't really work, or I'll give you a verbal warning if you're about to run out of time. Okay. But that is, I think we have everybody, and everybody's slides appear to be working, and it sounds good. So I think we're in good shape to start the session just after 20 past. Okay. Host, did I miss anything?
Oh, sorry, my sound was not working. I think we're ready to go. There's someone with her hand raised, but I don't think it's an author.
Say again, there's something.
There's someone with her hand raised, but I don't think it's an author, so
okay.
Ready to go. Okay, it's fine.
Okay. And the presenters should turn their cameras on as well, preferably.
Okay.
Yeah. Okay, so we will give it another minute or so and then we'll start. Okay, so my clock says 20 past, so I think we can start on schedule. So welcome everyone to Deep Learning session number 4. Okay, this is the final A session of the conference, and we have 5 excellent papers for you. Okay, so we have lots of attendees in the room, some really exciting papers, and I hope we can see lots of engagement from these participants. So as this is the last session, I hope I don't need to remind you that the audience can use the raise hand functionality if you wish to ask a question, or you can write the questions in the Q&A, or you can also discuss the papers in the Slack channel, and I think that's deep learning, okay? But the authors would really appreciate the opportunity to answer your questions at the end of their talks, okay? So we have five papers. The first paper is entitled Biconditional Generative Adversarial Networks for Multi-View Learning with Multiple Views. And the authors are from the University of Grenoble-Alpes, and the speaker is Anastasia Doyonko, and our co-author is Matia Reza Amini. Okay, so Anastasia, when you're ready.
So hello, everyone. Thanks for joining my presentation. I'm a second-year PhD student at the University of Grenoble-Alpes, along with Matia Reza Amini, who is a professor of computer science. I'm studying multi-view learning problems, particularly in case we have missing data. The paper I'm going to present proposes a solution that employs conditional generative adversarial networks for classification tasks where observations have two views, but one of them may be missing for some training samples. I will start my presentation with an introduction to a problem. Next, I will give a short explanation for generative adversarial networks and justify why we decided to take such a model as a foundation for our approach. Then I will look at the framework we propose and finish my speech with presenting the experimental results. So let's start. I think everybody has heard about multi-view learning. It is a direction of study in machine learning that employs multimodal data. For instance, in web page classification, there are often four views for describing a given web page. First two is the text and graphical content of the web page itself, and second is the content of any web page linking to this web page. Multi-view data are very common in real-world applications, and that drives a high demand for approaches that can learn from diverse sets of features that define a very the same object. Overall, well-designed multi-view learning strategy has better generalization ability than single-view learning. Therefore, many advances have been made on both theoretic and algorithmic sides. The three main families of techniques for multi-view learning are canonical correlation analysis that finds pairs of highly correlated subspaces between the views that is used for mapping the data before training or integrated in the learning objective. Next, multiple kernel learning considers one kernel per view, and different approaches have been proposed for their learning. And core regularization techniques tend to minimize the disagreement between the single view classifier over their outputs by adding the regularization term to the objective function. However, all these techniques assume the views of samples are complete and available during training and testing. But in practice, observations often have missing views. This is a typical situation for many industrial applications where different sources generate different views of samples unevenly. For instance, if we recall the sample with web pages, we can note that not all web pages have image content, or for example, multilingual collections may have documents that are not available in all languages. Some studies tackle this problem by assuming the existence of view generation functions to approximately complete the missing views. For example, machine translation to translate documents into missing languages. These functions generally require an external resource to be set, and their quality has a direct impact on the performance of the learned multi-view classifier over the completed training set. On the other hand, our motivation is to address this problem by joint learning the missing views and the multi-view classifier. In this direction, generative adversarial neural networks provide a propitious and broad approach with a high ability to replicate the data distribution and create new samples. These models have been mostly applied to image analysis. For instance, they are successfully applied for image domain transfer or missing pixels imputation, which made us to suggest that we can use it for missing views imputation and adapt it for joint learning, which is our goal. So generative adversarial networks, these models takes their origin from the game theory and are formulated as two players game formed by generator and discriminator neural networks. The generator takes a noise vector as an input and is supposed to produce a sample from the feature space, but it doesn't train directly by qualitative comparison of distributions of real and generated samples. On the other hand, we have the discriminator that determines whenever a sample comes from the true distribution of the data or if it's a synthetic object that came from the generator. The classification error is a basic metric for training of both networks. So discriminative network is trained to minimize the final classification error, and at the same time, generative network is trained to maximize the very same objective. In other words, the two-player minimax game can be written as the following equation. And that's all I have to say for a short introduction to generative adversarial networks. And now I would like to move on to deep discussion of biconditional GANs for multi-view learning with missing views. First, I will present the basic definitions which will serve to our problem setting. So we work with bilingual collections of documents. Each document was preprocessed and then represented as bag of words using TF-IDF-based weighting scheme. Thus, each document can be represented by a sequence of two vectors from dictionary space of two languages. Nevertheless, there are documents in the collection that are presented not only in one of the languages, and for those, we say that their second view is missing. Next, each observation belongs to one and only class. The class membership indicator is vector Y, and we use one-hot encoding to create vector of labels over K classes. For the training test, we assume that each example is identically and independently distributed according to a fixed yet unknown distribution. We define our data for training in the following way. It consists of three subsets. SF denotes as a subset of training samples with their both complete views, full subset, and S1 is a subset of training samples with their only first view available, or the only second view available for S2 subset respectively. Our goal would be to generate missing views for examples from S1 and S2 subsets, jointly with the learning of the association function between the multi-view samples and their classes. So that brings me to description of the model that we propose for bilingual text classification. It is composed of discriminator and two generators networks formulated as three-parted game, and let's discuss it in details, each of the components. So generators are supposed to produce the corresponding missing view from random noise conditionally on the observed view. For instance, generator 1 takes as an input vector of second view from subset S2, concatenated with the noise vector Z from uniform distribution of the first view's dimension. The architecture of generator is a fully connected neural network with one hidden layer that employs sigmoid function as an activation. The output for generator 1 is a synthetic first view that initially was missing. Generator 2 is defined likewise. These models are trained in a way to replicate the conditional distributions, one view given the other one. But this distribution of synthetic views and real ones are not compared directly. Similarly to GANs, we are going to have discriminative neural network. In other words, discriminator, which poses the simplest multi-view strategy and takes both views concatenated as an input, and then perform classification tasks. First, it has to recognize observations that are partly synthetic, which means that we created, say, a fake class for it. While additionally, for samples from full SF subset, the discriminator is learned to classify those samples to their original classes. Thus, the discriminator predicts a posterior probability over K+1 classes. After all, we would like to have a function that assigns a multi-view observation to its class according to a max argument of probabilities over real classes, in case the probability of being fake is small. So in this way, we have just defined the game with three players that implies joint learning of two tasks, missing views imputation and classification. Generator's goal is to generate views such that the completed bilingual documents will have high class assignments. Discriminator's objective is to be certain of the class of the observation with their complete views and the uncertain of the class of documents for which one of the versions was completed. This procedure resumes to the following objective functions, and unique global equilibrium is reached if and only if the real marginal distribution of pair of views is equal to the one when the other view is generated. As soon as I'm short in time, I will not provide all the theoretical proofs, but you can refer to the paper for it. And moving forward, I will present experimental part of our work. We performed experiments on publicly available collection extracted from RCU1, RCU2 dataset. It contains numerical feature vectors of documents originally presented in 5 languages that are categorized to 6 classes. In our experiments, we consider 4 pairs of languages with always English as one of the views. And the case where the number of training documents having their 2 versions is much smaller than those with only one of their available versions. So, and we start our evaluation by comparing F1 scores over a test set obtained with our model and a neural network having the same architecture as the discriminator trained over the concatenated views of documents in the training set, where the missing views are generated by machine translation. Each point and figure represents a class, where its x-axis represents the test F1 score of the neural network trained using machine translation, and y-axis represents the score of the proposed biconditional GAN. All of the cases in the different language pair scenarios are above line of equality that clearly shows an advantage of joint learning. We now examine the gain in terms of accuracy of learning in different multi-view approaches, which I presented in the introduction, on a collection where for other approaches than ours, the missing views were completed by one of the generators of our model. This unit identified by way of hat in table. Table summarizes these results for both test scenarios. Reported performance is an average over 20 random trained test splits. In all cases, biconditional GAN provides significantly better results than other approaches. This gives an empirical evidence of the effectiveness of the joint view generation and class prediction. In the last experiments, we tried to see the performance of the method in case of huge imbalance in S1 and S2 subsets. We run biconditional GAN with the following settings. The number of samples in SF subset is small as before and fixed. The number of samples in S1 is large and fixed too, but the number of samples in S2 is growing from small to large. The results we compared with a single view classifier, which is neural network, trained on the same S2 subset. The charts show that biconditional GAN can leverage the lack of information from training samples having their other view observed. The last, I present a random document in English from the test set, and the top 20 words in the feature characteristics of the generated vector in different languages from this document. You can see that generator is actually producing a vector of most meaningful words in target language vocabulary, which explains why use of this additional information is actually improving classification task. In the last minutes of my speech, I would like to conclude the main points of the work that I presented today. We proposed a solution for multi-view, multi-class classification problem where observations may have missing views. The model consists of 3 neural networks implementing a 3 players game between a discriminator and 2 generators. We have showed the results of experiments that proves the effectiveness of the joint view generation and class prediction over single view classifiers and the other multi-view methods that rely on external methods for view imputation. As future study, we will work on generalization of the proposed model for more than 2 views, or testing it on the data set from the other different domains. And that brings me to the end of my presentation. Thank you for your attention. I'd be glad to answer any questions you might have.
Virtual applause for you, Anastasia, and thank you for your excellent timekeeping. Do we have questions from the audience? I see one hand up. Could the host promote Ting Su to allow her to ask her question? Host, okay, I can click.
Hi, Anastasia. Hi. Thank you for your presentation. I don't really know much about GAN, but I heard that it's really game-changing for image recognition. But from the results you presented, it's not so significantly better. Like, I mean, yes, it is significantly better, but it is not so much better than the other traditional models. Do you know why? Like, do you have any insights on why the GAN on text is not so great than the text on image? The GAN on image?
I would say that probably, I mean, in our case, that we consider the simplest case where we give the GAN the actually vocabulary space with the coefficients of the words we were using. I would say that probably if we would use more advanced models in order to have notion of a sequence of words in the text or something, we would have better improvements even with GANs compared to other methods. So I feel like in other domains rather than images, we could apply the generative adversarial networks in order to see and compare, and there is the cases where it can be better. So yeah, in future study, I think we would see the improvements by applying more advanced models that will take into account the features of the text, not just vocabulary that we're using now.
Okay, thank you very much.
So Anastasia, I have a question. So in your example, in the introduction, you showed us image type views. You showed us possibly web pages being represented by their inlinks, but certainly the focus of your experiments was on multi-language documents. So what kind of other tasks can you imagine that would be amenable, that have this multi-view of the same item, that are relevant to information retrievals?
Basically, we would have like in web pages or the other our objective is to go to the domain of the studies where we have several views. For example, with web pages, so sometimes we have lack of information, and the thing is that even with web pages, I was saying that sometimes we don't have images or text. And the thing is that GANs wasn't not used before with a lot with text, but our model shows that it can be used good. So basically, for the example I provide, we can combine views with images and text, combine this GAN to complete the maybe missing information, because we know that the same information can be presented in pictures or in text. So basically, if we can predict the picture from the task and then solve the classification problem, we would advance in this. And the thing is that if we can do this jointly, maybe we can advance more. So that's pretty much for our future plans, yes. So,
great, thank you very much. So I think that's all we have time for. Thank you very much, Anastasia.
Thanks.
Okay, so do you want to stop share screening, and then Zia and Shan can pick up? Zia and Shan, can you share your screen?
Yeah, sure.
Okay, so the second talk in this session is an attention model of customer expectation to improve review helpfulness prediction. The authors are Zian Shan Q, Xiaopeng Li, Xilla Farkas, John Rose, all the authors are from the University of South Carolina, Columbia, and Zian Shan is going to be presenting. So Zian Shan, when you're ready.
Hi everyone, good afternoon. My name is Zian Shan Q, and I'm a PhD student in University of South Carolina. Today, I'm glad to present our research work, an attention model of customer expectation to improve review helpfulness prediction. So first, this is the outline of my presentation. It consists of 5 sections: introduction, related work, proposed model, evaluation, and conclusion. So first, according to a survey, about 90% of consumers will read online reviews before they are making purchase decisions. However, there are a large amount of reviews online, and the quality of the review vary greatly. So it makes it hard for customers to decide which reviews are helpful or not. So this introduces our research problem. So the research problem is to predict if the review is helpful or not. So the problem is defined as a helpfulness is equal to the overall helpful votes a review receives divided by the total votes a review receives. So here we also take advantage of the previous commonly used value 0.75. If the helpfulness is greater and equal to 0.75, we consider the review as helpful, or else we consider it as unhelpful. So for this research problem, the previous research work can be divided into 2 branches. So the first branch is the traditional machine learning methods. So for the previous researchers, they either extract features from the review text, so such as emotional features, the emotional words, emotional sentences, or some structures features, such as a number of words, a number of sentences, and so on. And also some machine learning models are all applied, such as the support vector machine, the random forest, and so on. So in recent years, as a development of the deep learning models, some deep learning models are also proposed for this research problem, and the normal frameworks are proposed based on some basic deep learning models, such as a convolutional neural network, the recurrent neural network, and so on. However, from the previous related work, there are some disadvantages. So the first disadvantage is that the review sentiment was not used to identify the useful information from review text. So although the review sentiment has been used before, it is used as a single feature in previous research work. So the relation between the review sentiment and the useful information in a review text was not considered. And the second disadvantage is that the unique aspects of each product was not considered. So although some common features like the from a particular product are considered, the unique aspects such as the different levels of importance for each attribute are not fully identified. So based on these 2 disadvantages, we proposed 2 contributions. So the first contribution is that we make use of review sentiment to identify the useful information from the review text. So here is an example. This is a review extracted from the Amazon. So this review has a rating star of 2 out of 5. So which reveals a relatively negative sentiment. So when the customer read this review, they may pay more attention to the negative descriptions compared to the good descriptions. So this is the intuition of this contribution. We want to relate the review sentiment and the useful information of a review text. So for the second disadvantage, we propose a second contribution, which is identify the unique aspects of each product. So here is an example. We have two mouses. We can see that for both mouses, they have some product attributes and they have some common attributes like the easy to install, easy to use. And most importantly, for each mouse, they have some unique product attributes, such as for the first mouse, it has lightweight, it is value for money, and for the second mouse, it is easy to install and has sleep mode and is good for gaming. So the second contribution is to identify the unique aspects of each product attribute from the review text. So based on these two contributions, we have this model framework. It consists of three parts. The first part is a base model, which is a hierarchical bidirectional LSTM. The second part is a sentiment attention layer, and third part is a product attention layer. So these two attention layers correspond to the two contributions we proposed. For the sentiment attention layer, the purpose of this attention layer is to identify the sentiment-related information from the review. So for example, for the review on Amazon, they always have the rating star from 1 to 5. So we use the rating star to represent the sentiment of the review. And then we calculate the similarity between the sentiment representation and each word or sentence of a review text. And the calculation is based on the score function. And then after we get this similarity value, we convert it into a value between 0 and 1 based on the softmax function. So you can refer to our paper for more details. The second attention layer is the product attention layer. It consists of two parts, product 1 and product 2. So product 1 represents the unique product attributes. Here we use the unique product identifier to represent these attributes. We convert this identifier into an embedding. And second is product 2. It represents the common product attributes. So we make use of metadata of product and such as product titles, product descriptions, and extract the important features through a convolutional neural network. Then we represent the product based on these two kinds of product information. And similarly, calculate the similarity between the product representation and each word or each sentence from the review text based on this score function. So next, to evaluate our proposed model, we use two public datasets, Amazon dataset and the Yelp dataset. So the dataset statistics are shown here. And to evaluate our model, we make use of a metric, which is the area on the curve. This is also a commonly used metric in previous work. We also explore two application scenarios. First is a cold start. Second is a warm start. Cold start means no reviews of a particular product has seen before. So which means for the product in the test dataset, no reviews of a particular product has been seen before in the training section. But for the so all the products in the test set can be considered as a new. So for the warm start section, it means some reviews of a particular product has been seen before. It has been used for training. So we consider these two commonly seen application scenarios. So first of all, the application scenario 1 cold start, we have some results from the previous research work. First of all, the Amazon dataset. Here is a result. Each column corresponds to a result for each model, and the last column is a result of our model, and the second last column is a state-of-the-art model. So from this Amazon dataset, we can see that our model has improved the result by approximate 5.4%. So similarly, for the Yelp dataset, on average, our result, our model performance have improved the AUC by approximate 1.5%. We also conducted the significant test, and the result shows that our model is significantly greater than the state-of-the-art model with a p-value of 0.001. So which means that our result is significantly greater than the state-of-the-art models. We also conduct some further analysis of the different model components. So here we consider 4 different model components. The first one is a base model, the hierarchical bidirectional LSTM model. It has 2 levels, the word level and the sentence level. The second model component is a base model plus sentiment attention layer. The third model component is a base model plus a product attention layer. And the fourth model is a complete model, which consists of the base model plus sentiment attention layer plus product attention layer. So the purpose of the further analysis is we want to know like if each attention layer makes a contribution to the final result. So first for the cold start application scenario, you can see that for all the models can improve the performance from the base model, and the complete model has the best result. And for the second application scenario, warm start, it has a similar result. The complete model has the best result. And both adding the attention layer, sentiment attention layer, and product attention layer can also improve the result. So next, we want to have a visualization of these attention layers to see what they have learned by these 2 attention layers. So here we have 2 examples, and the words in color are the keywords learned from this attention layer. So from the first example, we can see that first for the product attention layer, the words related about the product attributes are paid more attention to, such as fit, top, enough. And for the sentiment attention layer, because this review has a rating star of 1, which is a negative sentiment. So the words which reveal negative sentiments are paid more attention to, such as did not and return. So from this research work, we have the following conclusions. First, we propose a novel neural network. We make use of the review sentiment and product unique attributes. And this model shows a AUC improvement of 2 public datasets. And we also validate the effectiveness of each attention layer, the sentiment attention layer and the product attention layer in 2 application scenarios. Okay, that's it for our paper. Thank you, guys.
Thank you very much, Yan-Shan. So I see we already have questions coming in. So the first question is by C. Wang from the University of Glasgow. So you go ahead.
Hello. So
yep.
Thank you for your presentation. And I have one question, which is about embedding, because I have I read your paper, and I remember you were using growth embedding as input, a pre-trained growth embedding. So according to the state of art, the bird contextual word embedding can be helpful to a lot of different tasks. So did you try to compare your model with bird-based embedding to see the difference?
Yes, like we have tried several pre-trained word embeddings, like the word-to-vec, glove embeddings, and finally we make use of glove embedding as a final embedding. So you want
because all embeddings you are used now is non-contextual word embeddings. So it's quite intuitive. If you use sentiment information, it can be helpful. But if you use a contextual word embedding like bird or some other contextual word embedding, I don't know whether the sentiment information can still be helpful.
Oh, I see your point. So I haven't tried like bird embeddings. So maybe in the future I can try this kind of embedding and to see if the performance can be affected. So, but previously we have tried to train a word embedding based on the similar context. So you see my point, because like for the word-to-vec embeddings, it is trained on the Google News. So the context may be different from ours, which is about the product electronics, like products. So we also try to train like embedding based on the similar context. So this kind of embedding has better performance compared to the word-to-vec embeddings, because like for the word-to-vec embeddings, there are a lot of out of vocabulary words. So that may be also a reason why it do not have a good performance. So yeah.
Thank you, Zian Shan. So Jeff Dalton asked a written question, but I think it's essentially the same as what she asked. Did you consider using a pre-trained transformer model? Maybe Jeff, do you want to host? If you could ask Jeff Dalton, maybe if he wants to adapt his question or still ask it. No, okay. The next, we've got time for one more question from Ting Su, and then Zian Shan, there are written questions in the chat that maybe you could respond to after the presentation is over. Ting, go ahead.
Hey, can you please go to the second last slide? Second last. Yes, there. So here I see that when it's negative or positive, you can see like something called like did not and return and great and uses and these. I was thinking that these actually are some kind of like intuitively I would think that they are stop words. So your attention weight actually focus on the stop words. What's the point of it?
I fit all the whole text into the deep learning model, because we know that for the previous traditional learning models, we may want to remove the stop words. But for the deep learning models, like for the previous released work, what they did is fit all the text, just maybe did some pre-process, like convert it into lowercase.
Yeah, I know the transformer type, but what my point is that if the important words that you highlighted here are mostly stop words, then you're just finding the extreme emotions.
You mean for the sentimental attention layer?
Yes.
Yes, like we know that for the reviews, a lot of the reviews have like the extreme ratings, like from 1 to 5, maybe 1-star rating, and 5-star rating has more reviews than the other sentiment. So our attention layer actually may have more effect with these extreme ratings, extreme sentiment. Yeah.
Thank you very much.
Okay. So thank you, Zia and Shan, once again for your presentation. So as I said earlier, there are questions in the Q&A down the bottom that I'd like you to respond to as well. Okay. So if you could stop sharing screen, and then Sarub can take over. Thank you very much. Sarub, do you want to share screen?
Can you see my presentation?
We can. So the third paper in the session is entitled A Neural Architecture for Question Answering Using a Knowledge Graph Web Corpus. And the authors on this paper were all at IIT Bombay when it was published. If I remember correctly, this is an information retrieval journal paper. Yes, so this is a journal paper that Sarub is going to try and condense into 15 minutes for us. So without any delay, please.
Yeah, thanks. So hi, I'm presenting our work on neural architecture for question answering using KG and corpus. Currently, I'm a first-year PhD student at Carnegie Mellon University. Let's get started. So day by day, there has been an increase of structure in web queries. At least 57% of web queries mention entity or target type category. By simple analysis, it shows that at least 29% of queries directly mention entity, and by refinement, we can increase these numbers. Let's consider this simple query, which scientists use to play violin. Clearly, in this query, we have the target type mention scientist and the entity mention and the relation mention played by. Let's consider another query, which institute cloned Dolly. Again, here there is a clear mention of institute, which is our target type. Hence, there is a increase, or there is a lot of mention of the target type, which means there is an increase of structure in web queries. But one might ask, why not feed these models into BERT and take softmax over candidates and get done? In fact, there are many BERT-based encoder-decoder QA systems which are being used for single clause and multi-clause question answering. However, recent probing studies have shown curious phenomena around complex QA benchmarks like hotpot QA. First, these systems can cheat using implicit type analysis and not do the multi-hop reasoning. Second, these best systems, although they can answer complex queries, fail on answering subqueries at least 40% of the time. Therefore, we see a clear need for interpretable QA architectures. Now I'll just briefly go over what a KG is. A KG is hierarchy of types, where entities are connected to one or more types. And we have transitivity with ancestors. Relations are denoted by binary edges. For example, here, book, who is written by an author who is a person, and Albert Einstein, who is a physicist and also a person. KG is often very useful, but incomplete in the sense that it does not contain all the information that is there on the web. So why do we use KG along with corpus as our title suggests? Let's consider a very simple query. Band, Jimmy Page was in before Led Zeppelin. In this query, if we consider a simple entity linger and target type identifier, we can identify that Jimmy Page is the entity mentioned E1, and band indicates the target type musical group. Was in is a keyword which can be used to identify that it is a member of musical group. But the query interpretation is incomplete without considering the token before. That is, even when we execute this query on KG, we will be able to identify target entities E2, which include Yardbird, but might not be able to give higher weight to Yardbird, which is the correct answer. Generally, KGs have very sparse time steps on membership, or they don't. Hence, we see a use of corpus. For example, corpuses usually have sentences like about Page's work in the Yardbirds prior to Led Zeppelin. By a simple matching, we can map the word prior to before and match the word Led Zeppelin to increase the score of yard words in our ranking, which matches the KG entity, the yard words. Hence, we increase the score of yard words in our ranking using corpus, which otherwise, without the use of word before, was difficult. Now I present our system architecture, ECIR2020, which is based on this paper, ECIR, published in 2015. Our system receives an input query Q and the gold sets of answers E2 star. For example, it receives the query as I discussed before. Then we pass it to an entity linker, which gives me the set of entities that include Jimmy Page, Led Zeppelin, and so on. We pass these entities in KG and corpus to derive the target type, the relation, and the candidate E2s, which can potentially be the answer. Further, from corpus, we also derive the context. For example, we get these contexts like about Page's work in Yardbird prior to Led Zeppelin. After this, we use various connets. We use query relation connet to score various relations along with query and the relation. We use query typenet to rank types, and we use query corpus connet to rank and to score the candidate E2s from each of these contexts. We aggregate the score of these corpus query connets, and then we pass all these scores to a score combination network for a final combination to score each of the extracted E2 candidates. Using an entity ranking loss, we train the score combination network for retrieval. Now, one may ask, why do we combine 3 connets to rank entity E2s? Connets have a proven ability to scan over sequence of grids to detect patterns. Various spans in queries have different scores for different routes, which can be identified by a connet. For example, band is a clear indicative of a target type T2, which is musical group. These connets can further identify relation membership by looking at the words or the phrases was in. So here I consider one segmentation of these roles, which I assign them as. So target type T2 is a band, membership is the relation. And we define an interpretation as shown in the example as one hard segmentation and labeling of roles. So this is what we refer to as interpretation in the remaining presentation. Now I'll discuss how do we train our score combination network. Remember, we have labeled instances, which are the queries and the target entities E2. We don't have the gold query interpretation, which I just discussed. We majorly consider 2 approaches which are based on different definitions of interpretation with respect to KG. In approach 1, we consider the set of entities E1, the relation, and the target type as a template, which we execute on KG to retrieve a set of entities E2, which we compare against the gold set of entities E2 star in a set-based reward, which is recall, precision, or F1. In approach 2, we include the target entity E2 in our interpretation and do a joint ranking using ranking laws like AUC and MAP. We call first approach as ECIR2020 as we just consider the top interpretation. We aggregate the score over all candidates E2 to get a per interpretation score. We rank and choose the top interpretation for inference. In approach 2, we allow unlimited number of interpretations by doing a joint ranking of the interpretation with E2 mentions. And we use a max margin loss as shown. The intuition here is in LHS, the good E2s among the best interpretations should be the best E2s for their best interpretation by a margin delta. The max formulation in RHS leads to non-convexity, and we have to go to methods like LVDT, but I'm not going over those details. You can find these details in our paper. But then we have this question, can we restrict number of interpretations to a few and see what happens? That is, we used the same laws as before, but instead of allowing unlimited interpretations, we restrict the number of interpretations to top k. We choose the best interpretation as R max over this restricted set, and we rank E2s among these sets of interpretations. Now I'll move on to results. So in the talk, I'll primarily consider natural language queries, that is track INX and wrap questions. But to cater to other forms of the queries, we considered keyword queries in our paper, which we discussed in detail in our paper. I'm skipping. Web questions are majorly answerable by KG, but in track INX, only 57% of queries are answerable by KG. So we see a corpus role, a vital role of corpus for additional evidence. Let's look at the effect of different number of interpretations on these two datasets. Here I'm plotting precision versus recall. The red cluster denotes our ECIR1 system. The green cluster denotes our ECIR few system, and the blue cluster denotes ECIR all. Clearly for track INX, ECIR all performs the best. But for web questions, ECIR1 has a better performance in terms of F1. In terms of numbers, for entity ranking, we beat state of the art by a huge margin. So you can see ECIR all beating the state of the art by a huge margin. In terms of entity set retrieval, our improvements are relatively modest. For example, on track NLQ, our ECIR in best is 32.3, which is around 10% improvement on EQ. And on WQ and LQ, our numbers are matching with the state of the art systems. The reasoning being the crude way of cutoff method that we are using to convert from entity ranking to set retrieval. And it seems like we can clearly improve this by careful thresholding, which is visible by these ECIR and all ideal thresholding numbers. Before I end the talk, I would like to discuss the heat maps and how our system is interpretable, which helps in understanding how and what it is doing. So let's consider a few QRN samples. If consider the query who started Pixar, our corpus relation connet, our relation connet focused on word who and started as compared to the word Pixar to get to the relation organization founders. This is a relatively interesting query. What movie did Rihanna play in? So in this, the word play is a little ambiguous. So our relation connet focused on word movie to detect the relation film actor instead of focusing on the word play. For QTN samples, let's consider this query. What are the major cities in France? Again, it focuses on city to understand location city sound by ignoring the word France and giving negative weights to major, which is again an ambiguous word. Similarly, what are the major languages spoken in Greece? Our QTN model focuses on the word languages as compared to major and spoken. To summarize, deep system can answer complex multi-clause queries, but the interpretable decomposition of complex queries is not provided. Transparent scoring of candidate is also a non-trivial problem for that. Homogeneous network architectures like BERT cannot identify these diverse roles of query spans. Whereas we propose our system ECIR which combines these component networks which are tailored to cater different query spans with their roles. It would be an interesting work to see how these interpretable architectures expand to complex multi-clause queries. With this, I'll pause for any questions. Thanks for attending.
Okay. Thank you very much. That's my contribution to the virtual applause. Do we have questions for the authors? Perhaps I could start if there was no questions. So my question was: we've seen a few papers. With knowledge graph embeddings during the conference. They're becoming quite popular. Is that something that how would you see that integrating into your approach?
Yeah, so we can integrate that to improve our KG retrieval, but our KG retrieval was already very good, so I don't see how much it will improve, but definitely it can be an interesting extension to include node embeddings.
I do think it would be able to help you there. Okay, we have a question from Jeff Dalton. Jeff, you can speak.
Hello, thank you very much. Really interesting talk. I hope this was, I think this paper was part of the special edition that we helped edit. So thanks for your submission there. So a lot has changed in our field in the last kind of 2 years or so since some of this work was done. How would you do some of this work over again, particularly as you mentioned some of the BERT-based architectures, all the state-of-the-art kind of question answering are all now kind of BERT-based kind of deep models. How would you kind of change and adapt this work in the kind of modern field, modern era, post BERT, I guess?
Yeah, so we can improve our like these coordinates which we use. We right now use crude embeddings, but we can improve these to BERT embeddings. I suppose we can improve our retrieval from corpus. So these deep BERT-based architectures can help there. But to make our system interpretable, we still believe to have this modularity and different training of these separate coordinates and like a different training of the joint supervision network. So I believe that these BERT models can definitely improve our extraction from the corpus.
Okay, that's really helpful. Thank you. It'd be really interesting to see where, like maybe to compare some of the modern QA systems with this work and see kind of where those key differences are and kind of where there's interesting opportunities for your system to kind of evolve and maybe do better than them. Be quite interesting to see. So, thank you.
Definitely, yeah. Thanks.
Okay. We have a little time. Are there any more questions for Sarib? Okay, so Sarib, thank you very much for that great talk, and I see that the source code is available if you email Suman.
For access of the source code, please email Suman.
Yeah, Suman. Okay, great, thank you. So shall we set up for the next talk? Okay, Abhilasha, you're still on mute. Do you want to unmute yourself? Abhilasha, do you want to unmute? Yeah. Okay. Yeah, we can hear you. So the fourth paper, the penultimate paper in the conference, is entitled "Reinforced Rewards Framework for Text Style Transfer." I thought this is a fascinating piece of work. So Abhilasha, Sanchetti, Kudan Krishna, Bala Srinivasan, and Anand Dathalu are the authors in this paper. I understand that most of them are from Adobe, as well as, of course, University of Maryland and CMU. And Abhilasha is going to present the paper. So please, when you're ready.
Thanks for the introduction, Craig. So today I'll be presenting our paper on reinforced rewards framework for textile transfer. This work was done while the two authors were at Adobe Research. Okay. deals with the algorithms to transfer the stylistic characteristics of of a piece of text from one form to another. In this work, we specifically look at transferring the style from formal to informal, modernizing Shakespearean English, or converting sentences in exciting form to non-exciting, and also the other way around. Style transfer is an active area of research these days because of its wide variety of applications in the field of content creation. The below figure here at the bottom shows the input, which is an informal input, which is I want to be on TV. It is fed into the our proposed reinforced rewards framework, and the output is a formal sentence which looks like I would like to be on television. Talking about related work in this field, we have like it could be classified into two categories, which is style transfer using parallel corpora and style transfer using non-parallel corpora. First, I'll be talking about the style transfer where parallel corpus is used. So because parallel corpus is usually difficult to obtain, there are limited work in this area, in this category. First, I'll talk about Zhu et al., which introduced a parallel corpora and then a phrase-based translation model to modernize Shakespearean English sentences. Another work by Jamtani et al. Proposed a copy-enriched sequence-to-sequence model for Shakespeareizing modern English. Our work is based on the model which was proposed by Jamtani et al. I'll talk about it later. Now, coming on to another data set which was introduced by Rao et al. More recently, and it consists of formal and informal sentence pairs, and also it benchmarks this data set using sequence-to-sequence models. Now, talking about non-parallel style transfer, work in non-parallel style transfer tasks, the Shen et al. Assumes shared latent content distribution, and then it proposes a method that leverages refined alignment of latent representations. Another work by Li et al. Defines style in terms of attributes which are localized to part of a sentence, and then it learned to disentangle style from content in an unsupervised setting. Following these works are other works as well, but what most of these work train their models on is loss, which is at word level, but the contribution of our paper is that we train our model using sentence level loss terms. This is because evaluation is being done on sentence level metrics, and in order to deal with the problem of train test evaluation mismatch, we use sentence level loss terms. Another contribution is that we optimize our model directly on the metrics of content preservation and transfer strength instead of only optimizing it over word level losses, which teach the model to generate sentences matching the reference. One more important contribution of this paper is that we use reinforced rewards framework, which looks like this, wherein we consider a base sequence-to-sequence recurrent neural network-based copy-enriched model, which was originally trained on this maximum likelihood loss, where the probability of generating each word during inference is a linear combination of the probability of that word from the recurrent neural network and the probability of just copying that word. Given the input sentence in a particular style and the ground truth sentence in another style, the sequence-to-sequence model generates an output sentence. This output sentence is then presented to a content module and a style classifier, which scores this generated sentence. So this is the sentence level score which we get from these modules. This score is considered as a reward, and then it is reinforced into the model using metric specific loss terms. The content module here ensures that the core content of the input sentence is preserved in the target transferred sentence. And in order to realize that, we leverage self-critic sequence training to optimize the framework with blue score as the reward. The loss term looks like this, wherein the first difference term ensures that the reward of the generated output is at least as good as the greedily generated output. One thing to note here is that the blue metric which we use here need not be differentiable, and any other like any other metric which can be used here. The style classifier module ensures that the generated sentence is in the target style. And for this, we train a convolutional neural network based classifier to predict the likelihood that the given sentence belongs to the target style. And then this score is formulated in terms of a loss function, and depending upon the direction of transfer, the formulation differs. So, for example, if we are converting the sentence from informal to formal, then the first formulation would be used, and the second one otherwise. We evaluate our model on 3 tasks as mentioned before. One is reinforcing formality. Second one is reinforcing excitement. And third one is beyond affective elements, which is modernizing Shakespearean English or vice versa. We use blue metric and the accuracy to evaluate our model. And we also use an overall score to see how the model performs overall. The baselines that we consider here are the base model copy NMT, which was introduced by Jamtani et al. The second baseline is the cross-aligned baseline, which is an unsupervised state-of-the-art benchmark for this task. And the third one, we train a transformer-based translation model on style transfer parallel dataset. So now I'll talk about the experiments that we have done. So the first experiment that we do is reinforcing formality, where we use the corpora introduced by Rao et al. It is a parallel corpora for formal and informal text. In order to demonstrate the improvement in performance of the model with the new loss terms that we introduce, we first do an ablation study. The first model here is the copy NMD, which is the base architecture, and it is trained only with the maximum likelihood loss. The second model here is first trained with maximum likelihood loss for a few epochs, and then it is trained with the combination of maximum likelihood and the transfer strength loss terms. Similarly, the CP model is trained initially with maximum likelihood and then with a combination of maximum likelihood and the content preservation loss terms. There is another variant where we train our model on a combination of all the 3 loss terms. There are other 2 variants as well, where we use iterative training, and we first train the model using maximum likelihood, followed by training it on a combination of maximum likelihood and transfer strength, and then on a combination of maximum likelihood and content preservation. These are the results of the ablation study, where the first row here presents the results from the baseline model. The second these 2 rows present the result for the TS and CP model. So you can observe from here that when we train our model on transfer strength loss term, the accuracy of the model increases. When we train our model only using the content preservation loss term and content preservation loss term, then our blue score, which is the metric to measure the content preservation, increases. When all the three loss terms are used, in that case, the results are kind of between the performance of TS and CP. And this shows that there is a trade-off in content preservation and transfer strength in this task of style transfer. Now, the next two models are basically the iterative variants. And we can observe from here that this model has the best transfer strength performance, and the TSCP version has the best blue score. But since we are more interested in an overall improvement of the performance, our further analysis would be based on TSCP, which has the best overall score. Next, we compare our proposed approach with the other baselines, and we can see here that that our model has the best overall score and also very good content preservation as compared to the other baselines. Although transformer has very high accuracy, but it has very low content preservation, and because we are transferring the style of the content, we would want our content to be preserved. Next, for evaluating our model on excitement transfer, because there is no data set available, we first curate our own data set using Yelp reviews. Reviews with rating greater than equals to 3 were considered as exciting sentences, and then we ask Amazon Mechanical Turkos to rewrite the exciting sentences to make them sound boring or non-exciting. And we also ask them to rate the rewrites and the given sentences on a Likert scale of 1 to 5. These are the results for the excitement task. And here also we can see that our model performs consistently better in terms of overall score and also blue score. Now, beyond effective elements, we consider transferring the either modern English to Shakespearean English or vice versa. And similarly, here also our model has better performance as compared to the other baselines. Now, apart from the automatic evaluation, we also consider doing human evaluation of the model outputs. For this, we ask Amazon Mechanical Turkos to rate the model outputs and references on Likert scale. For content preservation, we use a Likert scale of 6, and for transfer strength, we use a Likert scale of 5, and the descriptions are as given here. And each of the output is annotated by or rated by 3 annotators. These are the results from the human evaluation, wherein we can see that in at least 60% of the cases, humans prefer outputs from our model as compared to the other baselines. Now, the takeaway is that explicit optimization over metrics help in boosting the performance. We have proposed a generalized approach, and it works for a variety of style transfer tasks. And we have seen that there is a trade-off between content preservation and transfer strength, and thus we can always tweak the combination parameters alpha, beta, and gamma depending upon what the task is at hand. And as a future work, we intend to study the transfer of multiple styles simultaneously. Thanks.
Thank you, Abhilasha. So we turned your camera off during the presentation to save bandwidth, just so you know that we can't see you anymore. I think this is fascinating. As a grumpy Scotsman on a Monday morning, I'm not very good at writing exciting emails, and perhaps your techniques your models could help make my emails look more enthusiastic. But so we do have some questions.
Yeah.
I can see one from Chow Wang. Host, do you want to promote Chow? And you go ahead, Chow.
Hello.
Yep.
Thanks for talk.
Yeah, I can hear you.
I have several questions about this. So first one is, what's your action for your reinforcement learning algorithm, and what kind of reinforcement learning algorithm you used?
So since this is a like text generation setup, the action here is basically choosing a word from the vocabulary, right? And the state is basically whatever I have generated, whatever history I have generated till now, like whatever prefix I have generated till now. So action is basically the word that I'll be choosing from my vocabulary.
Okay. Okay. So the reinforcement learning algorithm, you use the reinforce, right?
Yeah, it is basically a variant of reinforce, which is SCST. Yeah, so in this case, basically the baseline is the reward for the greedily generated output.
Okay. Okay. So can you do you think the model can apply to longer input sentences, because the reward you given is based on the sentence level, meaning after you get the whole sentence, yeah. So if the sentence is too long, yeah, you can.
So we were using here recurrent neural networks, and I have observed from the results that it wasn't working very well with longer sentences, as in the maximum sentence length in our case was 25, and like I don't think if we consider like 30 or 40, then it would work really well because of the problems with RNN as well. But I think in case we consider transformer based models, then it might help there.
Okay, okay. One last question, because you used the style classifier, right? And you use the CN here. So this model is also supervised learning. How do you define the target labels? Because there are so many targets, I think.
Yeah. Yes. So we are working with parallel data sets here. So formality data set, excitement data set, and the English data set were all parallel data sets. And we know that, okay, we know which sentence belongs to which style. So that is why we train in a supervised fashion.
So there's how many, the number of your targets for this style classifier is 10 or 20?
Sorry, number of what?
The target, the classifier targets.
So this is basically a binary classifier. So for each of the tags, as in for formal and informal sentence, we have a binary classifier. For exciting and non-exciting, we have a binary classifier. Yeah.
Okay, binary. Okay. Yeah. Thank you. Thank you.
Thanks, Chow.
You're welcome.
Abhilash, I had a question. So you showed in the paper that you could make styles such as exciting, non-exciting, Shakespearean English to so could this be done at a more personal level? Could you make styles that are, could you make a piece of text read more like Craig or read more like Abhilasha? Can you make personalized models that could be learned? And so part one, and if so, should I be worried that such a tool would facilitate plagiarism by students by allowing them to take pieces of text from the internet and make it more like something that they had written?
Yeah, that is totally possible, but we only require data for this. So if I have data where I have, like, you can define style in any which way. We consider these style characteristics because of the availability of data, and there is work in transferring author styles as well. So it is possible, and this approach could work on that as well.
Could work for that task. Okay,
yeah.
Great. Thank you. Thank you for a very interesting talk.
Thank you.
Okay, if you stop sharing your screen, we can set up for the ultimate talk, the final talk in the conference. And Gustavo Pena, do you want to share your screen?
Yes. Can you see my screen?
We can see your screen, we can see you, we can hear you. So
Excellent.
this is the ultimate presentation, the final presentation in the conference. The title of the paper is Curriculum Learning Strategies, and has a subtitle, An Empirical Study on Conversation Response Ranking. And the authors are Gustavo Pena and Claudia Hoff from the University of Delft. Okay, so Gustavo, when you're ready.
Thank you for the introduction. I'm a PhD student at U Delft, being supervised by Claudia. And I'm going to talk about our paper on curriculum learning for ECIR. And first, I'm going to talk about what is curriculum learning. And the core idea is the following. So we teach students by imposing a certain order of the material that we give them. So the question is, could a machine benefit from a similar strategy? So a very interesting experiment was done by Ken et al. And they asked people to present images to a robot in their order that they believe it's going to be better for the robot to learn graspability. So the instances are here on the top. So on the left, they are highly non-graspable, like the church. On the right, they have highly graspable, like the toothbrush. And a common strategy that appeared between people was that they first showed to the robot highly non-graspable, followed by highly graspable objects, and so on. So this strategy that people followed to this robot, the interesting thing is that if you actually train a model like this, you could actually improve the performance of the model. So Benjo et al., he showed that if you first train your neural network using easy instances, and then move on to the most difficult ones on the data set during the training procedure, the final network is more effective than the one that uses randomly sample batches from both distributions. So in this example here, the easy instances are objects that are not twisted, and the difficult ones are the ones that are slightly moved and twisted. And we wanted to see if we could apply this in information retrieval. So we asked, what is difficult or easy in our context of information retrieval? And could we use this indicator to improve retrieval effectiveness using curriculum learning? And so, can you still hear me?
Yes, we can hear you. We can hear you.
Yeah. I thought something went wrong here. Okay, so before I present our strategy, we have to first set the task and the model. So the task is a very popular task these days on conversational search, which is called conversation response ranking. So the input to the model is the dialogue context, which is the previous set of utterances. So I have an example here. So the user asks, is ECIR an online conference this year? The agent answers yes, and then there's a follow-up question, how can I attend to the presentations? And the model has to rank the correct response first. So here in this case is with the Zoom and YouTube links. And the model we chose for this task, it's BERT. So basically we concatenate the query, which is the dialogue context, with the document. And we train BERT with this, we fine-tune BERT with this. And we use the scores based on the CLS token to predict the relevance of the responses. So now that we have a model and the task, we want to answer, how can we say that a conversation is difficult or not? So we propose several scoring functions to do so. So the idea is that the scoring function receives as input the dialogue context, and as output, there will be a number telling us how difficult or easy this scoring function is telling us that this conversation is. So I'm going to present the scoring functions that we proposed in the paper with different notions of difficulty of conversations. So here, this is kind of our baseline, because traditionally we wouldn't do anything with the training instances. So we get this baseline, which is just a random function. and then the batches are basically randomly selected. The first set of scoring functions are based on the query. So I have an example here of an easy conversation according to this scoring function is a short conversation. So if the conversation has only one utterance so far, the important information here is most likely in this text that the user has already said, as opposed to a difficult conversation where we have several turns, and the conversation the important part of the conversation or the information it could be spread across different turns of the conversation. We also thought about scores based only on the documents, which are the responses. So a simple proxy could be the number of words in the responses that the model has to rank. So if you have very small responses, it's possible that BERT finds this more easy to retrieve, the correct one, whereas if we have very long responses, the model could get confused in the text that it has to select between. Then we moved on to functions that are based on both the query and the document. So here we have two scoring functions that are based on this input space. And the idea here is that we use a ranking we use a retrieval, traditional retrieval model to retrieve the responses based on the query. So we have several scores for each of the response. And we say that a difficult conversation is the one that BM25 has low standard deviation, has a low standard deviation of the BM25 scores. So the idea here is that if they are very similar according to a BM25 ranker, this might be difficult. Whereas if there's one document that stands out according to BM25, maybe we already have an easy conversation to have. And the last set of scoring functions that we proposed here are the ones based on the query, the document, and the relevance labels. So we use all the available information of the train set. So what we do here is basically divided into an initial step where we train BERT, we fine-tune BERT for this training set, and then we extract from BERT a measure of difficulty based on the BERT confidence on the candidates. So I have an example here as well. So let's say we have two candidates, and BERT predicts that this response is relevant, and this response is actually relevant with a score of 1.0. And for a non-relevant response, BERT predicts that this is 0.1. So apparently BERT has given a really good gap here between the relevant and the non-relevant one. And a difficult conversation would be a conversation where BERT is still confused, even after training for some fine-tuning for some iterations. BERT still cannot distinguish between the relevant and the non-relevant documents. Then we say that this is a difficult conversation for BERT. So those are all of the scoring functions that we analyzed in the paper. So given that we have this scoring function, we still need a way to, during training, move from the easy ones according to the scoring function and go on to the difficult instances. So the framework that we proposed is inspired by previous work. So the main idea is that initially the instances are going to be randomly shuffled. And the color here indicates the scoring function. So we get these instances, the dialogues that we have to train BERT, and we sort it by the scoring function. So now the difficult conversations are on the right and the easy conversations are on the left. And what we do when we are training the model is that we have another function that controls how much of the input the model can select batches from. So in the beginning of the iterations, this function, which is in pink here, will let the model see only the initial 33% of the conversations. So here we are like starting small. So we are only training BERT with the easy conversations. And as the iterations go, this other function, that the pink function here, allows now BERT to sample batches from 50%, and at a point in time, that BERT will be able to see all instances. It will start sampling batches from the difficult ones as well. So this is the framework we analyzed in the paper. And there's this other function that we called here the pacing functions, which is basically tells us how fast should we move from the easy. So how fast this pink line goes from easy to difficult according to the iterations that we have. So in the paper, we have more details on the pacing functions. I decided to remove here because of time. So if you want more details on how to go from easy to difficult, we provide the results on the paper, but I'll go into the results, the main results of the paper, which is given by the scoring functions. So now we compared both, compare the strategies, right? The baseline, which is random, against our scoring functions using this framework here that I just presented. So the first result is for two different data sets here, METIS and MS Dialogue. They are data sets for conversation response ranking. And the number here is the mean average precision for the BERT trained normally, as we would do it with random batches. So the scoring functions is a random uniform between 0 and 1. So now we want to go on to the scoring functions that we proposed. So most of the scoring functions that we proposed, we have no statistical difference when we train BERT with curriculum learning using them against the baseline. So all of those, we could not see any difference between the numbers and the baseline. And this tells us that our intuition of what BERT thinks, what a conversation is, if a conversation is difficult to BERT or not, doesn't help curriculum learning when we use such manually defined scoring functions. And the ones that actually happen to provide statistical significance against the baseline are the random, are the BERT-based ones. So the BERT-based ones are those ones, to just remember, the ones that we first train a vanilla BERT model, and then we use this model to extract the those conversations where we think the model is having trouble, and then we train the model again with curriculum learning. So with those, we can get improvements up to like 2% just by sorting the input data, and the model is exactly the same as the one trained without curriculum learning. So to conclude my talk, so it's what I just said, that we could improve the retrieval effectiveness by up to 2% by just changing the order of the instances, which is positive evidence again that curriculum learning works in these different contexts that we have shown here, that is conversational response ranking. We also show that we better let BERT tell us what is difficult by extracting it from it, rather than finding features like query performance predictors that tells us how difficult this instance will be. And there are more findings on the paper about the pacing functions, but I'm going to talk about what we could do as future work here. So one of the questions that we could ask is whether the find is here generalized to other retrieval tasks rather other than conversational response ranking. We could see what happens if we try with ad hoc retrieval, and we could also test other rankers besides BERT to see if we find the same, we have the same findings. And finally, something that I think is really important is to try to understand why curriculum learning actually helps models. So we just sort the data differently, and during training, we follow this procedure. So why is this happening? Why are we seeing effectiveness improvements? So one hypothesis could be that, for instance, that we are filtering noise. So we might be spending less time in the noisy instances and more time on the actual good instances of the data set. But we have other hypotheses that could also be true here. And thank you for your attention. If you have any questions, I'm glad to answer.
Thank you very much. Thank you very much. I see a couple of hands asked, but first a question or comment from me. So in machine learning, we used to use boosting as a way to focus the learner to focus on more difficult instances later in the learning process. Do you think that's what's maybe happening here under your reordered learning?
Yeah, definitely. That's I didn't know about this, but definitely it's a similarity, right? Because in the end of the training, we're focusing more on the difficult instances of the training data set.
Mm-hmm. Yeah, so I think that boosting has a strong connection with what you're doing there. Okay,
Yeah.
We have 3 hands up. We have 3 minutes left in the session, so let's quickly ask the questions. We'll start with Sarawut. Sarawut, you can turn your mic on and talk when you're ready. Sarawut.
Okay, can you hear me?
Yep.
Yes.
Okay, I have a short question. Thank you for your presentation. Have you compared the result from the reward order, such as put the difficult first and the easy last?
I'm sorry, could you repeat the question?
Your order is easy to the difficult, right?
Yeah.
Have you compared to swap to reward the difficult first and the easy last?
So this is called anti-curriculum, where we start from the difficult ones and then move on to the easy. So during early experiments, I switched the order just to see what would happen, and we expect that the model would have more difficulty, so it would be less effective. And this is what happened, if I recall correctly, but we did not include those results on the paper. But this anti-curriculum strategy, what happens is the opposite of what a normal curriculum would happen. It decreases the performance of the model.
Thank you. Thank you.
Okay, thank you. Next questioner is Chow Wang from the University of Glasgow. Host, can you activate? Yeah. Chow, go ahead.
Hello?
Yep. Briefly, please.
Yeah, in my understanding, you're using this curriculum thing. So the training data is sorted using some difficulty level next to each other. So do you think this model will affect the model convergence?
Yes.
I mean, mostly we use the shuffle technique to make the model learn more robust, to learn the distribution. So I think this order could affect the convergence.
It definitely affects the convergence rate. So what previous work also showed, and we also observed here in some of our experiments, is that the final effectiveness is higher, and sometimes, or most of the times, it achieves convergence earlier during the training procedure. So some results show only earlier conversions, and at the end, both models achieve like a similar performance. And sometimes, in some cases, the final model using curriculum learning achieves both earlier convergence and also higher effectiveness. So this definitely is an important factor.
So we're nearly out of time. I just want to give Max Berendorf from LMU Munich the chance to ask his question. Very briefly, please, Max. Or the question is gone. Okay, so Max, go ahead.
Yeah, okay. Can you hear me? Yeah, right.
Yep.
Okay, maybe I make it brief. I would have a question to the BERT heuristic. So you said that you first train BERT, then you use like the confidence of BERT as a score, right?
Yep.
And then you said that you retrain the model. So do you then like use already the pre-trained BERT model, or do you reset it again to the state where you started from?
So this is a good question. So I have a slide here where I put this. So this model that we use to train the new curriculum learning model is a different model. So we kind of throw the model away that we pre-trained, that we used to extract the difficulty scores, and we start again a new model with curriculum learning. So there are like 2 steps here.
Okay, thank you.
So this concludes the Deep Learning 4 session. I just want to play you the final bit of applause on YouTube. So thank you very much to all of the speakers. That concludes this session. Please don't go away. We have the closing session, and I will hand over back to the chairs.
Thank you, Craig. George and Raphael, would you like to announce ECIR 2021?
Yes, okay. Okay. Can I share my slide?
Sure, of course, yes.
Do you see the screen?
No, you need to share the screen. You green button.
He asked me the permission. I have to restart Zoom. And
okay, maybe we can go.
Yeah, I need 1 minute.
Okay, so maybe Pablo, we can go first. What do you think, or shall we wait?
Yeah, we can start.
Yeah.
If you want. Is that okay, George? Shall we do that? Good.
Yeah, fine with me. I think it's good to wait for Raphael.
Not joined yet. So, Pablo, I'm going to give you host so you can bring people to the panel.
Good.
Okay.
Yeah, happy to get that. I'll be in control.
You're in control. So I'm going to share my screen. Okay. Raphael is back.
Yeah, here I am. I try again. Sorry for the inconvenience. Now it should work. Can you see the screen?
Very good.
Yes.
Okay, perfect. Thank you.
Beautiful.
Sorry for the issue. Okay, as maybe most of you already know, the next edition of ECIR will be held in Lucca, in Italy. It will be the 4th edition of ECIR ever held in Italy, after Rome, after Pisa, Rome, Padua, and now Lucca. Why we prepared and submitted a bid for Lucca? There are many reasons. The first of all is that Lucca is a beloved city in Tuscany. It's very nice and has an exceptional quality of life. This will be the first event, IR event ever been organized in this city, and so maybe this can attract the interest of the attendee. Lucca is quite easy to reach. You can fly to Pisa or Florence, and from Pisa or Florence airport, it's very easy to reach Lucca downtown by bus. It takes about half an hour from Pisa and something more than 1 hour from Florence, or you can even use the train. You have to change, in this case, in the Florence station. Once you are there, Lucca is very welcoming and easy to explore. You do not need at all public transportation, because everything is at walking distance, and the historical city is surrounded by ancient walls, and the life of the city is within the ancient walls. It is even a perfect gateway for reaching interesting attraction in the region. You see in this slide a lot of destinations that can be easily reached from Lucca in 1 hour or something like this in the same day, anyway, in any case. And what I want to do is to update the community about the status of the organization of ECIR2021. We already choose we have a location, an historical location within the ancient wall of Lucca. The location is the campus of IMT. IMT is an excellence school providing PhDs, school for computer science, economics, cultural heritage, and psychoneurology. And he is an ancient convent that was exceptionally restored in 5-6 years ago. And so the main room in which the conference will be held are 2 churches, and they have a lot of nice facilities. All is cabled. We have internet connection. We have the canteen. We have all services in a modern campus, university campus. And we hope to have also the involvement of the student from the IMT school that can help in the organization in the supporting the event. We have also the place for the social event, for the social dinner, in the unfortunate case that we will have a physical conference. That is our hypothesis by now. We'll see. And we have already in place the website at the address ECIR2021.eu. You can browse the site, and we have some information already there. And we have the media channels in place, also on Twitter and Facebook. And so that's all. And we are going to organize to decide which is the key people in. We have already some preliminary key people in, for the chair that are myself and Fabrizio Sebastiani, and the program chair, that's our George, and Hemstra and Marie-Francis Moen from, and maybe George is online, that he want to spend a few words about the call for PayPal and the news and the goals that we aim with this edition of ECIR 2021. Can maybe that we can. Okay, I see.
Yeah.
He's connected.
Thank you, Rafaela.
Okay.
All right. Yeah, we want to take this opportunity to share our vision on where ECIR should be headed and how you can help. So yesterday, Jamie Kellen noted that fundamental improvements in IR are coming from natural language processing and machine learning, and that the IR community is reacting more than leading. And we think Jamie is right. We need to be leading again. So in our call for papers, we want to reach out more to the NLP and ML communities and enable cross-fertilization between IR, NLP, and ML. Second, we want to reach out to researchers from low-income countries, such as researchers from Africa, but also, because we're a European conference, researchers from Eastern Europe. I'm not sure if you ever participated in an NLP conference, you may have noticed that their communities has grown much bigger than ours in the last years, and also much more diverse. For instance, there's multiple well-known researchers from Eastern Europe that are writing papers and organizing events. Another thing that the NLP community does better, I don't want to, well, better is that their papers are available online, free of charge. Our papers are still locked up between paywalls, behind paywalls. And well, research has shown that open access papers are downloaded more, they are cited more, and they are just have a bigger impact. So the third thing that we would like to do while organizing ECIR 2021 is to start a discussion on how to transition the IR literature, including the ECIR proceedings, to an open access publishing model. So for this discussion, we want to involve you, the IR community, the BCS RSG and ACM SIG IR into this in this discussion. I want to take this opportunity to ask you to support these changes, or as Jamie Kellen put it, so how we put it yesterday, we need to up our game. Thank you.
Thank you.
I really enjoyed ECIR this year. It was great.
Thank you. That's all. Further information will be published on the website and on the social media channels. And as a last thing, I want to thank the organizer and all the team of ECIR 2020. It was a really exciting conference. It was my first online conference, and I was very happy to be on the other side of the organization and to attend the conference instead of managing all the difficulties that you had. Anyway, I think that you did a great job, and the conference was really enjoyable. I appreciated a lot all the talks I attended. Thank you.
Thank you.
Thank you, Rafaela.
Thank you very much, Rafaela. Rafael, can I share my screen now, Rafaela? Sure. You need to stop. Okay, perfect now. Give me just a minute. Okay, so so Pablo and I, so we would like to start by congratulating everyone in ECIR. So both authors, organizers, and session chairs. So it involved a lot of preparation and rehearsal. So this was a lot of hard work that at some point had to be shifted to online only. But nevertheless, we managed to have amazing keynotes with Chirac, Joanna, and Jamie. So the keynotes were actually the top in terms of audience. Those were the moments when we got more people watching on Zoom and on YouTube, so that was a very positive thing. The award ceremony was amazing, so it was slightly different this year, as you can see here, but then again, everything was different this year. Also, we had the Test of Time Award, where Stephen Robertson, founding father of ECIR, was present to give the Test of Time Award. So this was a big moment. We had the artistic moments. Julio's, we didn't think about this, Pablo, right? But we should have thought about an award for the most beautiful presentation.
The most innovative presentation, sure.
Yeah. So this was really fantastic. So Julio managed to integrate his video with the presentation. Jeff Dalton at social event, so he was very keen on sharing his dinner with all of us, but the lockdown didn't allow for that. So we also had the social event at the Mozilla Hubs. For those of you who tried, I think you all enjoyed that, and it was something different to relax. The panel this afternoon was really fantastic, and fortunately we didn't have more time to discuss all the issues that still lingered from that discussion. And behind the scenes, this is how ECIR was for us. So you always saw us with the background that we are showing now, but actually there was a lot of work from everyone, and not just Lisbon. So this time people were in Lisbon, in Madrid, like Pablo, of course, but we also had people in Pittsburgh, like Gustavo, and Brussels, Felipe. So people actually helped us from all over the place, and we all looked like VJs or YouTubers. So this may be our second occupation now. So to conclude, we ran some a questionnaire today, and we have the statistics, but actually the more interesting bits were the comments that you wrote, and we actually had probably 50% or more of people wrote suggestions and made comments. These were very this was a very positive feedback. So the first one, and this one is something we cannot solve, is so people complain about time zones. Okay, so waking up at 3 a.m. is not good in Toronto. Okay, but well, there's not much we can do about this, right? At least if you want to attend live. Otherwise, you can always go to the YouTube video and watch it offline. So in terms of the positive feedback, so this attendee wrote that I am impressed how smoothly the conference ran. The organizer did a terrific job of pivoting quickly to an online conference. They made it look easy, although I'm sure that, yeah, well, thank you very much. Thank you very much. So this is very positive. The Mozilla Hubs, this was a virtual environment where you could have an avatar to play with people. If you don't try it, then you can still try there. Try it. It's in the social event page. So another comment was that YouTube was a much better option than Zoom. So this is a feedback that we got. And also in this graph, you can see the number of views per day. And the red square just shows the live transmission of the conference. So we had those peak hours. This was yesterday. So the peak hour was the award ceremony, and the peak before that one was the keynote by Jamie yesterday here, okay? And this was people that watched it offline, so probably people that woke up, like this first attendee that he complained that the conference started at 3 a.m. for him, so he probably started watching the video here later when he woke up. So on the negative aspect, so I think we all missed this. We all missed the fact that we didn't get the face-to-face and the interaction. So we are social, so we want to socialize, and conferences are important for that. So this is something that video conferences can help, but they don't replace the physical aspect of the conference. And so the other negative point that we picked was the short paper sessions. Handling should be rethought. It was not very practical to browse videos on YouTube. Maybe having 30 seconds, 1 minute spotlight. It was not easy. Believe us, it was not easy to accommodate the short papers and the demos. And this was what we thought at the time to be the best idea to do that. We now have other ideas, but ECIR is now over, and so other conferences can pick up in those ideas. So last but not least, so we had an amazing suggestion by Aryan. So Aryan suggested to interview people. So this is one of the comments that we got from attendees. So thank you very much, and we will think about doing interviews. Who knows? Let's see. And now, who knows if Lisbon is going to host someday ECIR? This year it was not possible, but who knows if it will be possible in the next 10 years. Let's see what the future holds. And to conclude, I need to thank and to Pablo.
Sure, yeah. I would just like to say a few words. I'd like to join Joao in thanking and congratulating everyone. It's been an amazing experience. Okay. Everyone has been incredibly supportive and cooperative and innovative. The organizers, the presenters, the session chairs, the attendees. So I think this has been a challenge for everyone, not just us. And I think everyone has taken the challenge and clearly done their best. So for this, I really want to thank and congratulate everyone. In spite of the lack of physical presence, I must say, at least I speak for myself, I have felt some kind of sense of presence and participation and intensity all along. And finally, I hope that, of course, you have enjoyed this one conference, and that I hope that we have contributed something for the next upcoming conferences that are likely going to be either fully or partially online. So again, thanks everyone.
Yeah. So I would like to second what Pablo just said, and I also need to thank Pablo because it has been amazing to work with Pablo, and not just amazing, but it has been a pleasure, and I definitely learned a lot with Pablo. And,
well, sorry.
Sorry,
I have to say that I have to say the same. I mean, it's been yeah, an incredible experience. I have to thank you, Joao, for this. And I have to say, in the middle of everything, I think it's been fun at more than one moment.
Yeah. And so,
Joao, Emin wants to talk.
Sure. Emin, go ahead.
Emin?
Sorry, it was to make me a panelist, not to talk. Thank you.
Oh.
But I would like to thank everyone as well. I think it's been.
Will you please move him into panelists?
Then.
Yeah, I mean, you can turn on your camera.
If you see your name here, can you raise your hand? And if you're in the attendees list?
Sorry, how do we raise our hand?
No, Vanessa, I think
Vanessa.
you're a panelist. Yeah, you are.
You are in the stage, Vanessa. You can turn on your camera. Hey.
Emin?
Yes.
Go ahead now.
Sorry, I'm just.
You can switch on your camera.
Yes, if I may chip in while Emin gets ready. Here is Stefan Rüger from
Stefan, your camera is off.
Yes, first of all, apologies. My camera hasn't outlived the hard work in ECIR, so it just broke. So apologies for not being able to switch my camera on. But I wanted to, I think everyone else has beaten me to give my utmost thanks to the organizers, to the chairs, to Joao, to Christina and to Pablo for having organized such a wonderful conference. And please let me thank you on behalf of BCS IRSG, who steers the ECIR conference series. This was one of the most difficult years that we had, given the circumstances. And I have to say that Joao and his team did a great job of recognizing early on what was happening and of servicing the community with open access publications, a wonderful novelty here in ECIR, and also with such a slick organization of the talks and everything. So hats off to you, hats off to all the team. This has been a really enjoyable experience for me and for everyone else I spoke to. You did a wonderful job. Thank you very, very much.
Okay, so
Thank
can
you,
I
Stefan.
ask now everyone in the organization to switch on the camera? And if there is someone in the attendees that was also in the organization, can you please raise your hand? No? Good, so
They're all here.
ready to go. We can take the picture now.
Can you stop sharing your screen so you can take the picture?
I am taking the picture.
Yeah. But while sharing.
Now let me who we just asked. Okay, hold on. And now all of you can see, so the happy organizers. Hold on. Yay! Guys, thank you all. And George and Rafaela, happy and good luck with ECIR 2021. I'm sure you're going to be luckier than we were. So, but
thank you, Joe.
We still hope to see some live presentations. But YouTube and all that.
We're looking forward to next year.
Yes.
Thank you. Grazie, guys.
Okay.
I need to save all this. Sorry, guys.
So Joao, what are we going to do now?
I don't know. I don't know.
No, either. Shall we have a meeting tomorrow? I don't know.
Yeah, we need some adrenaline. Now it's not
You can be
I'll
proud.
call you tonight. I'll call you tonight.
Yeah, we still need to finish a lot of things. Some of so the move to online was not just the video, but we also decided to make the proceedings open access through Springer. We had an idea. This was discussed in September of going open access, but that was not possible. But now, given all the circumstances, we can go open access with Springer. So that was a way of, because at the end of the day, science is what matters in ECIR, and so we want to make the science that was produced this year to make it completely available to everyone. And so that is one of the changes that were introduced in the last minute. Not last minute, but last month, literally last month. So
Will they stay open access, Joe?
Sorry?
Will they stay open access?
So they were not open access from the start, because Springer needed like 1 month to do that. But we are in conversations with them, so we are doing that to have them open access. So there are some bureaucracies to go on now, because we need to repeat some of the processes. Okay, some of the things that were done for the regular proceedings, we have to repeat them. But that is the plan that is currently ongoing.
Okay, that's really great. Yeah.
Yeah.
So I have a question. So in
very
terms,
interesting, Jory, because I share exactly the same opinion as you just outlined here, and I had the same position. Okay.
Yeah. Fabrizio and I happened to discuss this at ECIR, and I think we might be in the opportunity to make some real changes. So yeah, that's well done. Yeah.
I have a quick question. The online conference format is actually super nice. Like, I mean, there is a huge benefit to being present in person with people, but this makes it the conference accessible to many people who cannot travel for a variety of reasons, whether it's, personal or professional. And I'm wondering if we could continue, even after the COVID situation has resolved, if we could continue having some form of online conference, so that people, just to make the conferences in general more accessible to everyone. Because I think it's, there's not really a replacement to being physically present with people, but if you can't be, then it's better to have some kind of online presence, and this works quite well. I think that it would benefit early career researchers who don't have the funding to go to the conferences. It would benefit industry people whose jobs won't fund them to go to conferences or pay for publications, and it would be a way of just making the science available to people, and I think that would be a really good thing.
I will support that. That's really very important thing, particularly people from developing world who cannot afford to travel at all. So that will make IR events more inclusive.
Yeah. And there's also the issue of the carbon footprint. So saving a lot of flight travel could also be a good thing to think of in the future. And that's one way to reduce that. Definitely.
I think we can offer half reduced price for online registration if you want.
Yeah, to cover the costs of doing that. But so for instance, this is a conference that Amazon would have probably not funded my travel to, but it's a great conference to attend. And so it'd be really good to have this option. And if we could pay for, online attendance, a large part of my group could attend the talks and so forth for this conference that would never be able to attend otherwise. And I think that would be super great. I would like to see that continue. So, I mean, this forcing function to get everybody to figure out how to do it, I think it's actually a good thing, and we should continue it regardless of, the pandemic situation.
Yes, I agree, Vanessa. Yes, Stefan. And in fact, one of the intermediate steps was that Joao, when he realized that some countries were having flight restrictions, he already planned for a partial online participation or presentation mode. And I personally believe this should become optional in the conferences in the future. And for the same reason that you said, Vanessa.
Yeah, and I think that once this becomes more normal, people will find ways to engage one-on-one and personally with people that they just hadn't thought of before because they're unfamiliar with the format. But once it becomes a normal thing, then like we're having this conversation now, it feels very personal. It doesn't feel like I'm, you know, observing something that I don't have involvement in. So I think it would be a driver for making this just maybe even a better format. With the ECIR PC meeting, having it fully online made it more democratic, because usually the PC meetings, the papers are sort of decided by the 5 or 10 people that are present. And in this case, we had, you know, sort of 80 people able to participate in that and put their 2 cents in on those papers. And I thought that was a really great thing.
I'm promoting everyone to panelists to enter the discussion. Ideally as well.
What a fantastic thing to do. I was just going to say that the poor attendees, they can't talk now.
No, they are not leaving. They are being promoted to panelists.
Fantastic.
That's the
one by one. Thank you, João. One by
one. Well, sorry, but this is something we wouldn't be able to do in the physical conference. So not everyone would fit in on stage. So, but here, okay, fair enough. Not everyone fits in one page. We have to go to the second page, but still, not bad.
Given the many screens that you showed us a couple of minutes ago, Joao, it surely will be possible to fit all the participants on the screens that you have.
No. I can no longer find myself here.
Getting there.
If you dye your hair blue, it makes it easier.
You have a point there.
I would just like to point out to these answers. I don't know if you can see some of the more interesting.
This was Rui's idea. He wanted to get all your feedback, and he got. So
122. It's nice.
Rui,
yeah.
Can you? Okay, you're bringing everyone else. Oh, Dia.
I'm gonna stop sharing. I just want to. I'm gonna promote 9 more.
What does the 1 mean? Is that no and 5 is yes? What is the?
1 is strongly disagree. 5 is strongly agree.
Okay, so people want to have the option to attend online, but they don't actually want to attend online.
Yeah.
Okay.
I think people like watching the talks on YouTube. I think that was the most positive thing that we got out of the questionnaire. And maybe the fact that then people are there physically available to discuss what they just saw on YouTube. I think this was a very good thing. So there was a big decision that we had to do, which was not to let full paper authors submit a video, because we predicted that would reduce engagement among people. And so we asked authors to present their paper live. And this meant that Pablo had an amount of work to sort people by their time zone. So this was a lot of work to put authors from Asia in the morning and authors from America in the afternoon. So Emin and Joman had done the scientific organization, but then we had to resort everything, not everything, but just a few, right? But still.
The amazing thing is that it was actually possible because there was such so many papers from Asia and Australia and the US that still, yeah, somehow everything fit together.
Guys, since we are all online on stage, we could unmute our screen and do a big clap live to Joao, Pablo, and all the organizing team.
Finally.
I also need to make a special thank, which is to Dia. So Dia was the best sponsorship chair that we could have imagined. Well, I cannot see Dia.
Hello.
Hey. Hey, Dia.
Here you are.
Hey.
No, thanks for having me. It was a great pleasure to work with you.
Thank you.
Yeah, so Dia managed to get a very good sponsor and in number as well, so that I couldn't even close everything with all of them. So we still need to go back to them, but this was really, and in part that is what will help us have the open access and still refund people that way. So, and there's still one attendee. No, come on. Yeah, you have to.
Empty.
I see there one.
It says one, but I can see it.
Oh, you're right.
Me. Sorry, I didn't realize I was meant to be away. I thought it was an open discussion. I could just join in.
You can.
No. So you had the attendee role throughout the conference.
Yes.
But now you have the panelist role.
Everyone was promoted. Yeah.
Everyone was promoted.
Yeah.
So, yeah.
Okay. I just wanted to say, well done to Dia and everyone else.
I don't know if Laura Dietz is here. She was asking why Springer, why not PDFs in how's she saying? Why not PDFs in a web server?
That's a good question. I can talk about that with George and Stefan. That's
and Vanessa is answering. Maybe you want to answer, Vanessa?
Yeah, I was just wondering. So this is outside of my area because I'm not an academic, and none of the publications count towards anything other than personal gratification for me. But I'm just wondering, if you make something completely open access and put it on archive or someplace, does it matter? Does it make any difference to whether that counts towards a publication in the view of your university? I would hate to make a decision like that and then have people fail at their tenure cases because they didn't have enough publications. And I'm asking that because I know in some universities they put a high priority on like journal publications and conferences don't count as much, for instance. So they can be kind of picky about these things, and I don't know how the system works.
I think as long as there is, as long as there is some peer review process, I think whether it's open access or not, or there is what is the publisher behind, I think would not be that important. I believe, at least in my case in Spain, I think that would be the case. It's true that in Spain, for instance, the journals are disproportionately more recognized than conferences, but conferences are recognized as well. And I think it's the peer review process that matters, I believe.
If you see in the field of computer science, so the conferences that have higher impact, they are open access. You have NIPS, it's open access. CVPR, it's IEEE, but it's also open access. And well, ACL as well, like George mentioned. But I think it has to do with the citations of papers, the impact of the conference that is more. I guess it depends from country to country.
Is there a difference? Is there a difference between open access and through a publisher like Springer and open access where we just put it all on archive or on a web server somewhere? Does that matter in terms of how the paper is regarded by institutions?
Yeah, I mean, I think the issue is that the paper have been accepted through some peer review process. And someone also mentioned the issue of the conference rankings, which in some countries I think is really, really important. It's the case in many countries in Europe, at least, and in Australia as well, I guess.
And it's not only a matter of conference ranking. You also need to be indexed by citation databases, especially in Italy, like Scopus or Web of Science, because they are officially used for promotions at national level and then local level. So if you just put it on archive, it will not work, simply.
If I can intervene, I think there are multiple dimensions beyond the ones that we are discussing now, because we also have the competition among the universities on the Shanghai rankings and stuff like that. And I agree that within our departments, probably we don't care very much if it is an ACL paper, a conference paper, or it is a journal paper, but go explain that to the physics people, and then you have an issue. So for the individual promotion, maybe it's not that relevant, but if you are trying to promote your department within your school or promote your university, then the journal publications will matter. That's also an issue.
I've had friends who had to turn entirely to journal publishing in order to make any case for tenure because their university would not recognize any conference paper. And that's a little, I guess the benefit of a journal article is that you don't have to travel to a conference to get it published. But on the other hand, you know, I'm all for open access and I would love to just see everything on archive, but I would not want to make that decision based on, you know, the fact that I have no connection to the tenure system.
Yeah, so Simon, so we discussed this a bit for ECIR 2021, and I think that the Springer LNCS is for some universities counted more than the average conference. So yeah, that's something we should take into consideration.
I wanted to chime in on what Nicola said, and I think that it's very important that whatever the news publication, the papers
going to one thing that was discussed was that going open access then involves some practical issues that are not easy to address. Because ACL, for example, it has its own foundation, and ECIR is BCS. So this needs to be handled by the steering committee because we want the conference to improve the reputation, and some steps are risky, and so Springer is the smoothest change in the direction of open access. So that's probably my experience of that. So
maybe just a small thing. I see we are constantly coming back to reputation system and so on. And I think what CORE is doing, Mark Sanderson and Australian people, to my understanding, that's the only actually ranking that we fall on, you know, like when we need to see which is a A-star conference, A, B, and so on. So would something be possible actually on, I would say, international level, you know, like, because we use CORE as some sort of semi-official conference ranking. I think the latest one that they have is from 2018 or so. Would we as a community, and meaning as computer science community, be able actually, and this would be really something good for the IR community, to come up with something that's even more centralized, maintained by, now that's the difficult part, who should be the maintainer, you know, like, but CORE is a good starting point, actually, make it more, I would say, prominent, and, you know, that would at least help sort this reputation problem.
Yeah. I don't know how it is in other places, but in Portugal we look at CORE, but then we are allowed to make a few adjustments, not many, but a few adjustments. Okay, so for example, a national conference, we are allowed to give like a B or something like that, because it's national, and so it's important for the community, for the national community, and so we are allowed to do that. But the base is the CORE. The base is still the CORE, and CIMAGO. At least in Nova University, it's CORE and CIMAGO. In Universidade de Lisboa, I'm not sure, and Porto. So, and you don't know. Okay. So, Pablo, would you like to say? Yeah. Wow, Aryan.
Sorry?
Aryan, just.
Oh.
You see Aryan's video?
Oh, yeah. Thank you, Aryan.
Aryan received the Best Music Award in ECIR.
Okay. Pablo, would you like to say some?
Yeah. I mean, it's been fantastic to see you all. It's fantastic to see you now. So, yeah, I'm personally, I'm happy how things have gone. Yeah, thank you all again, and I hope to see you soon on Zoom or and hopefully in person, not before long. I mean.
Yes.
And now you will have to press leave meeting.
Bye, guys.
Bye.
Good job,
Bye.
guys. Great job.
Bye.
Thank you, everybody.
Again and again.
Bye.
Bye-bye. Bye-bye.
Bye, everyone.
Então, fica como share.
Força, Rui. Podes dar uma festa aí até isto acabar.
Bem, vamos se calhar terminar isto.
Vamos,
Vou terminar a gravação.
Está no YouTube. Tchau, tchau.
Bem, foi o final do ECIR de 2020, agora a terminar em português. Espero que tenham gostado e até para o ano, Itália. Lucca. Ok.